Hey, thank you for joining us. My name is Ken Merritt, and we want to spend the next few minutes introducing you to our fully integrated advanced CAM solution for SolidWorks. Now, one of the greatest modern advancements is happening with multifunction advanced mill turn and Swiss type machine centers. SolidCAM is committed to leading the industry with the best programming solutions for these complex machines, as well as all the other machines in your arsenal.
Major technological advancements in today's CNC machining industry have led to a convergence of milling machine operations and turning or lathe operations all into one machine that can do all operations. These new, very advanced machines, called mill turn machines, have pushed efficiency to the extreme by eliminating multiple setups as well as the need for numerous mills and lathes. They provide a one-stop part completion station that handles even the most complex parts and geometry. These machines are now the fastest growing segment of the CNC machine tool market, with record numbers being purchased. One even more specialized machine, the Swiss type, has evolved to include an incredibly powerful array of tool stations, turrets, as well as spindles where multiple parts can simultaneously be machined. Now that you've seen all the power of SolidCAM in action on one of these advanced machines, let's take a look at how we program them using SolidCAM. SolidCAM is a fully integrated and gold certified CAM solution partner for SolidWorks, and therefore we ride directly inside the UI. We just have our own browser manager here. And within that browser manager, we have all the features that are necessary for us to basically set up and manage the entire CAM project and output the code to the machine. Okay, let's take a quick look at our machine definition. The machine definition is a part of the post-processor. This one's for a Citizen L32 advanced Swiss type mill turn machine. Basically, this gives us the ability to identify the entire mechanical kinematics of the machine, including the axis alignments and stackings, the machine's sub-machines, alignments of components that work with each other, the channel distributions, what gets output on channel 1, 2, 3, however many we have, and of course the axis patterns, which are the axis distributions across those channels, which ones are normal, default, and forbidden. Of course, we have coordinate system managers, stock and target, things of that nature, so we can kind of do the project setup and get everything organized and oriented properly. Then we have this updated stock module. This is really powerful. We don't want to waste time cutting in the air. So what we do is we automatically update the stock for each operation throughout the entire project, and all of our toolpaths then can work from that updated stock definition. So if I drag this icon down here, you can see the machining as it begins to apply with a knowledge of where the stock currently exists. Now this is also a great visual aid. And then of course we have the operations manager. Now the operations manager is where we're going to set up the ordering of the toolpaths and what sub-machines and what fixtures and components and so forth can be set up. But this also gives us a linear timeline style alignment. SolidCAM works with the Command Manager ribbon also. We've grouped all of our operations into this operations node, so if you want to select them from there, you can, but we've also broken them out into each of the subdivisions like 2D, automatic feature recognition, three-dimensional, multi-axis, 4 and 5 axis simultaneous type stuff, and what we're going to be kind of working with today is the turning area. Now, a lot of the toolpaths that are scattered throughout those different areas are very, very powerful toolpaths. Just some of the ones here in the turning. We've got tricoidal turning, we've got balanced roughing, we have simultaneous tilted turning when the machine supports it. We also have these MCOs and the channel synchronization manager. We'll talk about that one in just a moment. An MCO is a machine control operation. So let's scroll down here and take a look at one. This MCO right here is responsible for pre-positioning the subspindle for the part catch. In these parameters here, I can see the Z-rapid position, the clamp position, and so forth. And these are nice, but I'm guessing at numbers here, and what do I want to wrap it up to? What I could do is I can go into the machine view, and this gives us a lot of power of visual alignment. If I pick in this field, notice that it moved to that condition and is showing me the exact pick-off of that part. Now, I can put my cursor, this is the Z2 axis, by the way, remember we talked about that earlier, and I can move this by rolling the scroll wheel on my mouse. If I want to align it to, okay, I want to come up to there, I feel comfortable rapiding to there, and then I want to go ahead and feed in for the rest of the pick position, then notice the value here now. I could simply take that position, paste that axis value in here, and change where I want to have that running. So it makes a very easy way to visually see what we're doing while we're actually programming the toolpath. We have a channel synchronization manager that gives us a very, very comfortable view of how the operations are run in channel 1 and in channel 2. Okay? Now, these black lines are the weight codes for the output to the G code. And so we want to make sure those are lined up with where we want to synchronize different operations, throughout all of this. It's also very easy to change the synchronization. Let's say I wanted to take this main spindle OD and I wanted to line it up with this operation instead. So I'm going to click on both of those, and then I'm going to simply go up and hit this button, and it's going to assign a weight code to move those into synchronization with each other. Now we can simulate from in here, but let's go ahead and post the code. I want you to kind of see how this runs. So we're going to post the code out. And now you can see that the toolpath has been output to the G-code. This is our channel 1 alignment. This is channel 2. And as we scroll down through here, you can see these yellow bars line up exactly with the black bars in our channel manager. And so we can see the movement that we did in the resynchronizing these two operations with each other. We can go down further and see the different sync codes here. And it gives us a real clean way of seeing the output code. When you're working with these advanced machines, it's very helpful to have a robust simulation system. Make sure you set on the operations node and then choose SolidCAM simulation mode. Notice we have several different types of simulation. We're going to look at machine simulation right now. And you can see that SolidCAM's machine simulation has many different capabilities and features that are very helpful. Now, I like to have the move list loaded up. I also like the axis controls available, so I can move them around if I need to. In this visualization, we can see as much of this machine as we would like to see, or we can actually turn the housing off so that we can see the motion components. Another powerful feature is to be able to set this up for viewports. Personally, I like the 3-port view. In each of these ports, we can set the orientation and the zoom. In this case here, I'd like to see the front view so I can look directly at this main spindle. In this view, I like looking down at the top so I can see the sub-spindle. And so we'll move that up into a good zoom. Now let's take a look at the run. So we can start the run, and SolidCAM simulation will show us all of the tools, all of the different components, and how they're going to be interacting with each other throughout this runtime. I'm going to go ahead and pause that for a moment. Notice here it's moving through the move list. We also have the ability to advance to a given operation and take a look at how that's going to work. The system will update the stock removal and move the components into the position ready for that operation. Now in this case, I want to zoom up on this. I want to look at both the main and the sub spindle and see how they're going to be doing their work. So let's bring this one up. Now this one is a little bit hidden by the tool post, so we could very easily shift it over into a different angle and zoom up so we could see the motion going on here. Let's go ahead and run this. And again, excellent simulation of what the machine is going to be doing during these operations, and this can be done for each individual operation or for the entire set of operations. Very nice feature to be able to look at when you're working with advanced machines. All right, SolidCAM has a lot of different toolpath strategies that really can optimize machine time, your cycle time out at the machine, as we've seen kind of with the synchronization on the advanced mill turn and Swiss type machines. I also want to talk a little bit about how SolidCAM can really help you optimize time in the engineering office as well, by allowing you to create automation strategies that you can then use from one project to the next. So we have a lot of automatic feature recognition functionality, but I also want to talk about our templates. So I'm going to go ahead and open up this iMachining operation. Now, once you've gone through an operation and you've established your geometry, set your tools, set your levels for machining. In the case of iMachining, you've set the wizard to run where you want the technology to run, and so forth. Once you get all this set up, then you can actually save this as a template. Now, this works for any of the operations inside SolidCAM. You can even save tool data and include geometry filters as well. So this makes this a very, very powerful way to automate a strategy. Now, in this case, we've run the toolpath around the outside of the part. But let's go ahead and take a look at some of our templates in here. I've got this opened up to the iMachining area. I'm going to grab this. This is what I call a rough and finish toolpath, and I'm simply going to drag this and drop it onto this face. And SolidCAM is going to immediately begin processing that toolpath information, including the tools and the geometry selection, to create that toolpath for us. Really powerful features. I can also take this, hold my control key, drop it here, here, and here, and it'll do that for multiple faces as well. So you can see, once you've built some strategies that you like to use for different scenarios, it's really easy to bring those in and drag and drop them. Now, another area that can be very powerful for you is what we call our hole wizard area. Now, this hole wizard icon here allows me to simply drag this and drop this to a SolidWorks hole wizard feature, and SolidCAM will automatically compute all of the necessary details, including creating the tools for machining that. Notice over here, this has done a spot drill operation, a drilling operation, and a tapping operation. And so it takes care of that very quickly for you. It's also very easy for you to configure these and to edit them going forward. Well, we have talked a little bit today about the gold certification and full integration of SolidCAM into SolidWorks. So let's take a look at what that means for us relative to associativity. In this particular part file, we've created several toolpaths on this job, and I want to take a look at how we can manage that across a family of parts using configurations. As we establish some foundational settings in the system, we can set it up to do automatic recalculation and resynchronization. So really all I have to do is go to this second configuration, double click on it, notice the model updates, okay, and then SolidCAM immediately begins recalculating the toolpaths, synchronizing them to the new geometry dimensions. Notice the window in the front there changed size pretty dramatically. And very quickly, we have set the toolpaths up for the next member of the family. Let's take another look at that. Let's go to the third one and see what happens here. And again, a huge size change, dimensional repositionings, all kinds of things like that. And SolidCAM makes quick work of going through all of the entity IDs, tracking all the geometry associations, and reconfiguring all those toolpaths immediately for those. So you can literally work through this project, select on one of the configurations, generate G-code, send it to the machine, go to the next configuration, generate the G-code for that one, send that to the machine too. Well, we were talking a little bit about iMachining earlier, but let me kind of show you what it is and what it does. iMachining is SolidCAM's patented material roughing toolpath. And there's a lot of wannabes out there, but we actually maintain 7 patent claims on this technology, and this is truly a different toolpath than anything else that you've ever seen. So we use this particular machine that you see here at trade shows. This helps us get in and out of trade shows very easily, and it gives us an opportunity to show what SolidCAM can do even with small tools on a light-duty machine. This is a desktop CNC. It's on a cart on rollers and sitting, of course, on the carpeted floor at the trade show. But we do some pretty impressive stuff here. So let me tell you a little bit about this. This is a 3-horsepower spindle. This tool is a 3/16" diameter tool that's just under 5 millimeters. And we're going to be going 3/8 of an inch, just under 10 millimeters, deep in mild steel. Let's go ahead and get this started. And what you're going to see here, we're going to helix into this material at 16,000 RPM, 2 degrees helical angle, 150 inches per minute. feed rate. We're going to go 3/8 of an inch deep, and then we're going to take off at 18,000 RPM, just over 300 inches a minute, and we're going to machine this pocket out very, very rapidly. Now the amazing thing, listen to the sound as this is cutting. Notice it's a very, very consistent sound. The load on this spindle is only running at 47%. Now remember, this is a 3 horsepower spindle, but this spindle actually runs at 23% spindle load when it's just running at 18,000 RPM in the air. So this is only a 24% delta for spindle load on a 3 horsepower spindle. The other amazing thing about this was we cut one of these pockets about every 10 minutes throughout the entire duration of the show, and this tool lasted us a day and a half at this performance level. Now the only reason we pulled it out was because it was getting a little bit warm when we reached in to touch it after it was done cutting. Normally it runs pretty much room temperature, but after a day and a half at this performance, it was starting to get a little warm to the touch. Pretty interesting stuff. The chip thickness in this is amazingly stable, and therefore the load on the tool is extremely stable throughout the entire run. If you'd like to see some more information about SolidCAM's iMachining, please connect with us at www.solidcam.com.
Hello, everybody, and hi, Natalie.
Hello, Linda. Hello, everyone. You know, Linda, I woke up this morning with a magical feeling in the air. You also feel it?
Well, you know, Natalie, you hit the nail right on the head. It felt so magical.
Yes, it is. So, should we launch today's event?
Let's do it.
Welcome to SolidCAM World 2022.
You know, Natalie, I was telling Emil the other day that the SolidCAM software is advancing so fast that we could make a summit every 6 months. And don't get me wrong, I cannot wait to go back to our resellers like we used to every year. But on the other hand, so many more people, including customers and prospects, can also watch these exciting presentations.
You know what? You are right. Our 3rd summit in 2 years. Wow. But you know, we do have a lot of new exciting features to talk about, like the upcoming SolidCAM 2022, the Solid Metal Marketplace, the Solid Cloud product, and even additive manufacturing. Let me tell you something else. Emil talks about iMachining in every summit, how it saves cycle time, increases tool life, and automatically calculates optimal speeds and feeds with its unique wizard and so many more advantages that I really cannot believe how a SolidCAM CNC machine shop customer can do without iMachining.
You know, today there are many SolidCAM CNC machine shops still without iMachining. I think every iMachinist today knows the advantages of iMachining, and if anyone has the least doubt about it, there'll be a fascinating presentation by Anthony Calderon, our CTO of iMachining.
That would be great. Also, 2 new presentations will be given by David about the Solid Cloud product and Solid Metal Marketplace. The advantage of saving data on the cloud is the cutting edge of technology now. Right. And now SolidCAM has enabled its customers to do this.
Now that you mentioned Solid Metal, let me say what it is in a few words. Solid Metal is an interactive cloud-based marketplace that generates a medium for interaction between SolidCAM CNC machine shops that do the CNC work and the CNC job buyers. This is very exciting as it enables our SolidCAM CNC machine shops to get CNC jobs from buyers worldwide.
Wow, that sounds great. You know, as parts in CNC machines are becoming more complex, there is more and more demand for our mill-turn and Swiss type solution, which enables the CAM programmer to work significantly faster and become much more productive. Right. Marina Vilkina, our mill-turn and Swiss expert, will give a fascinating presentation about our multi-channel mill-turn and Swiss solution.
This is so exciting. After every presentation, we will answer 2 to 3 frequently asked questions that attendees will ask online. We will finish off the day with a panel discussion with Emil and 3 of our experts, Michael Leditsky, Amod Onkar, and Anthony Calderon.
Right. Please note that after every presentation, there will be a code for each presentation. The attendee can then fill out an online form with the codes of the sessions he attended, and the attendees who listen to the highest number of presentations will win prizes.
Can I also win a prize?
Sure.
I heard one of the prizes is a metal pen made by our Swiss type solution. We will have another contest of CAM parts. The best CAM part will win a prize. Again, the attendees, you, will decide which CAM part will win.
Sounds exciting. Okay, so I think we can give the stage to Emil, who will give the keynote presentation about SolidCAM. And by the way, did you see the article in a major financial newspaper about Emil? The man who dared and made it big.
Did I see it? The whole world saw it. It is an amazing article. And now let's give the stage to Emil.
Hello, SolidCAM staff, reseller staff worldwide, and hello to our lucky customers, also worldwide, and to you prospects watching this presentation. I hope I will be able to convince you to become also SolidCAM customers and join the successful SolidCAM family. SolidCAM today is a solid platform for manufacturing. It has many products besides the main product. The main product is obviously SolidCAM, integrated seamlessly inside SolidWorks and Inventor, also fully associative to the design model. We have the new shop floor editor and simulator for the operators working at the CNC machine to be able to simulate the CAM part and do some minor code editing if needed. Now we have also a solution for mold makers. By using the RMB SplitWorks, MoldWorks, and ElectrodeWorks add-ins to SolidWorks, the combination of SolidWorks, RMB products, and SolidCAM provide a complete solution for design and machining of molds and also for electrode design and machining. SolidFlow provides optimal scheduling of CNC jobs in the best possible way, and we are launching now the Solid Cloud module for best SolidCAM cloud backup. We'll give you more information about it. And last but not least, we have the Solid Metal interactive marketplace that links our SolidCAM customers with CNC job buyers worldwide. SolidCAM is the complete, easy to use and to learn CAM solution with revolutionary iMachining, multi-channel mill turn and Swiss CNC machining support, seamlessly integrated and associative SolidWorks and Inventor, as I said. And we always say that we provide you the one CAM solutions for all your CNC machine, from 3-axis machine, 5-axis machine, and obviously complex multi-channel mill turn and Swiss machines. You see, a CNC machine shop without SolidCAM has a problem because you could have different CAM systems for different machines. What is the problem with that? You have different software for different machines. This creates problems like being more time-consuming, high training costs, high purchasing costs, no one-size-fits-all solution, and no native data exchange. When you get SolidCAM, it's the full solution for all your machines in the CNC shop. The advantage of it, you get native data exchange, easy training, employees can train other employees, one support for all, and future-proof product. Okay, but wait, there is more. I mean, SolidCAM today provide you with so many modules. First, iMachining 2D and 3D, and I will talk more about it later, about iMachining. Our 3-axis HSM, HSR, HSS, our new Turbo HSM, very fast version of HSM, simultaneous 5-axis solution, advanced mill turn and Swiss type, our shop floor editor I mentioned, Solid Probe for handling the probes on the CNC machine, an amazing new SolidCAM simulator. So it's the one-in-all solution for all the needs of your CNC machine shop. What are, in a nutshell, SolidCAM unique value propositions? We have three main propositions. First, obviously, our amazing integration in SolidWorks and Autodesk Inventor, our support for complex multi-channel mill turn and Swiss type machines, and our iMachining, which is a revolution in CNC machining, right there to help you make your machine shop much more productive, much more winning. So, and we don't never forget that SolidCAM's intuitive and easy to learn and use interface makes it so easy to learn the system and to use it daily. One picture to show you the range of our SolidCAM international customers. You see so many names there, you know, in all fields, in aerospace, automotive, machine design, electronics, medical, optics, military, consumer, energy, production shop, mold tool and die, prototyping, and technical education. SolidCAM customers include small and medium job shops, the majority of our customers, also many medium-sized engineering and manufacturing companies, and also large aerospace and automotive companies. Also, we have technology cooperation partners. These are cutting tool and CNC machine tool manufacturers. In cutting tool, like Kennametal, Vidya, Hoffman Group, Goering, Mapal, and Iskar. And with the machine tool manufacturers, Star and Citizen, these are Swiss machines, QuickTech, Milturn, Haas, Gob, Alsmetal, OKK, and many more brands. In a nutshell, today we have 23,300 SolidCAM industrial seats worldwide and 62,000 educational seats. And we have a worldwide CAM distributor network with 65 resellers, 7 branches, and 9 affiliates. Let me give you an example of our branches. The main branch, obviously, is SolidCAM Germany, where we have the biggest number of staff and biggest number of customers. As you see, we have 7 branches all over Germany. And these branches are not only for our staff, but they have also technology centers. And we see here in the next slide, our technology centers. We have our main technological center, the one on the top, in our Schramberg main office. This is the picture to the right, to the bottom. That's the picture of our headquarters in Germany. And we have also another 2 technology centers in our office in Rosenheim. You see it to the left, and in the middle bottom in Seoul. These technology centers serve us both to test the software, to make customer days, to make webinars with live cutting. As a summary of SolidCAM Germany, we have 70 employees there, more than 6,700 industrial SolidCAM seats, and over 12,900 educational seats. Another major branch is SolidCAM Inc. in the US. They have a team of 35 staff, and they have a system called SolidCare, because for them, the support of the customers is of tantamount major importance. We have been focused on doing customer support using web support since 2010. The entire support team is thoroughly proficient at web meetings. We have live chats, and we have also night school, after hours live podcast. And we sell the product in solid packages, we call them. There is, in every level, there is the standard and the pro, like in 2.5D, in 3D, in 5-axis, in Milturn and Swiss. There is always either standard or pro package. We have 1,100 customers in the US. And amazingly, if you go to our US website, we have over 400 5-star customers reviews. Think of it. From 1,100 customers, 400 of them gave us 5-star customer reviews. This tells you that they are very happy with our support. Another indication of their happiness is that 80% of our customers are on subscription, a very important issue. Another example of our affiliates is our first affiliate in the world, SolidCAM UK, which was established in 2002 by Gordon Drysdale and Mark Stokes, two amazing people, one a great salesperson and the other a great technical person. So they have been our reseller since 2002. They have total 15 staff, and they have about 2,500 seats, including commercial and education. And also, they have a high level of subscription, 74%. And as you see in the picture, they have a very nice SolidCAM UK technology center with many machines given to us by different machine manufacturers and resellers, including one from Star. Here's an example of one of our SolidWorks resellers who sell also SolidCAM. We have most, I would say, major SolidWorks reseller today in the world. They sell also SolidCAM as the CAM solution for the manufacturing customers. So Tekias has been in business since '94, and they are the first and the largest SolidWorks VAR in Turkey. They have 5,000 SolidWorks customers and 10,000 SolidWorks seats, 7 offices, 90 employees. They have a revenue of 15 million. And they have a dedicated SolidCAM team in Tekias. You see, it's not a small team. 10 application engineers, 20 employees, 4 direct sales reps, 2 inside sales reps. They have 1,700 customers, you know, unbelievable for a country, for Turkey, with 2,100 SolidCAM seats, 7 local offices and training rooms. They have 6 sub-resellers to cover the whole Turkish market. We see here the location of the sub-resellers of Tekias. Okay, another example of our main reseller is CAM reseller, who sells dedicated to SolidCAM only. Obviously, they sell also the bundle that includes SolidWorks and SolidCAM. This company in Japan is called Tactex. We have been working with them since 2020. Their headquarters is in Nagoya, Japan, and they have 10 additional branches all over Japan, and they have a major technology center also in the city of Gifu with several CNC machines of different types. Now I want to talk a little about our favorite technology, SolidCAM iMachining, that provides 70% and more cycle time savings and obviously increased tool life 5 to 10 times, and it has the amazing technology wizard that provides optimal feeds and speeds for every point of the tool path, taking into account the stock material, the cutting tool, and the machine parameters. Now, our competitors claim that they have something similar. Well, I could tell you, as far as iMachining is concerned, no other technology compares to it. Those competitors include VoluMill, which is integrated in many CAM products, like in Cimatron, GibbsCAM, HyperMill. There is Dynamic Mill of MasterCAM, Adaptive Graphic of AnixCAM, Profit Milling of Esprit, and TrueMill of SurfCAM. Let's compare anyway and see what we have against all these so-called competitors. First of all, iMachining has 7 patents. The only other one that has 1 patent is TrueMill, and you know, TrueMill is SurfCAM, and SurfCAM is not much to be seen these days after being sold and bought and sold several times. What is the main difference of iMachining? Is it provides constant cutting force all along the toolpath, constant spindle load. All the others have different other technologies, much inferior, like constant step over, constant engagement angle. Nothing compared to our constant cutting force technology. And how do we achieve constant cutting force? All along the toolpath, we can vary the cutting angle and the feed. So if the cutting angle increases, we reduce the feed, and vice versa. We have also the maximum amount of morph spiral, which is the most optimum sort of toolpath, and we are the only one who have amazing thin wall handling. Also, we are the only product of its type that has the technology wizard that I said. Automatically provides optimal feeds and speeds, taking into account the stock material, the cutting tool, and the machine parameters. None of the others has anything similar. They might have something simple, they call it wizard, but it's nothing compared to our technology wizard. Because of the use of the wizard, we have the shortest learning curve. And in so many benchmarks against those competitors, we always had the best cycle times. And we are ready to challenge any of them in any benchmark again and again. You could go to our website and see hundreds of iMachining success stories where we beat all the other competitors and saved a lot of money for the machine shop. We are also the only product that have a complete process for prismatic parts. That includes roughing, rest roughing, and finish. And if you take all these advantages I mentioned, in the end, we guarantee first part success, a very important issue. And the great technology of iMachining is also fully integrated inside NXCAM. So any customer in the world today using NXCAM, he can take iMachining fully integrated in his product and get its amazing advantages. Now, I always like to talk about our latest and greatest version, which is today, SolidCAM 2021 SP4. And as you see, that this is Service Pack 4. So it has gone through 4 service packs during the year 2021, which means it's really very well stable, tested, and has the full functionality. And I recommend it to every one of our SolidCAM customers. Let's see what are the highlights of this version. First of all, we have a completely new tool table. I will talk more about it. We have a new SolidCAM simulator, an amazing one, and we have enhancement in all the other SolidCAM modules. Let's look at our new, powerful new tool table. It has great capabilities and features for mill turn and Swiss customers. Some of our only milling customers are a bit complaining that there is few more clicks in the new tool table as compared to the previous one. I could assure you this won't prevent you of using it successfully, and I'm sure that you will soon get a mill turn machine, because this is the way everybody is introducing mill turn machines, and then you will need the new tool table. With the new tool table, we can represent all the needed tooling system parts separately and in commonly used combination, as you see in this figure. And we could represent also complex tool assemblies, as you see in the figure there, that includes multi-body holders and multi-tool assemblies. There's no other CAM system that provides such functionality. And very important, the new toolkit is very important to use in Swiss-type machines because it provides modular machine setup. We define the machine setup with modules and then easily move the modules from one station to the other, an important feature for Swiss machines. And we can build the tool assemblies by downloading modules from an online source like Machining Cloud, ISCAR, Kennametal, or any other tool manufacturer website. And very important, we can visualize the tool item and its schematic position relative to the machine coordinate system and in connection with the machine devices, as you see in the figure here. I mentioned we have a completely new simulator. We have spent 3 years in developing it, and it's amazing in everything, in its graphics, clarity, and its functionality. We have completely new function in the new simulator that didn't exist in our previous simulator. You see here some examples of this simulator in mill turn and Swiss, and also in regular milling. And since also the turning simulation has been improved, we show the holder 2D shape in the turning simulation to avoid part and holder collisions. And since we are the best solution for multi-channel mill turn and Swiss machines, we obviously provide the multi-channel SolidCAM simulator You see here in the figure the synchronization table to the left, and to the right you see the simulation, the multi-channel simulation. Another major feature of this version is it is the perfect solution for multi-turret and multi-spindle CNC machines with ultimate programming ease of use, flexibility, and configurability. And obviously we support Swiss-type mill-turn machines, including the best multi-channel synchronization in the market today. In our mill-turn solution, all the milling and drilling and turning operations are available, including iMachining. So basically, you could, in a mill-turn or Swiss machine, you have a lot of milling operations, and we use iMachining 2D and 3D to save you both programming time, cycle time, and increase tool life. And we have another important added feature called MCO, Machine Control Operation, which enables you, the user, to insert control operations while manufacturing a part, a very important feature. Now, I want to say why Swiss-type users need CAM. First, parts are becoming more and more complex. The machines are getting more and more complex. So programming and managing sync codes and access patterns for multi-channel machines is very hard if you do it right on the controller with what I call finger CAM, right on the G-code on the controller. And obviously, if you are doing that on the controller, what we are missing is the important simulation and verification of the toolpath. You know, Swiss machine is very complex. And if you don't have simulation of what you programmed, you really risk having a lot of crashes. So, why Swiss-type users today must need CAM? Obviously, SolidCAM is the best for that. A Swiss-type programmer today by G-code is definitely not efficient. And it's very difficult to find somebody like that to recruit. Using SolidCAM's Swiss-type module, the programmer works significantly faster, becomes much more productive, and has the amazing simulation to prevent any problem and crashes in the machine. By having faster programming, the machine shop could bid on short-run jobs, keeping the machines active, making money, cutting metal. Also, because of part customization today, this means more variations and smaller lots, and more programming is needed. Best example of the use of our Smith solution is for medical, for dental implants. Nearly everybody today needs dental implants. So here's a customer of ours, Bioline. They tried GipsCAM and Esprit for their Swiss machines. They are not happy in the end. They moved to SolidCAM. They have Nextern and Hanwha machines, and today they are very happy, and they are doing programming of several new parts every week with SolidCAM, Swiss solution. Also, we have today a big database for support of different Swiss-type brands like Star, Citizen, Tsugami, Nomura, DMG Mori, Nextern, Tornos, Index, Traub, Hanwha, and any new machine or brand or a variation of existing brand, we can develop processor quite fast. Not only that, even if we have a processor ready, sometimes the customer wants special variations for his style. We can do this quickly and easily. We are the best in that in the market. Additional enhancement in SolidCAM 2021 in other modules include multi-core support for our turbo HSR and HSM. We provide 64-bit calculation, and the speed of calculation increases as the number of cores increase, and we have also much faster recalculation. We have major advances in our powerful simultaneous 5-axis machining module. We provide now multi-axis machining to rough out and finish pocket-shaped geometries in full 5-axis, an amazing feature. We have support for the new generation circle end mills, which the tool manufacturers promise up to 90% reduction in machining time. We support all shapes of these circle end mills, including barrel shape, oval form, taper form, and lens shape. Another feature for 5-axis is edge trimming. You know, energy efficient materials like composites are getting popular. They are generally cast, and these parts require edge trimming operation to get their final shape. Also, vacuum form part in the automotive industry require edge trimming operations. So this is an automatic algorithm that provides all the edge trimming needed for the model. Another very important feature is edge breaking. You know, after machining, you can have burrs left by the tool. SolidCAM edge breaking toolpath automatically detects the edges and creates a deburring toolpath. This way, avoiding a manual process that can take a lot of time to do the deburring manually. Another feature in 5-axis is Auto 3+2 roughing that creates 3+2 roughing toolpaths automatically for multi-sided machining. Now, I mentioned solid metal. Now I want to give you some more information about solid metal. First of all, we are the first CAM company that launches such a service for its customers. Because you, as our customer, can register yourself in our solid metal marketplace, give the data about your CNC machines, about the additional manufacturing capabilities, about the type of work you would like to do, and then CNC job buyers from all over the world. I mean, solid metal is from all over the world, both the manufacturers and the buyers can find you, communicate with you through the marketplace, get a quote from you, decide to take the job from you. So basically, this is a great service for our SolidCAM customers. But there is only one condition for our SolidCAM customers to be included free of charge in this marketplace. You must be on subscription and having our latest version, SolidCAM 2021 SP4, and you must have iMachining. Why? Because we know that if you have our latest version and you have iMachining, you can save a lot of time and money, and so you can provide a better quote to the CNC job buyers. So if we are going to recommend you in our marketplace to job buyers worldwide, we must make sure that at least you have our best technologies and that you'll be able to provide a good quote to the CNC job buyers. So when the CNC job buyer comes to the marketplace, he could launch a project, include the details of this project, like all the drawings, the models. He could search in the manufacturer database for specific type of work he wants to do, like medical, aerospace, for a certain capacity of CNC machine, for a certain geographical location, because somebody might have giving a job in Germany, but he wants to find a manufacturer in Turkey. He can do that through our marketplace. So it's an amazing service we are giving it to you, our SolidCAM customers. We just ask you to have our latest and greatest version and our iMachining technology. This will not only allow you to be included in the marketplace, it will save you a lot of money in your everyday manufacturing. So, Solid Metal connects buyers with manufacturers all over the world. And, by the way, you, as a manufacturer, you could even sometimes outsource some of your work because you have too much work. And then you could register also, not only as a manufacturer, also as a buyer, and find a good place to outsource some of your jobs. Now, probably everybody also is interested to hear what are our planned new features for SolidCAM 2022, which will be launched at the end of the month of May. First, in SolidCAM 2022, we support part configurations. Everybody working with SolidWorks knows what a configuration is, so you can guess what it means, CAM part configuration. Basically, the CAM part you define is the initial master configuration, and then you make clones from it. You use drag and drop to locate every new configuration at a station or fixture joint. The number of operations in all these clones is the same, but in each configuration, you can have some of the operations that you want to change suppressed and redefine them. And for each part configuration, the updated stock is saved. So this is a very nice feature. Also in SolidCAM 2022, we have a setup sheet web-based template configurator. We offer you an online database of predefined templates, and then you can easily do template customization and then download a customized template ready for use. A very nice tool for setup sheets. Another important feature in SolidCAM 2022 is the associative coordinate system. You see, in SolidCAM 2021, the coordinate system is not associative. If there is a change in the part and the location of the coordinate system moved, you have to redefine the coordinate system. Also, if you want to edit the location of the coordinate system, you have to restart from the beginning. With the associative coordinate system in SolidCAM 2022, and we worked a lot to do that, everything is associative, including the levels page. You can also edit the location without having to recreate the coordinate system from scratch. A very nice feature, and there will be a full lecture about it. And we are continuing all the time to enhance our amazing whole wizard. The enhancement we'll have in 2022, we have advanced feature recognition. So basically, you recognize the features once, and then you can use them repeatedly. Also, we have new feature-based attributes, including dimensional tolerances, feature color attributes, and logical flags. And we have also tool search criteria tolerancing. Also, we have in SolidCAM 2022 U-axis support. It's a new axis type that can be both simultaneous or indexial. The tool vector for kinematic calculations is the drive unit axis vector, normal to the plane vector. Also, in 2022, we have now collinear axis support. This is important for CNC machine for heavy and gas and oil industries. And those CNC machines are designed to hold heavy parts and also to do deep holes machining. So we will support them well by our collinear axis support. Another major technology which we talked about in the past now is coming to implementation is eye-turning. You have seen before our trochoidal turning toolpath. We have enhanced this trochoidal turning toolpath, and one of the major enhancements is that eye-turning supports all insert shape, not only round shapes. This technology is easier on machine tools. It provides increased tool life and reduced machining loads. Additional advances in turning, we are supporting the Ceratizit free turn. Ceratizit is a turning tool maker. And all familiar turning operations such as roughing, finishing, contour turning, facing, and longitudinal turning are all completed using just one tool. Very nice. Also, in 2022, we plan to support Sandvik prime turning. Prime turning is a new methodology that enables you to do turning in all directions in a much more efficient and productive way as compared to conventional turning. Sandvik says that it delivers a 50% increase in productivity. Another interesting feature in 2022 that will make your work faster and easier is what we call automatic templates. So for faster user working, we will generate an automatic template for each tool size, operation type, and type of stock material. Next time the user adds an operation and chooses tool size, he can choose from the last 3 automatically saved templates, the one whose parameters he wants to use in the current operation. By the way, all these things I mentioned coming in SolidCAM 2022, not all of them will be in SP0 released end of May. Some of them will come on later SPs like SP1 or SP2 or SP3. Now I want to talk a few words about Solid Cloud. We will have a lecture about it later. Solid Cloud will provide synchronized backup on the cloud of all your SolidCAM data. SolidCAM settings, your post-processors, your machine simulations, the material and machine tool databases for iMachining, the global tool tables, and obviously your SolidCAM CAM parts. So there's no need to worry anymore about losing any of your data. They're all backed up on the cloud. So if one day your computer suddenly has problems and you have to maybe redefine everything, you could simply reinstall the SolidCAM software, and then you can access all your existing data on the cloud, including all your CAM parts, post-processors, machine simulation, and all the rest. Also, another advantage of this feature, if you as a SolidCAM user want to work from another computer, let's say you have one computer in your machine shop and one computer at home. You can access from the computer at home all the data on the cloud, and then any changes you make on this computer at home will be synchronized to the cloud, and you could get them in your machine shop the next day. Very important feature. And by the way, if somebody is worried about the security of the data, Solid Cloud is based on Google Drive, and Google has the most secure backup. You'll have a lecture about Solid Cloud data that explain this very well. Now also I have another important announcement. We are announcing the SolidCAM Maker version. The SolidCAM Maker version will have the functionality of the regular version, except it will have only 3 built-in post-processors. One processor for Haas milling post, one for Mach 3, which is used by a lot of hobbyists, and also one Haas turning post. These posts cannot be modified. So these posts are the only posts that will be able to be used with this Maker version. And who uses this Maker version? It's for makers, hobbyists, and students. But I tell you, CAM parts built in the Maker version cannot be read in the regular educational or industrial version. This SolidCAM Maker version can be downloaded for free from the SolidCAM website and will be updated the same as the regular version. So basically, every SolidWorks user in the world, whether he's a student, hobbyist, or maker, can download the SolidCAM Maker version and use it freely. And once the maker becomes a customer, he will probably fall in love with SolidCAM and then move to our regular version. It's a win-win for all. Now I want to announce something really new. You see, studying what's happening in manufacturing, we realized that 3D printing is going into manufacturing. And you, as our customers, we realize that sooner or later you will introduce this technology to your machine shop. So if you are our happy customers, then we should be the ones who provide you with this technology. So we studied all the companies that provide such products, and we realized that Desktop Metal is the one that we want to partner with to provide you, our customers, with additive manufacturing. Here is Rick Fulop. He's the founder and CEO of Desktop Metal. We had a meeting in November where we decided on our cooperation. He founded Desktop Metal in 2015. He had amazing growth since then, both organic and through acquisitions. Like last year, they increased their staff from 200 to 1,000 in 1 year. They have launched additive manufacturing 2.0, and today they are the world leader in fast metal 3D printing with their leading binder jetting technology. Where do you use 3D printing in your machine shop? You can use it for rapid prototyping. They have two systems can be used for that, fiber or studio system. You can use it for mass production with their binder jetting technology. They have two systems for that, the shop system and the production system. And you can use it for manufacturing tooling. And for this, you can use either the fiber or the studio system. We will have a full lecture on this given by Michael Leditsky, SolidCAM COO Global. So wait for it. You will enjoy it. To summarize, what are SolidCAM advantages? Through several decades, 37 years of customer-centric development, our excellent product today has so many main advantages. Let's go through them. First, obviously, our integration with the main CAD products, SolidWorks and Inventor. We provide you, our customer, through our integration, a hugely superior CAD solution compared to the weak-owned CAD of all the other competitor CAMs. We provide you with the easiest to learn and to use CAM system. A new user could figure out the structure and user model very quickly. We provide you, as I have shown, with the most advanced tool table in the CAM field. We offer you the unique and amazing and revolutionary iMachining 2D, 3D technology with all the best time-saving, optimal toolpath, dramatic tool life savings, and the only really working iMachining wizard in the industry that takes out all the guesswork of setting the optimum cutting conditions. We have the most advanced simulation in the CAM field. We have seen the pictures. We have easily customized the best post-processor in the CAM world, a huge database of post-processors that can be easily customized to your preferences, you, our customer. Also, we have a complete CAM solution, as I have shown, for all CNC machine types, including the fastest growing niche of multi-channel advanced mill-turn CNCs, including Swiss type, where we provide today the absolute best CAM solution. Also, we provide important complementary solutions like the shop floor editor and simulator, Simco Edit, and also we are providing you with a solid metal interactive marketplace. And we have many new R&D developments on the way, as I have shown, new things coming in SolidCAM 2022. So I could say, definitely, SolidCAM 2021 SP4 is a great version, and every existing SolidCAM customer should get it by being on valid subscription. And obviously, you prospects watching this presentation, you could become our customer and get this amazing version. Now, I want to emphasize something very important. It's not just the software that's important when you want to give this service to a machine shop. It's true, the SolidCAM software is the foundation on which all the other further steps are built. But you need also post-processors. The best software is useless without custom post-processor. I mean, this is really, post-processor is where the rubber hits the road. Without post-processor, the software, CAM software, is really not much use. Also, as a machine shop, after you get the software, you need the best technical and post-service, perfectly tailored to your needs. And also very important to have the right implementation and installation of the software in the first place. So really to be happy, all these aspects have to be 100%. If somebody gives you only software but doesn't give you good post-processor, you won't succeed with it. If he gives you both solid software and then post-processor and then leave you alone and doesn't support you on the continuation, very difficult. You see, successful CAM is both a product and a service. It has two legs, and you have to stand on both legs to provide the best product and service to our customers. So, to sum it up, it's a lot about the technical and post-support. In SolidCAM, we proud ourselves by giving 5-star support. We have a main difference and advantage to our competitors is our technical, post, and CNC knowledge. We help our customers get better every day. You see, manufacturing companies now are under enormous price pressure, increasingly complex parts and shorter delivery times. The need for the best CAM system is the logical consequence of these requirements. So really, our motto is, let's make our customers much more competitive with SolidCAM 21 and obviously with iMachining. Now, to finalize, some people ask me, why is SolidCAM so successful as compared to our competitors? Well, let me define what are SolidCAM's core values that help us become the best CAM in the world today. First, our CAD integration. We are the absolute leaders in integrated CAM. We have seamless single window integration associated with SolidWorks and Inventor. We leverage the power and ease of use of these famous CAD products and provide them to you as a part of the complete solution. So, by deciding to concentrate only on CAM, you see, we had our own CAD in the past, but 25 years ago we realized a company cannot be the best in both CAD and in CAM. So we decided we'll concentrate on CAM and be the best in the world, and we'll integrate with the best CAD in the world. And this strategy has succeeded beyond any doubt. By concentrating all our R&D effort on taking our CAM to the highest level possible, we developed our amazing iMachining and our amazing multi-channel mill turn and Swiss solution. Another core value, we leverage auxiliary breakthrough technologies from CAM module partners. You see, there are some companies that provide CAM modules, like a company providing engines for Boeing aircraft. Boeing doesn't develop its own engines. So it's the same. There are companies that provide important CAM modules that have amazing technology. Companies like, for example, ModelWorks, which provide us with amazing 5-axis power, MachineWorks, machine simulation, SimCo, G-code editing. So this again, leveraging these amazing technologies from these CAM module partners enable us to provide better products to you, our customer, in a faster way. Also, we have an advantage because of our long experience both in CNC manufacturing and CAM software development. We can choose the right teams that combine expert CAM and CNC product managers and software developers, driving SolidCAM into the best CAM system in the market today. Also, we closely monitor our customer needs. We listen to customers for development and product direction, so we are always ahead of our competition. Also, our relationship with CNC machine tools and cutting tool partners give us a good indication of where the tools and the machine tools are developing, and we will always make sure we support the latest version of those CNC machine tools and cutting tools, and you have seen this in my presentation. And last but not least, one of the major core values is, I call it strength through independence. SolidCAM has set itself the goal of continuing to grow and develop independently of any external investors. Thus, we maintain our uniqueness and flexibility. We continue to be at the forefront of CAM innovation for CNC machining of all CNC types, including the most complex one. And as I said before, we continue to provide the best technical and post-process support in the CAM field for our CNC machine shop customers. You see, by being independent of any external inventors, we don't have to report to the stock market and to investors. We only care to report to you, our customers. Because our motto is the customer is the king, and our only purpose is always to provide the best product and service to you as our customer. So, why do we call SolidCAM the future of CAM? Well, I'll give you the answer. The best way to predict the future is to create it. And that's what we are trying to do in the field of CAM. Thank you all.
Thank you, Amy. That was a fascinating presentation.
And now, Linda, our next presenter is our own very SolidCAM professor, Sidney Eisner.
You know, Natalie, I have known Sidney for over 20 years, and he has a winning combination of being a very nice person and a true professional.
That's right. For the longest time, he was the SolidCAM professor, and today, he's the Vice President QA. He has surely come a long way. Emil asked Sidney to prepare a dazzling half-hour demonstration using our latest SolidCAM 2021 SP4 version that best shows the main amazing SolidCAM technologies. Our staff and resellers will then learn these demonstrations and use it to highlight SolidCAM functionality to every potential customer before doing a demonstration on the prospect's part.
You know, this is very important. It's a very interesting presentation for our staff, resellers, customers, and prospects. Sidney, the stage is yours. Dazzle us.
Hi, I'm Sidney Eisner, SolidCAM's Vice President for Quality Assurance. Today, I'll be demonstrating you how you can easily and quickly program with SolidCAM and give you a quick look at the modules that we have. This includes iMachining, both 2D and 3D, 2.5D milling, our most advanced mill turn with Swiss-type machines, and multi-axis applications, of course, and more. My goal is that once you get a taste of SolidCAM, you'll want to see a lot more. First, I'd like to get started by showing you how quickly and easily you can program this part that you see on the screen within 5 minutes, from the CAD model to the finished product. Okay, so if we take a look at the part that we have on our screen, what you'll see is very simple. I'd like to machine this part, put some face mill on top of it, some pocket operations, iMachining, drill these holes out, basically machine all around the part. Okay, so let's get started, and I'll just quickly start my new program, and I'll go to New Milling, and all I really need to do right now is create my coordinate system. So I'll go ahead and create my coordinate system, and I want it at the very top center of the model. So I'll just click over here, and it's at the very top center of my model that I have over here. I'll just accept that. And it's right now just creating my stock material around the part, and it's also choosing my target, setting up my iMachining information, and now I'm ready to start working. Now, as I said, the first thing I'd like to do is put a face mill at the very top of the part. So I'm going to go and open up my templates, and I'll choose one for face, and say I'm going to choose this one over here. Just drop it at the top of my part, and there we have it. We have a tool pass on top of my part. Now, I want to machine the outside of the part. No problem at all. I'll just go, and you know what? I'll use an iMachining 2D operation for that. And the iMachining 2D operation for that is going to be outside. So I'm going to do my outside machining. Just, again, click on top of the part. And as you see, let me just drag it to there. And you can see that it'll just put a tool pass just around the part. Let's take a quick look just at the simulation, just to see what I did. I'll do simulate. And you can see it did the face mill, the tool, the path around the side, face mill we had done before already. And now we're ready for our next operation. So I'd like to drag onto this surface one of my pocket operations, and I want to choose them for both, for this surface and for this surface. So as I drag it onto that surface, I'm going to hold my control button and then click on the second one. Letting go of my control button, that'll automatically create a tool pass for those two areas over there. I want to do the same thing over here. So I'll just drag it to this surface over here. And there's my tool pass just on that area as well. Now, I want to continue, say, to this area over here. You know what? Instead of dragging the template that I have over here, you'll note that I'm also building operations on the side. I can just simply take one of the operations, the pocket operation, and simply drag that to that surface over there. And we have a tool pass in that area over there. You see where I'm getting at? We're creating tool passes really quickly just by simply using templates. What are templates? I'll explain that to you in a moment also as well. I'm just going to continue on over here and drag it to this surface on top over here. And we have our tool pass over there. What about these two surfaces over here? Why not? Just do the same thing over here. Just drag it over here. Hold my control button so I can click on both of them. And there we have it. We have the tool pass over there. No problem at all. Now, you'll note that I have these holes on the part itself, okay? Now, those holes, I'm going to use something what we call Hole Wizard, okay? So all I need to do over there, as I'm going to close my templates for a moment, we have drag to surface for my Hole Wizard. I'm just going to drag that to the top of the part. And what it's doing right now, it's recognizing the counterbore holes, the simple holes, the tapped holes, and creating operations for those particular holes. And you can see the operations being done as I'm talking, without really going in and creating any operations. These are this is what we call our automated Hole Wizard, okay? And we know exactly what we're doing. Now, let me stop for a moment, okay? So don't hold my 5 minutes now. I want to make a little bit of a change, because we said now SolidCAM is associative as well. What happens if I have to make a change on that particular hole, that tapped hole over there, okay? And now, before I do that, before I make any change, I'd like to do something else. Since all of these operations the pocket operations, the iMachining operations, they are associative, and they're also, they check up on the updated stock. I don't want this to change at all, okay? So we have a new feature now, actually. It's called suppress and lock, and I'm going to lock the toolpaths. This way, when I make any changes on the part, I don't have to recalculate those as well. Okay, so now let me go to the part. I'm going to open the part, and what I'm going to do is I'm going to do the following. If I were to open up this hole over here, you'll see that it's an M12 by 1.5 hole, okay? And they just told me back in the engineering department that I have to change it to an M6 by 1. That's what they really wanted. So, okay, change it to an M6 by 1, accept that. Let me close the part and save that. So now, the operations that I had over there have to be updated. If I go over here, you'll note also that the operations that did my tapping are marked with a traffic light. That means it needs to be synchronized. So all I'm going to do, right-click, synchronize, and you can see those holes, those tapped holes are being redone, and they're completely synchronized. Now, if I were to open up, for example, my operation over here on the tapped hole, let's just take the last one over here for a moment. And if I go into my actual tool table, you can see that this is a tap M6 by 1. So that was changed to the proper type of hole. Okay, so now let's continue with programming the part. And you know what? What about this operation over here? I still have to pocket out that hole over there, this pocket over here, and it's a through hole. So I'm just going to take one of the operations that I had here before of the pockets. I'm going to right-click, I'm going to do copy, and I'm just going to paste it. Just like anything else, copy, paste. I have a new operation, and I'm just going to go in and edit it. Any operation that we have, even if it was created in a template, can be edited. What do I need to edit? I just need to make I need to create a new geometry. So I'll go ahead and create a new geometry by clicking on that edge over there. And that's it. You'll even note that my levels, my lower level, is automatically updated as well to be at the bottom of the part. I'm just going to do save and calculate. And then we have the bottom over there as well. Let's just do a quick simulation so you can see that. And I'll do this time solid verify simulation. And if I zoom in a bit, you can see that it just does that pocket right over there. Okay, so basically this side has been finished. Now, this side I really don't have to do anything except for this pocket. I don't have to do a face mill over here because I machine already that side of the part. And all I need to do right now is just put a pocket operation over there. Okay? So let's go back to my templates. I can also drag and drop from here if I want, but let's go back to the templates. And again, I'll just use that same template, just drag it now to this side. And you'll note when I do that, first of all, it's putting it right over here because that's where my last operation was where I did it. But you'll note also that my coordinate system was automatically created. It automatically created a coordinate system. Now, if I don't want that operation there, no problem. I can simply take that operation and just drag it to the bottom to exactly where I want it. Okay? And I'll just recalculate that operation. And we have that operation now on this side. What about the other side? I'll do the same thing over there. Just drag it to that side over there. Again, we have that pocket over there. Now, what about the bottom? You know what I'm going to do? Over here, I need a face mill, and I need this pocket over here. So I'm going to go back to the top. I'm going to grab that face mill that I did in the very beginning, grab the pocket operation that I did over here, and I'm just going to drag it to that surface. And it's doing both the face mill for that area over there, plus the pocket as well. quick simulation of that as well. And this time, you know what? I'm going to right-click over here. I'm going to use SolidCAM Simulator. Okay? Go to the other side over here. Start running it. And I'll do this actually slow so you can see it actually going. You can see it's doing its face mill. And you can see also the pocket being done. Now, what's nice also about if I'm already here with the SolidCAM simulator, what's really nice about this is you can also go backwards over here with the simulation. I can drag back and I can go back to any point to see a specific area if I want of the simulation. Okay, so I basically finished this part, except for one more thing. I'd like to put edge breaking on this side over here. So I'm just going to go. And you know what? I even have a template for that as well. I'm just going to go to my edge breaking recognition, edge deburring as we like to call it. And I created two templates for that. I'm going to use a 0.2 millimeter. Just drop it on that side over there. And there we have our chamfer operation for that. Let's take a look at the simulation, because this is really cool. Take a look at the simulation. I'll use Solid Verify for that. Okay? What you'll see is very simple. You can see how the edges come up exactly 0.2 millimeters, and it knows to stop before the actual target. So there we have this part now completely machined. Okay? Now let's talk a little bit about iMachining. You may ask yourself, what makes iMachining so special? What makes it stand out above all its competitors? Well, for one, this is our patent. No one else has it. Because we are the only program that uses constant cutting forces, we are the only program that can provide variable cutting angles, variable feed adjustment to keep the constant cutting force, and maximum for morphed spiral. And with our patented technology wizard for our feed and spin rates, we are able to give you the shortest cycle time, shortest possible learning curve, and the first part success without breaking tools. Now let's take a look at how iMachining works. Now, if you take a look at this particular part, what I'd like to do is I'd like to machine the outside. And before that, let's take a look at our stock. Okay? Our stock, in this particular case, is a box around the part. Okay? Now, so like I said, I want to start from machining first from the outside. No problem. Let's go into the iMachining operation itself. And what's nice about iMachining is actually feature recognition. It recognizes the actual features of the part. Now, in this particular case, like I said, I want to do the outside of the part. So we have here an option that says, okay, feature recognition mode for the outside feature recognition, as you can see. Okay? And I don't have to pick any geometry for this, because it recognizes what my target is, and it also recognizes what my stock is. Okay? Now, when it comes to tools, let me just click over here for a moment, and you'll note we have several different modes. We have a mode for multi-tool, where I can use several tools within one operation. I have, if I want to do just roughing with one tool, if I want to do iRough plus finish, and others as well. For this particular one, I'm going to first start off with iRough and finish. In other words, I want one tool to do my roughing cut and finish cut. Okay, now go ahead and choose my tool. And in this particular case, I'm going to choose a 16 millimeter end mill with 3 flutes. And I'll just accept that. Now, notice what happens also in a moment on the screen itself. Let's take a look now at what we have on our screen. You can see we get a preview of exactly what's going to be cut out. You can see the stock. You can see it's cutting up until, you can see the material up until the part itself. Now, if I go into my levels, you'll see it automatically recognizes what my upper level is and also what my lower level is. If I want to go a little bit below the part itself, which people do like doing, I'm going to do a delta offset by 0.5 millimeters. And now let's go to our technology wizard. And this is really where all the fun starts. You'll note And let me put this over here in this top view of this area over here. You'll note we have machining levels. Now, there's a lot that we know about iMachining, in iMachining actually. We know the type of machine you're using. We know that's your post-processor. We know the material, because you put in the material. And we also know the tool. We know what kind of tool it has, how many flutes it has. We know everything about that. So we can calculate easily the feed and spin rate through iMachining. But there's one thing we don't know. Only the user knows this. What's the condition of your machine? Is it a brand new machine? Does your machine have play in it? How are you holding the part? Are you holding it really nice and firm in a vise, or with two small clamps? So as far as how strong it's being held, only that person knows. So as far as being aggressive, the programmer can decide how aggressive he wants to be. You'll note also that if I make it less aggressive, take a look what happens at the spin and feed rate. The spin and feed rate automatically goes down. And you can also see the chip thickness is also less. As I go up, it goes higher. I'm just going to leave it at that. And just going to my technology, since I'm doing iRough and iFinish, you'll see that I have my roughing and my finish over here. Just going to do save and calculate. And there's my tool pass. Quick simulation. Now, let me start off a little bit. And let me put this in top view. Now, you'll note that as I'm going in, and also pay attention to my feed rate over here. As I'm going in, step at a time, you'll see that as we get thicker and thicker cuts, the feed rate slows down. That's what keeps our constant force. As it gets thinner, it speeds up. As it gets thicker, it gets lower, and so on and so forth. When it repositions itself like it's going to do now, it goes to its maximum feed and then goes back down. Let's run this now to the end, and you can see that's going all the way to the end of the part. Now, I'm going to stop this now, and I want to make one little change. Remember the stock over here, in this particular case, was a box. I'm going to change my stock to be a little bit different. And instead of a box, I'm going to make for a circle, for a round stock. Okay, so I'm going to do a cylinder, pick the part, accept that, and just calculate the operation. You'll see now that iMachining automatically recognized that the stock now is round, and the tool pass is completely different. Okay, now I'd like to machine out these pockets over here. Okay, again, iMachining. This time I'm going to use the option of multi-tools, where I'll be using one tool for roughing, one tool for finish. And I'll be using also the option of feature recognition by faces. In other words, I'll pick the faces that I need, and it will recognize exactly what material has to be taken off. So I'm going to click on this face, and you'll notice also the levels of the faces are not the same. That doesn't make a difference. We recognize that as well. Just click on all the faces that I want to machine. Okay? Even the middle pocket, I'm going to choose that as well. Choose my tools. Now, when I go choose my tools, the first tool I'm going to choose, I'm going to use the same tool I did last time. That 16mm end mill. And for that, simply I'm only doing roughing. You'll see that I'm going to not check finished wall or finished floor. I'm just going to leave that empty. So it's only going to do your roughing. And you can also see, by the way, the preview shows us what material is actually being taken off. Okay, now I'm going to choose a second tool. And the second tool is going to be 10mm end mill. Okay? Accept that. And now when I go to my levels, you'll note there is no levels over here because we have multi-levels, multi-depths. You can see that over here. You could also see on the part, it shows you that this is -10, -15. It shows you that everything is very visible over here. In my technology wizard, you'll also note that each tool you can control separately with your technology wizard. Okay? Now, let me go back actually to the second tool over here. And I said that this one I wanted to finish. I'm going to click, I want to finish on the wall and on the floor. Okay. If I go to my technology, you'll note that the second tool, which I see here on the side, has the wall and floor finish to it, while the first tool is only doing roughing. Okay? Save and calculate. And you can see over here now, it's creating now a second operation for the second tool. All this was done within one operation. It created two operations automatically. Okay? And we can see our tool paths around the part. Let's do just a quick simulation on the entire part using Solid Verify. And I'll speed this up. We have the outside. And it's going to do also the finish cut and the pockets as well with the separate tools. Okay. Now let's take a quick look at our simultaneous multi-axis machining. Our powerful multi-axis machining allows you to take full advantage of your multi-axis machines to be able to machine any kind of surface you may have. This includes roughing and wall and floor finishing while supporting new generation circle end mills such as barrel tools, oval, taper, and lens forms tools. Our multi-axis modules are an extension to that. That allows you to program with ease and machine a wide range of commonly used applications. This includes applications such as screw machining, swarf machining, edge trimming, port machining, multi-blade, edge breaking, contour 5-axis machining, and multi-axis drilling. Now, I'd like to show you one example of these modules, and that's edge breaking. Now, after machining on the part, all the parts that have straight edges or non-tangent cutter surface topologies, you'll find that there's a little burr that's caused by the tool on those edges. Well, SolidCAM edge breaking toolpath automatically detects these edges and creates a deburring toolpath. Let's take a look at such a part. Now, if you take a look at this part, I need to break the edges over here, deburr these edges over here, and these as well. Now, I've already created the operation, so let's just take a quick look at the operation itself. If I were to open it up, you'll see this is specifically called edge breaking operation. And you'll note we have our target and we have our edges auto detect. Okay? Let me just do a quick simulation of this. Simulate. Let's do this in Solid Verify. And we'll run this a little slower. You can see, let's zoom in on the edges itself. You can see that's being broken. Those edges now have a burr removed on it. You can see that on all the edges that we have over here, on the entire part. Okay. And finally, let's talk about SolidCAM mill turn with complex mill turns and Swiss type machines. With more and more of the industry moving over to complex mill turn and Swiss type machines, SolidCAM needed to support this as well. And we did it big time. We support the most complex Swiss type machines on the market today with multi-turrets, multi-spindles, using all of our machining modules from 2.5D, turning, iMachining, and multi-axis machining. Our MCO, which is our machine control operation, enables users to insert controls operations while manufacturing a part. Let's take a look at one of these parts. Now let's see a part that we have done on the machine, on the Swiss type machine. Now, if you take a look at this part, you can see that It's being milled. We have some fourth axis operations over here. We have drilling over here. We have turning. We have more milling over here. If I was to flip around over here, basically this part was done on a Swiss machine. Now you can see, basically we're using a lot of these operations, turning operations. We have MCO operations, like I said, for inter-control. We even have, if I go into my operations, you can see we have also channel synchronization. But you know what? Instead of actually starting to go through a whole program, I have this particular part, I have completely filmed the person actually programming it and machining it. So let's switch over to this part, and let's see exactly how this is being done. Now here's another part that was done in our technology center in the SolidCAM UK on a Star SR38B Swiss machine. In this part, we took full advantage of our multi-axis simultaneous machining. Let's take a look at the video and pay close attention to the machining. Now, everything you have seen here has also one major advantage that none of our competitors have. And this is where we really stand out above the rest. SolidCAM 5-star support. Our support team has many years of shop floor experience as programmers and machinists. When you need them, they're there for you. They understand you. Whether it is post-processors or help with SolidCAM, they are always there for you. They don't stop until you are satisfied. Now, to all our customers and prospects, I hope my presentation piqued your interest in SolidCAM's product range and how we can help you improve your productivity. For that, please contact your SolidCAM representative to set up a personal and customized in-depth demonstration that will fit your needs. Thank you for joining me in this presentation. Take care and have a great day.
Sidney, that was a very interesting demo.
Thank you.
I hope our resellers will learn it and use it.
I'm sure they will.
Okay, now the questions are starting to come in. Let's see the first question. Okay. So you were using drag and drop templates for programming your part.
Correct.
That was very impressive and quick. However, what if I want to edit one of the operations and make some changes? Can this be done?
Well, yes, of course. The operations that were created are just regular operations. You can just go to Edit Operation and make any changes you want, such as tool feet, spin rates, diameters, levels, offsets, whatever you want. You can even save that as a separate template.
Thank you.
Okay.
But just a second, another question is coming in. When you programmed iMachining, you used a specific material. What happens if after you program the part, you need to change the material? Do you need to edit all the operations?
All you need to do is to change the material in the CAM part setup and just recalculate the operations itself. All the operations will be updated to the new material.
Thank you. I noticed there's another question. I noticed that when you were using the whole wizard processes, you had made a change in the whole size and the operations and tools were updated.
Correct.
What if instead of changing the size, you change the hole type instead? For example, change the hole type from a tapped hole to a counter bore hole.
That's actually a very good question. And because each one of those holes uses a completely different technology, even the amount of operations are different. However, since we are totally associative, that's what SolidCAM is, to the part, any change like the one you make will automatically be synchronized and the operations will be updated to the needs of that hole.
Perfect. Thank you, Sidney.
You're very
That was
welcome.
Great.
complexity of parts changing all the time and the capabilities of the machine tools evolving, how important is it to have the right CAD/CAM package?
It's absolutely paramount, and they have to run seamlessly with each other. You could, with all the technological advances you can get in the machinery, the CAD/CAM has got to be there to support it. Without it, you've basically got a standard 3-axis mill. It was funny, when I first got introduced to iMachining and I showed the guys here, both Pat and Lee, what it was going to do and potentially how it was going to run, they said to me, no, that will never work, that's never going to do that. But I said, look, you've got to have the face, the technology is there, they haven't built a business around something that doesn't work, and sure enough we put it in, and it's doing 18mm depths of cut with a 4mm step over, and it will do it all day long.
So with full 5th axis simultaneous movement and turning capability as well, how easy is it to program?
With SolidCAM, it's very, very easy. It's all very graphical. The simulation is seamless. You can understand what's going to happen, what's not going to happen, and detect crashes before they get down to the shop floor.
Is it giving you tool life longevity as well?
Yeah, definitely. Just you can manage your speeds and feeds. You can get clean cutting data. The tool paths are generally quite gentle on the tools as well. Particularly with the iMachining strategies. The service and training we've had so far has been great. Ben's always been on call. It's like a 24-hour helpline whenever we need it. Yeah, we can't fault the service support we've had from them, and I can see us probably buying more licenses in the future.
SolidCAM and SolidWorks work great for Keller and for the 5-axis. So we ended up purchasing SolidCAM at the machine show. So we decided to go in that direction because of the SolidWorks SolidCAM integration. And as far as positioning on the machine for the 5-axis, SolidCAM really worked well. And as far as my bottom line, as far as profit, I brought my profit up 50%.
大家好，我是深圳市朔方精密机械有限公司的王祖斌，我是负责那个技术支持的。今天呢，我们是SolidCAM公司的用户之一，今天在这里要分享一下使用SolidCAM软件的心得，从最早的选用到我们今天的实际成为SolidCAM的用户，我们也是经历了很长时间的。我们使用到行业当中的基本几大类的软件，基本上都用过，最终选定SolidCAM公司的这个款软件，比较适合，我们认为是比较适合走印机加工的。在走印机应用领域，我们使用该软件，成功的编出了很多用别的软件是编不出来的产品。今天呢有一个代表的产品，就是一个东方明珠塔，这个就是一个应用的一个范例。作为众多的产品的应用，就是这个其实这个其中之一，只是一个代表。在今天的这里呢，就不能一一展现给大家。
Thank you so much, Sydney. This demo really showed the power of SolidCAM.
Natalie, you know, there was a time that people used to think that SolidCAM is lacking in whole machining automation. Well, no more. In our current version, Ken Merritt, our VP UI and Automation, and Sydney Eisner, our VP QA, made major strides in the development of our whole wizard automation for best whole feature recognition and machining.
I know. Resellers are already very excited about this whole wizard automation. Sydney will be showing us the SolidCAM 2021 whole wizard features, and then Ken Merritt will talk about the upcoming whole wizard enhancements in 2022.
How better can it get? Like I always say, when two professionals brainstorm, great things happen. Sydney and Ken, let's show our attendees SolidCAM Whole Wizard Automation, what it can do.
Hi, I'm Sidney Eisner, and I'll be joined in this presentation by Ken Merritt, SolidCAM's Vice President for Automation and UI, about our whole wizard updates and future enhancements. The first part will be given by me on the whole wizard updates, and then Ken will join me on the future enhancements. So let's get started. Now, one of the first updates I'd like to talk about is actually something I like to call the hybrid feature recognition. Now, what exactly is that? Well, for a while we were able to actually recognize regular whole wizard holes, okay? If a hole was extruded, okay, and it had the exact shape of any of a whole wizard holes, and you thought it was a whole wizard hole, we were not able to recognize that because that was just an extruded hole. It did not come from the whole wizard. But now we can actually take those and recognize them as a whole wizard shape and include them in our whole wizard process. Let's take a look at how this works. Okay, if you take a look at the part that we have on our screen, you'll note the following. Let me go into the CAM tree, actually into the CAD manager, and you'll note I have several things. I have a hole over here. That one looks like a counterbore hole. I have another hole, for example, over here, and that in particular is a threaded hole. Now let's go to our CAD tree and we'll see the following. The tapped hole was actually a whole wizard hole. You can see that in the CAD tree itself. My extruded hole, the counterbore hole, what looks like one at least, it's just an extruded hole. So we have no way of knowing that that's an extruded hole. So this is exactly what I was talking about. So let's see exactly how this works. I can do it several ways. One way is I can actually do drag and drop into, say, that particular hole over there. Let me zoom in a bit. And you'll note, even though it's a CAD extruded hole, you'll see that the operations were created and it recognized it as a counterbore hole. Okay? Now, let me actually delete the operations for a moment. And what I'd like to do is drag to the face instead of to the hole. Because now I have on this face also these tapped holes, and I don't want to do them both. So it's going to actually recognize both types of holes. So again, I'm going to drag to the surface. And I'm going to let SolidCAM Holes Wizard do its magic. You see, it's creating the operations for the tapped holes, which are actual hole wizard holes, and it's also creating the operations for those CAD holes, for those CAD extruded holes, which are not hole wizard type holes. Okay, now let's get back into my presentation. The next update I would like to talk about is on imported parts. Now, imported parts are a completely different issue. They don't have any features. They usually come in as one feature called imported. That's it, nothing else. We have no information about any of the holes. But we are now able to scan the part, pick out all the holes, and assign them to the proper shape and process. Let's take a look at this in action. If we take a look at the part, you'll see that this is an imported part. You can see it has only one feature in it. Okay? So we have absolutely no information about any of the holes. But this is what I said now that we recognize those as well. For example, if I were to drag to this hole, okay, it'll not only recognize that particular hole, but it'll also recognize any hole that's exactly the same as it, make it into one group. You'll see that all these counterbore holes are recognized within the group because they are all the exact same shape. Let's do this to another one. You can see that this was recognized as a counterbore hole. Let's do this to, let's do it to this countersink hole over here. And it's going to do the exact same thing. It's going to recognize the countersink hole as it's supposed to be done, a countersink hole. You can see that in the CAM tree as well. And I can do this for the entire part if I want. Okay, so now let's go back to my presentation, and we'll talk about our next feature. And this is a really important one. Now, a major improvement we have done is color filter. One of the major issues that always came up was you may have two simple holes, for example. One of them may have been a very loose tolerance, where on the other hole, it may have been a very tight tolerance, like a dowel hole. Those holes might look the same, but they need a different type of process to drill it out. You can now assign different colors to the holes, and you can assign colors to the process as well. This will allow you to match the type of process you need for those set of holes. Let's take a look at how this works in SolidCAM. Okay, so if we take a look at the part, you can see now that we have those counterbore holes over here, okay? But I have this as one set of colors and this as another set of colors. I have the same thing with all the holes around here as well. I have different sets of colors. I may have one set because I want one more precise, and the other one, like I said, may be looser. Now, before I actually do that, let's go into the process itself. I'm going to open it up, and you can see now that the processes themselves can be assigned a color. So all we have to do is just match the color to the holes. How do we pick out a color? Very simple. All I have to do is just right-click over here, go to color, and I can just pick it from the model itself, and that's it. Okay? Let's exit out of here, and let's see exactly how this works. Okay. Now, before I actually use the actual color filter, let's see what happens if I don't use the filter, as if all of these are one set of holes. So I'm not going to turn on the filter. I'm just going to drag it to that hole. Now, since I have more than one process that's for that hole, and I didn't give it a filter, it'll stop and ask me, okay, which process do I want to use? Okay, I'm not going to do that right now. I'm just going to not accept any of that. Now I'm going to turn on my process, my filter for my processes. So I'll go to color, and the first thing I'd like to do is, let's say, machine out those holes over there. So I'm going to pick the color I want to filter out, just click on the part, and you can see that this color went into this area as well. Now, all I have to do is I'm going to drag it to the hole. Doesn't make a difference which one of those holes I'm dragging it to. I can drag it to this hole over here, drop it, and it'll only do the holes that are on top, because that is the matching color to that particular process. Okay, now if I want to do the other holes, no problem. I can switch colors, pick them from the model. I'll go back to here. You can see now that this is the new color. Now, if I drag to this hole now, you'll see that it'll do a different set of processes. You can see they're also in the name. I named them differently. You can see the first ones were regular counterbore holes, and the next ones were precise counterbore holes. Now, as we were developing this, something came across which bothered me a little, and I said, you know what, why do I have to pick out the colors every single time? Why can't I do that automatically? So we did something for that, okay? I'm going to delete everything I did over here, and I'm going to turn on a process called, with the color, auto color. That means it'll automatically recognize the colors of the groups and match them automatically to the colors that we have inside the process itself. And you can see right now, I'll get two different sets of processes. The first one for the counterbore holes, and the next one for the precise. Now, I can do this not only just for those holes, I can do this on the entire part. Let me delete again what I did over here. And what I'm going to do now is I'm going to drag to the surface. But wait. Remember I said we now recognize all types of holes? This big hole in the middle is also a hole. I don't want to machine that by drilling. Okay? So I want to skip that hole. There are two ways of skipping it. One way is I have a filter for hole diameter. I can go to my filter for hole diameter and simply pick on the largest one that I do want to do, say this one over here. If I click on it, that value will go into here, and then when I drag it to the surface, it will ignore that as well. One other thing I can do is instead of using that filter, I can simply say over here, right now it's taking all hole types. I can simply say, just take the CAD hole wizard holes. This way, it will not take that one at all, and I didn't have to use the hole diameter filter. But you know what? Since I already put in the hole diameter filter, so let's do that. So I'm just going to drag to the surface, and you'll see that it's going to create the operations for every single one of those holes, match them to their colors, and the process will be done automatically to the type of hole, to the type of tolerances you want to give. All that will be done very quickly without me doing much work at all. Very simple to do. Okay, just give it a moment. You can see the counterbore holes, both precise and the exact ones. Now it's dealing with the other counterbore holes that have at the bottom of the part. You can see that as well. And it's going around and doing every single one of those holes. Very simple. Okay, so now let's go back to my presentation, and we'll go to our next issue. Now, one more point I would like to mention. Color is a perfect way to recognize a tapped hole in an imported part or an extruded hole. You can just simply assign a hole process and to a color, and in that process, add the tapping operation. Let's take a look at how we can do this. Okay, if we take a look at this particular part, you'll note that I have 3 holes over here. 2 are colored red, and 1 isn't. Okay? Now, if I go into my process, you'll see at the very end, I took one of my simple hole processes, and I just copied it and gave it a name tap. And I also gave it that color. Now, if I were to go into that process just for a moment, just to show you what I did over here, you notice I added another process, another operation inside the process itself. And if we take a look at the process itself, you'll see that for that particular issue, we have a tap diameter. Now, this particular job shop, the way they normally get their holes in that are imported for tapped holes is they get the drill size in. So I made a process up for the drill size. I just did a small example. How did I do that? I just went into my conditions for the diameter, and if I go into my conditions, just a short show is that if the hole itself was 5 millimeters, the value is 6, as in an M6, okay? M6 for 1. Now this is for the meter rough, okay? If I wanted to do meter fine, for example, I would make a different process for fine with a different color. Okay, so let's see exactly how this works. Now, if I were to drag to this surface right now, what you'll see is as follows. It'll do a process. Well, you got me there. I forgot to choose my colors. I'm going to not accept it. I'm going to go to color, and I'm going to do it auto color. I'm going to drag the surface, and you'll see the following. It'll create 3 different operations. 2 of them will be tapped, and one of them, the middle one, as you can see over here, is just a simple hole. Okay? And now what I'm going to do is I'm just going to delete the operations that I did over here. Delete all. And I'm going to change the color from blue to red. How do I do that? Simple. This is already something inside SolidWorks itself. I'm just going to click on the hole itself, change the appearance. I picked up the color from this hole. You can see that in a moment. And you see that particular hole that I picked over there. Now I'm just going to add this hole to that list, and now it gets that color as well. I'll just accept that. And let's go now back to my hole wizard. And this time, when I do drag to surface, it'll again do three separate processes, but this time, all three of them will be tapped holes. As you can see, this time it did 3 operations for that particular hole, recognizing it as a tap only because I changed the color. If I were to go, for example, into my toolkit, you'll see that I have 3 different taps. I have a tap 6 millimeter, okay, 6 millimeter by 1. I have another tap over here that's 8 millimeters by 1.25, and my third tap over here is a 7 millimeter tap by 1. And now Ken Merritt will continue with SolidCAM 2022 future enhancements. So Ken, the stage is yours.
Hey, thank you, Sydney. That was a great presentation on Hole Wizard in 2021 SP4. And you know, our developers are really quite impressive. I can confidently say that they are one of, if not the best development team in the CAM industry. You know, from leadership through each individual developer, we really have some talented people. And I can't thank them enough for all their dedicated hard work that they've been doing on our software. Now, SolidCAM has truly become the industry-leading CAM system, and that's pretty cool. There are a great number of people responsible for that growth, and our development team is a large part of that success. Due to their efforts, we have a seriously impressive CAM software system. You know, and as we continue to enhance our automation strategies, we're already working on several new and powerful functions to make Hole Wizard even more amazing. I want to take the next several minutes or so to show you some of the items that we will be working on throughout the release cycle of 2022. Now, most of these items will be incrementally implemented in service packs over the next several months, so keep an eye out for them in the software as we begin to add them in. Our Phase 1 project, Feature Recognition, is a key to allowing users to automatically machine parts to their individual preferences. Now, model-based definition, or MBD, as it's known in the industry, requires that all machining decisions be derived directly from the engineering definition of the model. The more automated this process becomes, the less chance there is for human error, which really is the whole point of MBD. So we're developing a more robust recognition of whole features in support of this initiative. Now, this new effort allows us to add tolerance attributes to specific driving dimensions of the feature segments. This gives the user the ability to determine how the machining process uses the values from the model. Now, in this example that you see on the screen, the diameter dimension of the 4th segment, the main hole, is shown as an asymmetric negative tolerance for a thermal interference fit. Now, the hole diameter is the driving tolerance, and it impacts several driven dimensions. You can see those with the arrows pointing to them. These modified values will be sent to the Hole Wizard parameters for use in the machining process. Now, this method allows for automation across iterative design changes while still maintaining associativity and allowing for machining to the middle or mean of the tolerance based on the design intent. Now, this will start out as manual input, but in Phase 2, as we move forward with this, we will capture these tolerances directly from the Dimension Expert attributes when they're available, and we will automatically apply them to the recognition of a feature, thus making the full process automatic as well as model-based. As you have seen with the enhancements that Sydney just showed us in 21, color attributes can be a game changer. Now, for 2022, we will be enhancing the color functions to include segment-based color definitions. This will allow us to create processes that are compatible with several different requirements and can be automatically configured based on color matching operations with the assigned color attributes for each segment. Now again, this is going to start out as a manual function, and it will become more automated in later service packs as we build more power into the system. For any automatic machining system to work reliably, it must have exceptional tool selection capabilities. You know, the tool is really the foundation of any tool path. In the past, we've been able to filter how tools were chosen through the tool search conditions options in the CAM settings dialog. And this allowed us to identify which tool parameters were important and to use those to target the selection. Well, to make this much better and to utilize the strengths of our new toolkit in 2022, we're going to be implementing tolerances on these options where applicable, so that tool parameters that are near by the user standard to the exact selection criteria will be eligible to be selected instead of only those tools that match each individual criterion exactly. Now this will improve the odds of getting an existing tool that is already assigned to a project or a default tool table and is close enough to the calculated requirements to be useful, instead of creating a new tool for each iteration of similar features. Now we're hoping to have this built in early to mid service packs of 2022. Alright, to finish this up, I want to talk about something that I believe is very important to the industry, and that's imported models. As Sydney showed you, we have done some serious improvements in how we support imported models with our Hole Wizard. Our feature recognition engine is really coming along, and our developers are finding ways to make it so much stronger than it ever was. And hey, again, I'm so proud of the work that they're doing, and I'm excited to see where this next year is going to take us. But going forward, we're now investigating how to manage the application of product manufacturing information, or PMI data. And as recently as 2021 and 2022 versions of SolidWorks, there's actually been some notable improvements in their import capabilities. Now, STEP stands for the Standard for the Exchange of Product Model Data. And it was initially published clear back in 1994-1995, and it was a pretty significant publish at that time. It's much better than IGES. But it came out as ISO 10303, which was also known as STEP AP 201. Now, the standard has matured over the years, and there's been several APs or version phases that it's gone through, like 203 and 214, a couple of them that you might be really familiar with. But the current version, STEP 242, was originally published back in December of 2014, and it's been updated as recently as 2020. Now, the idea behind this translation standard is to really fit with model-based definition. And there's also been another initiative born out of the automotive and aerospace industries known as model-based enterprise, or MBE. These initiatives are really driven by the desire to automate all processes from the inception of the model design through the completion of component manufacturing and system assembly. And their hope was to minimize or eliminate the inadvertent mistakes that happen with non-digital communication of manufacturing intent. Now, these things happen especially when there are multiple engineering change orders in the life cycle of a part. And one of the most powerful aspects of this new STEP 242 version is its ability to transmit the PMI data, and that includes GD&T, or geometric dimensioning and tolerancing information. When this information goes along with the export translation of the digital model, and it can be received by the importing system, then the integrity of the engineer's fit, form, and function intent is maintained in a reliable fashion to be used in the manufacturing processes. Now, some CAD systems have been pretty slow to develop support for this, and have only recently begun to include full import and export of the PMI data. But our goal is to take advantage of this data to the extent that the CAD systems support it, and to automatically pass this valuable information along to the feature recognition engine, so it can be used to configure the machining processes with imported models in the same or a similar manner
to what we're already doing with the native CAD Hole Wizard features today. Now, in late 2022 and into 2023 versions of SolidCAM, we anticipate some very powerful automation capabilities with this Step 242 imported models. And we'll keep you up to date through the forum as we're able to start testing this functionality. I want to thank you for being with us today, and we hope that you enjoyed this presentation. Sydney, I'm going to hand it back over to you for some final thoughts, but thank you, everybody.
Thanks, Ken, for that excellent presentation of what we can look forward to, and thank you all for listening. Take care.
Thank you, Sidney. That was very interesting.
You're welcome.
We even have 3 questions from our attendees.
Okay, let it go.
So the first one is, I am having trouble getting the Hole Wizard to pick an existing tool from the part toolkit. The tool is there, but it makes a new tool instead of using the one that is there. Am I doing something wrong?
Well, it's probably that you have too many options selected in the tool search condition page in the CAM settings. Any option that are selected need to match exactly the conditions calculated by the process. Now, so what you can do is try it with just the diameter, tip angle, pitch, and see how it works. The tool search tolerance we are building in 2022 will enhance the tool selection, making this better and stronger.
Thank you, Sidney. The second question is, will the installed Hole Wizard process work with any machine and any material?
Okay. That's actually a very good question. People have asked me that many times. And that one really needs to be discussed a little bit. The installed process is an example. It is intended for you to study and learn from. These whole processes are specific to a class of machine based on the drilling cycles, which is usually the case. The machines have different cycles that are usually configured also in the post-processor. Also, generally speaking, the feeds and speeds are set by the author for a particular material type. So we made it easy to create a new Hole Wizard process for each condition that we need to handle. When you build your process to run the way you want it to, it's really easy. Do save as on the process that we created already, and just reconfigure your material. This will also probably you'll have to also probably redo the cycles on that particular process, and that's basically it. Adjust the speeds and spin rates. It's very, very simple.
Perfect. Okay, now the last question. Is there somewhere I can get some information on how to edit these Hole Wizard processes?
Actually, recently I've been asked that several times, and the answer is yes. There's a lot of information in the help documentation that is installed with SolidCAM. Additionally, during 2022 release, we will be creating tips and tricks, different videos that is. So keep your eyes posted on this SolidCAM forum.
Perfect. Thank you, Sidney. That was very interesting.
You're very welcome. And thank you all for joining us in my presentation. Take care and have a great day.
Hello and welcome to Lake News 22. I'm your host, Dave DeJohn. Today we'll be discussing computer-aided manufacturing, or CAM for short. With me is an expert in the field. His name is Eric Forwith. Eric has been with CAM and machining since 2006 and has over 200 plus installations of Swiss and advanced mill turn machines using Esprit and Mastercam.
Previous to today's technology, it was pretty much point and click, hope that your part was going to come out good. So a lot of the new age manufacturers want to handle their parts less. So the more complicated the part, they don't want to have to put it through 5 or 6 different machines. They want to put it in one machine, the new technology. So there's a lot of young people that are getting into the industry that are just overwhelmed right off the bat. And it's just something that really needs to be addressed for this advanced machining era that we're entering into. So as the technology of the CNC machine grows and you have more advanced products coming out, a lot of the CAM systems are definitely not keeping up with the new multi-channel machines, mill turn machines, Swiss machines. There is one software that I worked with a lot, Esprit, that did have a solution for every piece per se, but not necessarily in the best way that it could be presented to the operators or the users. So Esprit is a software I've used for about 6.5, 7 years. I've done tons of programming in it. It took me a very long time to get comfortable with the software. I'd say the better part of 2 or 3 years before I could really trust that what I was doing inside the software would relate to what was actually going to happen on the machine. It's just a huge learning curve. They are pushing Esprit into a new software that they call TNG. TNG is definitely going to be their future package. But everyone wants the perfect kind of program to just give me what I want, how I want it, and if it works, it works, and if it doesn't, let's fix what doesn't work and let's move forward. That's definitely not the norm from a CAM system. Normally you get what you get and you just go with it, and that's where the new age of advanced manufacturing is really pushing the envelope as far as software is keeping up with it, because it's a huge ordeal. But the general census is no, people are not switching to the TNG package. It's going to create a lot more havoc for the end user because they have to learn a whole new system from scratch. Right? So anything that's done in an actual Esprit file, if you bring it into TNG, you can see it. You can see what has been done, but you cannot modify anything. The only thing you can do is just a visual simulation of what you already have. So that's probably one of the biggest problems that I would run into repeatedly. And then they go and buy an advanced mill turn or a Swiss type machine, and their CAM package just cannot do what it needs to do to make that machine function correctly. And a lot of the big players in the CAM industry definitely are not keeping up with that trend. You're going to have more headaches than what that advanced machine is really going to give you at the end of the day. Everyone wants to basically get your part inside of a machine, hit the green button, and bring out a done part. So these advanced machines that are definitely made for that type of atmosphere where you're just running it all day long, the same part over and over and over, the CAM systems just aren't keeping up with that kind of a demand as far as. So I currently work at SolidCAM USA. I'm on a specialized team for advanced mill turns and Swiss type machines. I'm going to be going on site with customers, showing them the product, showing them the solutions to their parts that they need. I was able to learn the system relatively quick within the matter of a couple of weeks. I am confident in what I do, and I'm confident in the product. I'm confident in SolidCAM and our team that we've built. If you're using Inventor or you're using SolidWorks, you know, you've already got a step ahead of them. I really do think it gives operators and programmers and users a huge benefit being integrated into something that they're probably already using. The CAD side of CAM packages is always very infant. Being partnered with those CAD companies, we let them be good at the CAD because that's what they do. And we are good at the CAM because that's what we do. I've put more hours in Esprit than anything else, and they definitely have their downfall. Geometry selection is a huge headache. Changing the machine around is a huge headache. It could be 2 or 3 hours just to do something as simple as change a chuck, so that way when you look at your simulation, they do not like making custom machines, they do not like making custom posts. Stock updates in Esprit are probably one of the more painful things. Esprit, especially Esprit, is very complicated to use. It does not do automatic rest material. It does not do automatic anything. Very confusing. It did take me several years before I really got comfortable in the system. So that's probably where most of the CAM packages have their biggest issue, is multi-channel machines that require one side and the other side to be synced together.
iMachining is fantastic. I use it every chance I get. I do everything from big bolster plates to the tiniest parts that take a microscope to see on my machine. Every chance I get to use it, I use it. But there's so much more to SolidCAM than just iMachining. The 3D machining, the high-speed milling, everything.
iMachining has given us the ability to take parts that we had made before, reprogram them, take that G-code out to the machine, and not only reduce cycle time, but improve tool life. So you have a double benefit, obviously, if you can make your part faster and use less tooling, keep your end mills sharp, keep your inserts working. It's all there in iMachining. It's absolutely amazing. Whether it's 2D or 3D iMachining, it's amazing.
Thank you, Sydney, and thank you, Ken. You two really made a great job with the whole wizard.
Natalie, I will give you one guess about what our next presentation will be. And I will even give you a hint. It is our best and greatest module that saves tremendously on machining time, and no other CAD system has anything approaching it.
Well, that is not hard to guess. iMachining.
Bingo! Our next lecture is about iMachining. Anthony Calderon, our CTO, and Chris Calderon, his brother, the iMachining Wizard developer, and our great programmer, Senior VP of Algorithms, Doron Osovlansky, were the iMachining development heroes. Anthony and Chris both work very hard from our Newton, Pennsylvania office and technology center.
You know, Linda, let me share with you something interesting about Anthony and Chris. They both worked in their father's machine shop from the time they were 12 and 14, running his first CNC machine. So actually, they have been working with CNC machine their whole lives.
And it doesn't stop there. Now they are working together with Michael Vinetsky, our amazing Senior VP of Product Management, on the new eye-turning technology, testing it on our Haas ST30 lathe at our Newtown, Pennsylvania Technology Center.
So, Anthony, please tell us again the amazing secrets of iMachining that we are never tired of hearing again and again.
Hello everyone, thank you for joining the SolidCAM World 2022 Virtual Summit. My name is Anthony Calderon and I am the Chief Technical Officer at SolidCAM. Today's presentation is on SolidCAM iMachining, our unbelievable cycle time savings and unmatched tool life extension, using our iMachining 2D and iMachining 3D technology with our technology wizard. Our first product we released was iMachining 2D, the revolution in CNC machining. Some of the reasons for that you can see on the left. Our technology offers increased productivity due to shorter cycles, up to 70% or more, dramatically increased tool life, unmatched hard material machining, outstanding small tool performance, 4-axis and mill-turn iMachining. We have the highest programming productivity with the shortest learning curve. Our iMachining wizard plus our iMachining toolpath is the ultimate solution. Our unique iMachining technology wizard provides optimal feeds and speeds, taking into account the toolpath, stock, and tool materials, as well as machine specifications. Our unique iMachining features are that we use a minimum and maximum cutting angle along with a variable feed rate. We have 2 modules in iMachining, our intelligent toolpath generator, along with our full-featured technology wizard that generates a full suite of feeds and speeds. As mentioned previously, we use variable feed, and this is to keep a constant spindle load on the machine. When we are decreasing the width of cut, we are increasing the feed rate to keep a constant chip thickness, which also keeps a constant load on the spindle. Almost every line of G-code in iMachining will have its own feed rate. 2 additional patented features of iMachining is our morph spirals, which is only found in iMachining, and our intelligent separation. The combination of these 2 allow us to take a complex pocket, separate it into individual regions, and then have morphed spiral machining. And morph spirals are the best type of toolpath because it keeps the tool in contact with the material and decreases or minimizes the amount of entering and exiting. If we were to take a look at what a typical iMachining might look like for a complex geometry, we can follow along here. So first we start with a morphing spiral, and by morphing you can see how the shape of this spiral is not a circle. And you can see down at the bottom region, we can see more dense or closely packed toolpath versus the other regions around it, which are more spread out. Once we hit islands, we do what we call separating channels. This takes the islands we are able to finish around the islands, and after that, we can return back to our morphing spiral machining. Additionally, as the algorithm is continuing to see different topology during the cutting, it can do a separation island, as we see here, and then it will return back to morph spirals. So the entire goal of the toolpath is maximizing spirals. But iMachining is not just about roughing. iMachining also does rest material and finish cuts. Rest material is generally used where we have regions in the pocket where the larger tool could not fit into. And finishing, we do finishing of walls and floors. An important technology step that we do with finishing walls is that we pre-clean out corners where the tool would over-engage. And what this allows us to do is finish the entire geometry in one step down. This is very unique, and it also decreases the cycle time a lot and gives a perfect surface finish in the corner. This also makes a big difference when we have like 0-on-0 corner radiuses, such as machining a 1/4 inch radius with a 1/2 inch end mill. Here's a part, and we can see a few different iMachining toolpaths on it for different pockets. The general idea here is we see morphing spirals in the beginning, and then we go to, in this case where there's no islands, we just do trochordal passes, clearing out the rest of the geometry. Let's watch a video here on iMachining 2D. So this is a nice iMachining 2D part. We can see the cycle time of 11.5 minutes. What's really impressive about this part is it looks like you're machining aluminum, when in reality we're machining steel. So here's a morphing iMachining toolpath on the top. Here's our iFinish going around the outside. As you can see, it's doing it in one Z-step, or one step down. For all closed pockets, we are generally doing helical entry to get into the material, unless you've used pre-drilling. And here you can see some of the characteristics of the cutting. So in this steel, we were cutting at 14,000 RPMs, which is generally considered by many people almost impossible in steel and hard materials. Here we can see the video slowed down to 25%, so you can actually see how iMachining is working and doing its morphing spiral in the center of this pocket. As you can see, it's pretty amazing seeing iMachining in the video. It's even more impressive when you see it in real life. In today's industry and market, mill turn is probably one of the most important subjects, because even if you're a customer who only does milling, almost every customer is thinking or wants to get into mill turn. And what's important with mill turn is that our iMachining technology is also adding, I would say, even larger benefits in mill turn. Many times in mill turn, what we will see is that the tooling and the lengths of the tools are generally longer and might not be as rigid as what we generally see in a traditional milling or 3-axis milling operation. So here we have just some pre-cutting, which is just general milling. This is not iMachining right here. When we go to the subspindle and the part is transferred, then we'll actually see iMachining cutting. So here's iMachining on a subspindle. And many times the subspindles are not as rigid as the main spindles. So here, this is where iMachining and its constant load toolpath really makes a huge difference. As you can see, this is a simultaneous 4th axis cut. And in mill turn, for anybody that knows mill turn, generally when you're working on the face of the model like this, it's hard to have the complete machine travels to be able to do XY cutting to machine on the face of the part. So being able to do 4th axis cutting allows you to keep the tool in the upper quadrant where there's machine travel, and then the rotary axis spins to account for the Y-axis movement. And as you can see in mill turn, we achieve the same type of results that we achieve even in milling. And generally when you watch most people in mill turn, you generally see them on the milling side do very small depth, even smaller depth of cuts than what we do in traditional milling. A few years after releasing our iMachining 2D technology, we released iMachining 3D. iMachining 3D is utilizing the proven iMachining 2D technology and our technology wizard. Now, our iMachining 3D results actually give higher savings than what iMachining 2D is. And this works for 3D surface parts, such as molds and contoured 3D shapes, or prismatic parts, which are basically, pockets and islands. We have an optimized machining using Z-step machining or constant Z machining. And as I said, this is using our iMachining 2D technology for each Z level. We use deep roughing, which utilizes the whole flute length of the tool. And as this is what we do in iMachining 2D, to use this benefit in iMachining 3D, we use rest material machining, and we do upward steps, which is based on constant scallop height. This shortens the cycle time tremendously and brings the model to a closer net finish. We have intelligent localized machining and optimum ordering, and this is extremely important in 3D machining because a lot of times in 3D machining, CNCs are spending a lot of time moving from one area to the part to the next, and this is what we call like dead time, where the machine is just repositioning and the spindle's not actually cutting. So in iMachining 3D, we've optimized this. We use a true 3D updated stock the entire time, and this eliminates our air cutting. And our toolpath is automatically adjusted to avoid contact between holders and the updated stock. And this is really important for people that do big parts where they reach down inside of deep cavities. We combine this with our best-in-class HSM finishing, and iMachining 3D combined with HSM finish gives the best result for 3D parts. If we walk through some of the things that iMachining 3D does, we can do this now. So the first thing is optimum Z-slice machining. As I said, this uses the 2D iMachining algorithm at each Z level to remove the material. This includes our morphing spiral toolpath. Then our 3D algorithm automatically determines what volume to remove at each Z level, and this helps achieve the shortest cycle time. As I mentioned previously, we do deep step-down cutting. So if we look at this simple pocket here with these tapered walls, you can see we take a full step down, so this way we can get the largest metal removal rate for the largest area. And then we use our scallop-driven step up. And in our scallop-driven step up, we automatically adjust and find all the areas of the model with the appropriate down step, or step up as we call it, to maintain the same scallop height across the entire model. So if we look at the picture here, you can see what this means by scallop height. As you define the surface that you want to machine, which is the blue, we have the surface offset of what we're leaving on the model, and then we have the scallop height. And if you look at the model on the left, you can see for these two tapered walls, on the shallower wall, we have more steps. You can see that I think there's like 8 steps there. And then on the right hand, we have the 3 steps on the more steeper wall. And this is done automatically to give the most optimized machining. So we're not creating additional tool paths. The scallop-driven technology is extremely easy to use because it's just a single parameter. There is no guessing on what step down to use to leave the certain amount of material. And by using the scallop height, this generally is replacing multiple operations in a CAM program. That includes roughing, rest roughing, and semi-finish. So in one iMachining 3D operation, we are generally replacing a whole set of tool paths that people do in 3D. And this is where the cycle time savings becomes very large, and we are seeing people who do 90% and up. If you look on a more complex model here, you can see the differences of the step up and how we have different machining on the sloped surfaces. So we do deep depth of cuts, and on every area of this model, you get a localized region of step ups. And an important thing to note about this is our iMachining uses the technology wizard, and we automatically have separate feeds and speeds and engagement angles for each step that we machine. This gives an added benefit that we are increasing the metal removal rate as the step down is decreasing. Repositioning or linking movements is generally a huge problem in 3D machining, and especially roughing and rest roughing. You know, generally when you do the first tool and you do the first big roughing, the tool is just doing Z slices, and it's able to make a pretty optimized tool path from the point of view that there's not a lot of reposition moves. But once you do rest machining, and then you do semi-finish, you spend a lot of time with the tool repositioning from one area to the next. In iMachining 3D, we've developed an entire suite of technology that when you look at a part like this, there's no retracts at all. There is one entrance into the pocket, and it's able to machine all of those different Z levels, keeping the tool down inside the stock with complete collision detection from the holder and the tool. And it does all 3D linkings, and the tool just stays down and does cutting. In this tool path here, you would actually see G0 movements on the first movement and the last retract. That's it. Everything else is a high feed G1 reposition between the different Z levels. And no air cutting is something we've really strive for in iMachining 3D, and it's something we're very proud of. As we always talk about rest machining in 3D, because generally you are using larger tools and coming back with smaller tools to clean out corners, you can see how optimized our tool path is here. So just coming back with a smaller tool to clean out the corner, you can see the beauty of our tool path, how it's able to just start at the very bottom, it does a couple little passes to clean out the corner, steps up, and does the next one. And when you watch this run on the machine, it's almost like watching like a dance or something. It's just so smooth and elegant to watch the machine just stay in one region, do its cutting, and then move to another part of the model. As I've said before, we do have automatic cutting conditions per Z level. So this is where we rerun the technology wizard, so that way on each step up or each depth of cut, we recalculate what would be the optimum cutting angles and metal removal rates, and then we also adjust the feed rate because the feed rate will change for the engagement angle or cutting angle or step over. And this is done automatically without the user having to do any of this. Tangency and smoothness of the tool path is critical, which is why we use morph spirals, but the lead in and lead outs are also critical. And this is done automatically in the iMachining 3D technology. Every lead in and lead out is automatically adjusted for that area of the model, and it gives a smooth transition from one area to the next. And this is increasing tool life and machine life, because some of the most difficult or wear-inducive times and shocking times for the tool is the entrance and exiting of material. Now, we talked a lot about the technology in the tool path, but a major problem with using any tool path at all is calculating feeds and speeds. And this was something from the beginning of us doing our test cutting with iMachining that we realized we needed to provide a solution to our customers that would allow them to use iMachining as a tool, and it would be as easy or easier than any software that they already use. So let's talk about feeds and speeds and what we as CAM programmers have to figure out. When we look at generating a feed and speed for some part, we have to look at the material we're cutting, what tool we're using, the geometry we're machining, and then the machine it's actually being cut on. And there's many parameters for each of these things. We can see many parameters for each of these different categories, and this is kind of like an algorithm that us as CAM programmers do inside of our own head. So we are taking into account all of these things with the hardness, with the step over, the number of flutes, what is the maximum spindle speed of the machine, what's the maximum feed rates, and us as CAM programmers, we have to take into account all of that to generate some feed and speed. We've solved this by having an iMachining technology wizard. So this is an algorithm that takes in all of those parameters of the machine, the material, the geometry, and the tool, and we generate a set of feed rates, step overs, and spindle speeds, and depth of cuts that are synchronized, and more importantly, are fit to the machine and the limitations of that machine. And we don't just generate a single feed and speed, we generate a set of these, and we have what we call the iMachining slider. The iMachining slider allows you to choose between 8 different machining levels, with level 1 being the minimum metal removal rate, and level 8 being the highest metal removal rate. And essentially we can think of this as cutting force. So level 1 would be the least amount of cutting force on your cutting, and level 8 would be the highest. This gives us as an end user the ability to say, okay, I have my part, it's fixtured very well, it's not a very tall part, my tool is short, I can use level 8. But then if you go to a part where you think you aren't holding it as well, you know, there is a big difference between holding a part with 200 thou in a vise and only being able to grip on like 50 thou. So the iMachining technology wizard and its slider allows you as the programmer to adjust what feed and speed you want to use, but you're not actually typing and figuring out, oh, well, I need less force, so I need to change this RPM, this feed rate, and this chip thickness. The iMachining technology wizard gives it to you automatically. An important tool or byproduct of iMachining is anti-vibration technology. And this is our axial contact points. What this is that when we cut deep with a helical end mill, we are able to provide stability in the cutting by having multiple teeth in contact at one time. I like to talk about this in the scenario of a face mill. So if we think of a face mill, when a face mill is starting to enter the cut, we know that it makes the dunk, dunk, dunk sound of each flute making contact. Once the face mill gets buried into the material, it quiets up and we just hear the zzzz of the sound of the face mill cutting. And then when it leaves the material, we hear the dunk, dunk, dunk again. And when you look at a part for face milling, we see that in the beginning, there is a different wave to the surface finish, and then through the entire path, and then at the end, we see that wave again. That same thing where you have the inserts of a face mill, where it quiets up when you get multiple teeth in contact, this happens in the axial depth of cut using helical end mills. The iMachining wizard is automatically analyzing this, and we are able to provide feedback if you are going to have excess vibration to allow you to either change to a different tool or do something different if you choose to. We have 4 patents for our iMachining technology, and this is extremely unique. This is covering our iMachining 2D and 3D. Now, in the end, iMachining 2D and iMachining 3D is all about the savings at the machine. So we have a few examples here of different types of savings. So here's a customer who produces aluminum parts. They make electronic housings. And here's a simple part in 6061. And many times people think, oh, I cut aluminum. I am already cutting as fast as I can. I cut at the maximum RPM of my machine. I cut at practically the maximum feed rate. And there's nothing that iMachining can do. Well, we can see here, even on this simple part, it's not something complex or very tall or deep, we were able to take a standard cutting time of 17 minutes and lower that down to 6 minutes, which is a 65% savings. And an important thing we like to talk about is the total cycle time savings for lot runs. So for 400 pieces, this is 73 hours of saved machining time. Here's a simple bracket in titanium. So this customer had 75 pieces to machine. Kind of ironic, it's around the same similar time as the larger aluminum part we solved, which is 17 minutes. Here, we lowered their cycle time down to 3.5 minutes. The savings is 80%. And most important or not most important, but also important is the tool life savings. Generally, these customers machining titanium are only getting few minutes worth of cutting. So this part, they were probably replacing the end mill on each part. In iMachining, we extend the tool life longer than the 17 minutes, which is basically getting you more machining per tool. Many customers, or most of our customers, are using a combination of iMachining 2D and 3D. So here, this is a customer who uses both of these modules, mostly in aluminum for multi-sided work. And here you can see they're generally receiving 65 to 75% cycle time savings. iMachining 3D in steel, this is for this customer here who's machining 1020, with a 12 millimeter tool and just iMachining level 5, we took a cycle time from 146 minutes down to 28 minutes. And as I mentioned previously, the model is in a closer surface finish and better quality for the following operations for finishing. So we saved 81% cycle time in this, and the model is in a better state to start doing finishing. we can take a look at what iMachining 3D actually looks like on a complex shape. So here, when you look at the steps on this model, you can see here's a part where there's varying slopes, there's some vertical, near vertical walls, there's different slopes all over. Here we can see it starting from doing it in the deep depth of cut. So this is where we get the largest amount of material removal rate. Using the 2D iMachining is basically each pattern, and then we do step-up cutting. So here we can see it's doing just little areas and stepping upward up the model to attain the scallop height that we selected. And as you can see, it's basically, when it does step up, it's doing, in a model like this, it's doing very small cutting and generally lots of the corners and things like that. And this is something where you would need semi-finish operations to try to clean out those corners afterwards. But iMachining 3D does it automatically. Combining iMachining with our simultaneous 5-axis machining is something we're seeing with most of our customers who do 5-axis simultaneous. We can use iMachining 3D technology to do all the roughing before we go to 5-axis finishing. So here's an impeller, which is generally a pretty difficult part to machine. So as we can see, this is a pretty tall part. So this is, I mean, it's a very deep depth of cut, and you can see iMachining just eating away the material like it's nothing. We do our deep depth of cut first, as always, using the flute length of the tool, and then we start working upwards the model using our step up. And what you're going to see when this is done is basically like a flower kind of looking part, because that's what the roughing will look like once we get done roughing all the impellers. As you can see, you get spiral machining even on this part. As it's machining upward and upward, we are getting closer and closer to the roughed shape, or the rough envelope of what the impeller looks like. In this case, we're using 5-axis simultaneous to do the finishing on the top of each of the ribs, and also for doing the roughing or the slotting in between each of the ribs. I always think 5-axis impeller machining is some of the most interesting cutting to watch run on a machine. Since I'm from the US, I'd like to mention quickly our iMachining in the US and what we do. Pretty much we push for every single seat to include iMachining. And as you can see by our customer adoption rates, iMachining 2D is sold with 84% of our sales, and our iMachining 3D is 55% respectively. Customers who use iMachining are using it on every part. And we find that our customers are happier with less stress when using iMachining. And we have seen from many customers, they tackle new materials that they generally would not tackle in the past. And I think this goes with the less stress. They don't feel as stressed when taking on some material they've never machined before, because iMachining just manages it automatically for them. SolidWorks, SolidCAM, and iMachining is the best integrated CAD/CAM solution.
Not too many people learn about iMachining because it is my biggest competitive edge.
I think he says it better than anybody, why everyone needs to have iMachining. iMachining truly is the technology that will change your shop. Thank you for watching.
Thank you, Anthony. That was a very interesting presentation. I mean, I always love hearing about iMachining. And 3 questions have already come in from the attendees. So the first question is, if we already use SolidCAM, will we require additional training to use iMachining?
That is a great question. So additional training is definitely not required and in many cases, it is much easier than existing operations in SolidCAM. However, training can always be helpful to learn methods and optimize iMachining as well as best practices from our technical staff.
Okay. The second question is, do I need to buy special tooling to use iMachining?
No, special tooling is not required, but recommended tooling is solid carbide end mills. Additionally, many tooling manufacturers have created specialized tools with flute designs and cutting edges that provide additional performance when used with iMachining.
Okay, and the last question is, with faster cutting of iMachining, does this cause faster wear and tear to my CNC machine?
Great question. In fact, this comes up a lot. And no, in fact, iMachining constant load cutting causes decreased wear in CNCs, especially on spindle forces. By having constant spindle load with no spikes, the forces acting on the spindle are minimized.
Fantastic. So that does it, and thank you very much.
You're welcome.
Since moving to iMachining, we've seen a huge improvement in tool life, along with a reduction in cycle time. Now for us, it's not about cycle time because we want quality, and iMachining toolpaths give us that. We also find that the adaptive profiles mean that we don't have as many accidents on the machine, which is also hugely important. Now 3D iMachining is an absolute revelation. Those toolpaths with a one-click button, absolutely easy. When I'm using it, I always use iMachining as much as I can. It's just simple and it works.
We wanted something a little bit more modern. So when we started looking for a software package, there were a lot of them out there. We went with SolidCAM because it was integrated with SolidWorks, I really liked. And I like the graphical nature of SolidWorks, being able to see all the shading and you know, getting a good idea of what the part's going to look like. So SolidCAM really fit the bill for us, you know, especially for being able to have everything in one package. And I think what I like the most is that when I made a change to my model, all my toolpaths updated. You know, so instead of having to export again, it's just I just make the tweak, re-export the G code, and done. You know, so it works really well.
A small shop. It's just me, so I'm not keeping a large crew of machines going, and so it's also not my primary job since I'm a product designer. I don't run my machine often, but I'm always intrigued with new technology. And my sales rep kept saying, you really should try iMachining. Whenever I talk to the customer support people, they would say, now, do you have iMachining? And I kept watching the videos, and I said, man, this is really a nice product. It wasn't really something I needed from a time standpoint, but I thought, well, I'll try it out. And so recently they finally talked me into it. I did some more research. I said, okay, I will try it out. I've only been using iMachining now for about 3 weeks. And so it's something that I was very surprised at how fast I was able to come up to speed and learn it. The other thing that was pretty amazing is how much faster I can program parts too. But since I am a single person running my entire business, I want to design the part, come up with the G code, get to my machine, and make it as fast as I can. Because time is money. And no matter where you can save money, I'm going to take advantage of it. And in addition, I've been very impressed with the finish that it does by doing full-length cuts and what it will do to save me money in the cutters that I have to purchase also.
Hola, friends and family of SolidCAM. This is Maria Paez, Country Manager of SolidCAM Spain. Since in 2021, SolidCAM decided to establish directly with own staff. Now we are providing the best CAM and also the best service to honor our Spanish customers. I'm very happy to have this opportunity to sneak in this great SolidCAM Virtual Summit to invite you all at the BM show from 13 to 17 of June to the beautiful city of Bilbao. It's in the Basque Country, the north part of Spain, great industrial area and home of amazing machine manufacturers too. The BM International Show is the second most important show in Europe. It's every 2 years, but last one was 4 years ago because of the pandemic. Previous edition attracted more than 45,000 visitors around the globe. This time is going to be bigger because it will be the first show without masks, so we will be able to meet without covering our smiles. But also it will be more special and more genuine and more industrial than ever, also thanks to SolidCAM. And this is because in the SolidCAM booth, you will be able to experience 3 CNC live cutting, 5 simultaneous axis milling, Swiss type mill turn, and of course, SolidCAM unbeatable iMachining. As you know, iMachining is so amazing that no matter the words to describe it, you have to see it with your own eyes and also listen to the sound too. So even if you cannot join us at the BM, ask your local SolidCAM team and get ready to fall in love for the moment you see it, what iMachining does. This is what happened to me, and here I am. The first time I saw iMachining live was in 2011. Well, but there's more. We want everyone to experience high speed in their own body, like it happened with our CNCs with SolidCAM. We have our Formula 1 simulator, and it will be in our booth. It's with hydraulics. That means that it moves at the same time that you are driving. It's the same model that actual pilots are using to practice. Well, there's something else, but I'm not sure if I'm allowed to tell you about the special SolidCAM friends and family that will be joining us in Bilbao. So I won't say anything else. Anyway, contact us to get your invitation, and also you need assistance with accommodation and logistics at info@solidcam.es or solidcam.com, and go to the contact page and contact us in Spain. So see you in June in the beautiful city of Bilbao. And now let's continue to enjoy the content of the SolidCAM Virtual Summit. Adiós, hasta pronto, bye bye.
Thank you, Anthony. You know, we never tire of hearing about iMachining that revolutionized the machining world.
Absolutely. Okay. Our next presentation about our amazing Swiss solution will be given by Gordon Drysdale and Mark Stocks, the founder of SolidCAM UK. You know, Linda, Gordon and Mark have always been at the forefront of adopting our next and best technologies.
Right.
When they realized that our Swiss solution will be the best, they immediately hired 2 Swiss experts for post-processor development, which enabled SolidCAM UK to achieve excellent SolidCAM Swiss sales results.
That's right. They have also formed a very close relationship with Star UK, who gave them a Star ST20 CNC machine for their technology center. And at their SolidCAM UK booth at the recent MAC 2022 exhibition. You know, Star UK also recommends their Star customers to get the SolidCAM Swiss solution. Did you know that?
Wow.
Their Star CNC machine is used to demonstrate the Swiss solution at customer and prospect days and to make live cutting worldwide webinars.
Wow, let me tell you, SolidCAM UK is going places. And now, let's watch the presentation.
Welcome to the SolidCAM UK Technology Centre. I've got here with me Ben Miller, our Applications Manager, and we'd like to share with you how we made a success of selling Swiss-type solutions and the reasons behind our decisions.
Thanks, Gordon. So when did you create the strategy for selling SolidCAM Swiss-type and sliding head into the UK?
Well, Ben, in 2019, at the reseller meeting, there was a big push from SolidCAM and into the Swiss-type market, and we knew it was a growth market, and we'd been pushing SolidCAM for many years to deliver something, and we could see the product was ready. But it was clear to me and to Mark that the software was only part of the process, and the biggest part was delivery, mainly the post-processors.
Okay, so how did you plan to address this? I mean, surely we could have just got the post-processors from SolidCAM themselves.
We decided that the only way was to hire our own specialist and write our own post-processors, somebody that understood Swiss-type machines, and create the posts ourselves. Sure, it would be great to get posts from SolidCAM, but if changes are needed, and let's face it, most posts do need changes, that will lead to delays, and then we'll be no different to our competition. So in 2020, we hired our own specialist. Very quickly after that one, we saw that the market was so big and the opportunity was massive that we decided to hire a second person within 2 months. And we then started writing posts for the most common machines around.
Okay, what other strategies did you and Mark consider?
Well, we've long been advocates of partnerships, and we've had the Technology Centre now a few years. Within it here, we've got the Roman milling machines, and we then approached Star in the UK, and they kindly gave us an SR38 initially. That's now been replaced by ST20, you see here behind me. And having a machine has helped massively in terms of creating and developing posts to enable us to run live events. We also spoke to cutting tool people, Arno and Iskar. This particular one is covered with Arno tools, which again helps to promote them. So the benefits are massive for us and the partners.
Yeah, so I mean, we've been partners with Star for a while now. How long's that been now?
We've been working with Star now for over a year, and we've seen the relationship grow to the point where we've now delivered the software to their applications engineers, given them full training, and they're very comfortable with that, so they can deliver it to their customers, knowing it's a proven and fully tested solution.
Yeah, have we got any other suppliers who will recommend SolidCAM, or is it more a case of a bit of awareness? Or?
It is more about awareness. We are working slightly with Citizen. We don't have a direct relationship with them, but they are happy to mention us when talking to their customers, which is, in fairness, mostly what we needed.
Yeah. Who's been the main competition to SolidCAM in the Swiss type and sliding head market?
Our main competitor has been Esprit. In the early days, we could see that the market perception was that they had a more mature product, they had a larger library of post-processors. But as we spent more time developing our own post-processors, that perception began to change. And the major factor for us is that we have local support here in the UK. So all the support is developed and development is done right here from these offices. That's a massive benefit to the customer, because if they want a change, we can act almost immediately and react to any questions we have. Crucial to gaining happy customers.
Yes, I mean, do you think the strategy has worked?
Yes, absolutely it has, yes. We now have many customers of the Swiss type market. I think we're now probably the #1 supplier in the UK, and I can see our position getting stronger.
Yeah. So, in conclusion, can you summarise the route to success in the UK market before we hand over to Mark for a live demonstration?
Yeah. For success, we need a great software, and SolidCAM delivered that. We need to create our own post-processors, therefore hiring a specialist, and partnerships. Working with companies like Star has made this possible, so we can break into the market and conquer it.
Okay, great stuff.
Yeah. Thanks for watching, everybody.
Thank you, Gordon. Thank you, Ben. Before I go through a quick presentation in SolidCAM as to sort of give you some feedback from one of our experiences in the UK, I just want to give a bit of feedback, put a bit of meat on the bones to what Gordon's just said. We've been working with sliding head technology in the UK for several years now. It's a very big and important market in the UK, and in a way we're a little bit lucky. We've got two main players. We've got Star and we've got Citizen. Yes, there is some handware around, yes, there's some Tornos around, but predominantly it's Star and Citizen. So we are fairly lucky that we've got the two main streams of machine out there. Now, we've been working with Star for around about a year now. We approached them to try and get hold of a machine to demonstrate our capabilities. So we put the machine into our technology centre, and obviously for that we're very grateful for Star for giving the opportunity. But the reason why I want to go through this side of it is because it actually leads into how we want to demonstrate SolidCAM for the sliding head market. And this is quite important, I think. So when we want to come across, get this across in demonstrations, it's important to understand from the customer and from the machine tool supplier's point of view. So our experiences with Star started off that we were convincing them that one, we could do the job, but two, we could actually support it and do everything else as well. And again, flipping that around, looking from Star point of view, they've obviously had software in there which their engineers use to program parts for customers, and obviously which their customers have been using. But it's maybe been knife and forked a little bit. It's not been 100%. So both the customers and, say, the machine tool suppliers are sceptical that this can actually be done properly and fully supported. So that's one of the things on there. And you've got to imagine that both Star, when we started working with them, and the customer base have been basically working within their own type of framework of program and maybe copying and pasting parts of programs in there, doing all the weight codes manually, and then proving it out on the machine. And that's typically a very typical way of doing it. They're either writing it longhand on the machine, or they're writing a lot of it longhand and then copying and pasting in some of the complex things, maybe out of some CAM software which they've manipulated in editor to try and make it work on this particular machine. That has been quite a common theme. So the reason why they're doing that is because software really hasn't proven itself in this arena to be reliable and to be well supported on that. So whether it's because the software doesn't cover and doesn't cope with all scenarios, or whether it's because post-processors aren't developed or taken to the correct level and supported properly, there's various reasons for this. So this is where we've got to come back and look at that and say, okay, we're working with Star now, we're working with this customer. We need to convince them and overcome these obstacles and these historical reasons why CAM is not being used as much. So we obviously took the Star into our technology centre. Star have obviously seen us program on these machines, so it's become a lot more trustworthy from their point of view that we have the capabilities on there. In the UK, we've taken on specialists to develop post-processors. We write and support 100% of our post-processors in the UK. That is a massive thing for the local market, so for whether it's for Star, whether it's for Citizen, whether it's for the customer base itself on there, to actually have everything supported locally is a new concept for them, because in a lot of cases what's been happening, if they've had software to drive these machines and then taken it out, they had a problem, for example, and they've gone back, it's having to go back to some other country, some other person to correct it. We can do that all in the UK, and that is something which is very important. I would encourage everybody to try and get to that level on there, to be able to do everything locally. It makes a massive, massive difference. So basically what I'm saying is we've got to, if you like, undo a lot of the preconceptions for CAM, things which have been developed by, if you like, other CAM suppliers or customers using, if you like, their milling software, converting it in editor, chucking it onto the machine and that. So we've got to try and convert that. So that means we have to get their confidence. 100%, that's the most important thing which we need to do. We need to be able to demonstrate that we know what we're talking about. We can go in there and we can work as a partner with the customer to help solve all their issues. So this becomes a very, very big thing. We've done that in a couple of ways. Obviously through Star, they're giving us great recommendations now. So they actually understand all this, and they understand that we're working towards getting that. They've also recommended we join the BTMA, the British Term Parts Manufacturing Association, which is just an association, a body, which a lot of companies, a lot of suppliers are members of. And obviously they can talk about the situation, talk about the market, talk about what possibilities are out there. We have meetings quarterly and that type of thing. And it is absolutely brilliant, because in a lot of cases when we turn up these meetings, probably 90% of the customers, or the customers there, are our customers. So it is really, really good, and it backs up that we are actually doing a good job, and we can show the support for that. So if we take that through to the demonstration environment on there, what we need to do in a demonstration environment when we're in front of the customer on there is we need to get their confidence that we know exactly what we're doing. So that becomes probably the main focus of what we're actually going to do. So I'm going to run through a few highlights and things which I would always say we need to concentrate on when we're demonstrating on that. But there's a few golden rules as well which we need to do. And this is how we work, and this is how we've been very successful in the UK. So if we're going to a demonstration, I understand markets are different, and I can only talk about the UK market. We will always go on site. We will always sit in front of the customer. We need to get their confidence, we need to get their support. If we were to do it remotely in the UK, and I know, as I say, different markets are different, and we did a demonstration on site and another CAM company didn't, they did it remotely on there, we'd be questioning their application, and questioning why they haven't been on site. If they're not on site now, how are they going to support you? Are they going to come out on site, or are they going to do all the support remotely as well? So again, we feel that face-to-face is very, very important. When we go on site, we always take a customer part, blind. We'll take it in there, we'll have a look at their part, and we'll work on this part. That's the same for all our demonstrations, but I feel it's actually more important for sliders as well, for Swiss type. So there's a few golden rules. We take their part. We try and keep the demonstration as simple as possible. Simple looks easy. And if we can keep it easy on there, the customer thinks it's easy, is convinced it's easy, and can take a lot of information on board. But you can only keep it simple if you fully understand the software and fully understand the machines which you're demoing on. The actual, say we're going to put this on the Star ST20, for example, we need to understand the full capabilities of that machine. Because we need to be able to say, okay, I've got this part here, the customer's given me this part on there. This is the machine they've asked me to put on. First of all, why have they asked me to put on this machine? Is this the only machine they've got, or is there a reason for it? And for the Star ST20, it may well be because we've got 3 turrets on that machine. So we've got lots of superimposition we can do. We can be machining on 2 turrets together. So we can pair things up. We've got lots of tooling options on there. So there's lots of space going on and lots of things we can do about it. So we need to be able to understand that. And even if the part doesn't actually contain features which we would use, we should be talking about it. So that's sort of in advance, and that's what we want to show. And I say a few things on there we're going to go through on there. In terms of content of the demonstration, well, I'll run through this on here. I'm going to take a part which we've just recently done. So this is the part which we've just done this part, and we took this to a big exhibition, and we were cutting these parts of the exhibition on there. So I can run through what we've done on there, and there's a reason again why we're showing various features on there to give the correct output, to give the correct impression to the customer. So okay, let's go and have a look at the demonstration and give you some recommendations in terms of what we found very successful over here in the UK. Okay, so in terms of what we want to show when we're demonstrating and how we want to present things, probably one of the most important things we want to get across is just how graphical, how interactive SolidCAM is to work with these machines. This machine can get quite complicated, so the more feedback the software can give us at every point, the easier it becomes. So on something like this, I've already started the session on here with creative datums on that. So always I'd go into setup as you must do anyway. But this is a very good introduction to actually show the machine preview in the background at all points. And it's worth emphasising this is there not just in setup on here, it's also there and available within the tool library. It's available within every operation or every MCO. It's always available so you can see exactly what position the machine is at the time. So here I'm just focusing on obviously on the main spindle, on the guide push here, and we can see the components sitting there. So obviously we're now going to move that across to the sub spindle, so we can put onto there, and then it's worth showing exactly how we're going to, or where we're going to grip the part for transfer. So again, it's very, very graphical, see exactly where we want to be on the part and set that accordingly. So that's the first sort of introduction in terms of what we need to show. Okay, so I've just skipped along a little bit now, and we've got the part with some basic programming on there. Nothing clever on there, but all I've done on that, just to sort of save a bit of time going through it, they're just standard operations, but you tend to work differently on sliding head or Swiss type to you do on a fixed head machine. Fixed heads you tend to work outside in, it tends to be general rule on there. You'll turn the OD, turn a lot of work on the outside, and then go to work on the insert side or the internal work. On a slider's reverse, you do the internal first because you need to maintain the bar diameter for as long as possible on there to make sure that you don't fall out the guide bush. Obviously, that's the only thing which is really in contact locally with the part supporting it. If we turn the OD away, then that contact and that support's gone. So we need to be very wary of that to make sure that, one, we don't return the bar back into the guide bush so it falls out and we lose support, or two, we actually get rid of that too far. Yes, on a lot of machines we can work in non-guide bush mode on there, but it's worth actually understanding that we need to sort of keep that support local. So this is what I've done, obviously, for a start. So let's just have a quick look. And what we've got, again, keep it simple. Simple simulation as well. You've got all the different options to show this in machine and solid and all of that. But still, one of the most important ones is to show this. It's a turning operation, so keep it simple. So now we can see on there exactly what's going on. So we've taken this away. This is deliberately left on the front because I want to machine the front face as well when I come and put that pattern on there. So we're always going to leave that on there. But now we've got this area which we need to turn on the back. If I turn this and bring this out this way, when I come to do the work later, that's going to fall out the guide bush. And that's going to give me a problem. So I need to think about how I can get rid of all this material away from there without retracting it back in the guide bush. And this is one of the strengths of maybe the ST on there, because we've got double Z axis. We've got a Z axis on the lower turret and obviously the Z1 axis on the bar. So this is now a very good introduction to show MCO's machine control operations to it. So we can add the machine control operation to it and say, okay, I want to move Z1. I want to pre-position Z1 and we'll move it out 28 mil. But again, we've got the machine preview, so we want to show that so we can see where the bar is and obviously where it's moving to as well. This gives us room to get access in behind on Z3. So we're not going to be using Z1. This is now stationary. We're now going to be moving using the tool and using it like a fixed head on the lower turret. Okay, so this is just basic turning on there. So again, we can add the turning operation to it. And okay, always work showing just how easy and quick it is to add geometry to the part or add cutting areas to the part. It's literally a selection directly from the model. We haven't got to extract any edges or manipulate things. Everything's direct from the model, which is a big, big plus. So on to here, we've just set the geometry. We're going to pick the tool for it. So obviously we've got a good idea to emphasize exactly where we are. Always show them machine preview so we can see exactly where every tool is on the part as well. See where everything's set up. We can obviously emphasize on there that we can support the multi-tool holders as well. So we've got lots of stations on single positions within the turret. So again, we can pick all on there and then obviously select whichever one we want, whether it's this tool, whether it's the lower tool on there. That's completely up to us. So we can go and extract that from there. So there's our first tool. So it's worth also pointing out on there that we've got two modes we can move this. This lower turret can work so that it's using the Z1 axis on the part, or it can use its own independent one. We've already positioned the part, so we now need to use the Z3. But it's just a case of changing the mode over in here. That's all we need to do. So again, just a couple of quick parameter changes on here. We might as well finish this while I'm in here as well. And we'll set that to go. So again, very, very simple. Now normally on there, as you'll see from here, we wouldn't normally want to start from our safe corner over here because that's going to retract the bar back into the guide bush. However, because we're using this as a fixed head, that one is, in this particular case isn't very important. So again, it's worth maybe just talking about that with the customer as well, and just explaining the different reasons for doing it. So that's done on one. Nice little option on here. We can just do a save and copy. Nice button. We use this off a lot because it just saves a lot of mucking around. So if I just come in there and now just change that tool, and instead of using that one, the forward-facing tool, use the back-facing tool, I can just save and calculate that, and that's now done on the back. So again, reuse of information. Because the material management's obviously always handled, then we can see exactly what's going on as well. So let's bring that in. Another tool, actually you may want to reverse that. Again, simple change. Because it is so graphical, we can see exactly what's going on at every point. So if you do make mistakes, and obviously don't be afraid to make mistakes in the demonstration, because customers are going to. It's how you react to that in the end of the day. So again, we're now bringing that back up and finishing it. So again, very, very simple, but very, very powerful. Now maybe on something like this on there, maybe I would at this particular point just do a quick introduction to machine simulation, so we can just highlight and show exactly why we're doing it and what's going on. Just emphasize. So basically what's going on there, the bar gets pushed out, and then we're using the Z3. Okay, so this is it basically programmed. So what we're doing on there, we've got nothing clever going on. We've got our pockets being done around here. Now I could copy those around, but I'm not going to. I'm going to leave those done individually. There's a reason for doing that as well. Obviously deburr in the front on there. Every part which we cut with on our machines has to come off with deburr. More and more parts from all customers now coming off 100% deburr. So it's a very, very important thing to be able to show that and show how it's actually working on there. As our transfer, then we're working on the back. Again, nothing really too clever on it. We're just extracting geometry. We're just working on this as a local operation on there, and everything's clever. But now it comes to the bit which we do need to emphasize a little bit of. We've now told the story. In fact, we've done all the machining on the main spindle, we've done the transfer, all the machining on the sub spindle, and we've projected the part. So that's the part complete. But channel synchronization is a massive thing which we need to show. So let's just set that back as it was. So this is obviously as it was programmed. So we're switching between path 1 and path 3, all the way down. We do our transfer, and then we're working on the sub spindle and all our work on the back. So yes, we can take that all up the top and tidy that up. So that gives us our optimized time. So again, let me just undo that a couple of times to get back as it was. And we were pointing out, I've got machining time of just under 17 minutes, 16:47. By the time you've optimized it to run the back work at the same time as the sub work, we're down to 13-14 minutes, so we just saved a load of time. There's not a massive amount on the back, so it's not costing us an awful lot of time. So we maybe need to look at other ways to actually optimize this as well. So on path 1, we were machining one of those side pockets. Then we're machining the side pocket on path 3 and backwards and forwards onto here. So what if I was to delete that and try and do both of those together? You can see SolidCAM automatically recognizes that that is possible, and it puts it into superimposition. So very, very good feedback to understand exactly what's going on. So I've now done that for 3 sets of pockets. But it's also worth pointing out that in here we're doing a lot of checks to make sure everything is 100% working and everything is valid as we're doing it. Because I can see now, because this is greyed out down the bottom, I've got a problem. So it's showing me across here that these are absolutely fine. But if I put my clash detection on there, I've now got a problem down here. Because we go into superimposition mode here, we don't actually come out of it. So I need to add another option onto the bottom to come out of superimposition on there as well. So the only other thing I need to do is I need to change the mode. So we'll set that into superimposition, and we'll set that to neutral, and then that will allow us to come and do all of that. So we have this set up so that normally going into superimposition mode will retract the turrets on the machine. We obviously want to stay local, so we don't change we leave these in what we call a neutral one, which keeps it in its current axis pattern. We'll just set that back to turret 1 because it's on there. So this is now, and you can see on here, we're now down to just under 9 minutes. We've just halved the cycle time by doing a lot of this, by doubling up on operations. So we can see a lot of it's going on. So this is something we may well emphasize on here. We can go into and do a lot of what ifs. So, okay, if I put that one with that one, will that save me time? Can I do this and that together? So again, a lot of it on here, we can then graphically see exactly what's going on and how we want to play around with it as well. So again, all of that is all built in and worth it. Now, before I come to simulating, because obviously we want to show that on the machine at the end of it as well, we will always G-code it. You've got to imagine, as I said earlier on, The customers are used to their style of code and looking at code and maybe manipulating code and putting it in and out of editors and changing things around. So they're used to looking at code. We need to get their confidence up. We need to get them to understand that SolidCAM can do this job for them. So we would always G-code the file. This is very, very important to actually give the customer confidence that what we're actually generating is going to work, and they'll understand that it's going to work. So you've got to bear in mind that a lot of the customers are still writing code by themselves. They're writing this by hand, longhand, so they're going to understand this code. And then typically they're going to look at places on here to try and find out exactly where potential issues may be, or okay, does this look like my code? So they're going to run through this and see exactly what's going on, see the weight codes being married across all three channels and everything else on there. So it's very, very important to actually see and to show the customer, yeah, okay, we've now done all this graphically, we've shown all the tools, all that, everything looks good there. But this is the most important thing. So this is something which we'd always show the customer so they can see and understand exactly what's going on. So all our weight codes, everything there is all ready to go down to the machine now. So just in recap on there, a lot of things which are obviously demonstrations on there. I'm not teaching you how to suck eggs. English expression, look it up. Then what we're trying to do is try to give you a bit of a few pointers on there, things which have worked in the UK. When we're demoing, just as a recap, when we're demoing, we always take the customer apart. As I say, we try and keep it simple. Simple works, simple's good. But as I say, that can only be done if you understand the machines and understand the software very well. Show just how visual SolidCAM as a tool is, so we can show all the machine previews and everything else on there. Extracting geometry or picking geometry directly off the solid model is a massive thing on there. The tool library, as we're adding components to it, so we can add holders directly onto the mounting points onto the machine or whatever. So again, all of that is very dynamic and talkative. One of the most important things when you're taking parts from the customer is to talk to the customer. If they give you a part, say like this, don't naturally assume that you know best on how to machine it. Talk to them, ask them how they're machining it and what the problems are. You'll get good feedback then as to actually understand where their issues are and what you could possibly show them, which will clinch the deal. So it's very important to talk to the customer and get their feedback onto it. Things like deburring on this particular part is critical, but it's also something which is near enough impossible to do that by hand. So again, show that. Same for superimposition. Superimposition or style is 2 M codes or 2 codes. It's a tiny thing to actually do, but to be able to actually visualize that and to make sure that it's actually possible is a completely different ballgame. You need to have a lot of experience for it. SolidCAM is just automatic. You just marry those 2 operations together and channel synchronization is done. So again, with channel synchronization, show a few possibilities in there. Again, machine simulation. Typically, unless I'm showing something which is, as we did earlier with the Z3 axis on there, I wouldn't necessarily go into that within the demonstration. That's something for the end, something so they can see it when it's all channel synchronized together and everything's working on there. But always G-code it. Always give the customer a chance to have a look at the G-code. This is where their confidence has got to come from. If you can't build up trust in what you're doing, you're on a back foot for a start. You need to have or need to give that confidence to the customer that you're not only going to provide them with a solution now, you're going to be in a position to be able to support them going forward. And that is critical. Thank you.
Hopes are, at least for Northern Nevada, is that not too many people learn about iMachining, because it is my biggest competitive edge over local competitors. If you don't have iMachining, you cannot compete against me, because I will cut the part in a fraction of the time and not destroy tooling. And I have many examples, but the biggest impact that I saw was in cutting difficult materials, stainlesses and Inconels, and many of the difficult to machine materials that are just known for chewing up very expensive cutters.
iMachining extended our tool life upwards of 10 times.
Thank you, Gordon. You know, that partnership you formed with Star is super important.
Let me tell you something. Emil has made it his mission in life to hire the best people for every field, and Marina Velkina from St. Petersburg, Russia, is one of them. She is our worldwide expert in our amazing multi-channel advanced mill turn and Swiss solution, including complex CNC kinematics, CAM programming, and post-processor development.
Wow, that's so impressive. I also have to add that she's also an advanced training for these technologies for our staff and resellers worldwide. She always manages to dazzle our staff with her expertise. So if anyone needs the best training in these fields, she's your person. Go, Marina.
Hello and welcome to the summit. Today I will talk about features that we have inside SolidCAM, helping us to program Swiss type and advanced mill turn machines. For today's presentation, I've chosen a question-answer format. I've made a list of programming challenges and associative questions and going to show how SolidCAM can support it. The name of the first challenge is Machine Architecture. If you ever saw a cutting video or opened a machine catalog for Swiss or advanced mill-turn machine, you know what I mean. There is a wide range of machine constructions, advanced multi-channel, multitasking machines, Swiss-type machines, and you will need a flexible solution to fit them all. Here I have a couple of slides showing machine kinematics. It looks like there is no limit of how machine can look like and from what devices it can consist of. The construction of turrets and number of channels can also differ. Machine can have a Lego structure. For example, as you can see on a slide, you may set up different attachments. You can combine them in different ways. You can even add additional attachment after you got the machine to your shop floor. That means we have very various functions for machine and working the zone that can offer even if name of the model will differ. SolidCAM can cover all variety of machines with any complexity because we have a powerful tool to build them inside SolidCAM. I'm talking about Machine ID Editor application. It has proved and clean machine tree structure where I can take all necessary devices like stock table, tool table, bar feeder, part cutter, and even custom device that build machine that I can build machine that I need. Moreover, I can assign devices properties, axis, limits, and CNC behavior. I can add channel information, axis patterns, and finally build the model for the machine simulation. All I need in one application. The next challenge I would like to name is the variety of tools, holders, attachments, and any other devices that could be added to fix the tool on the machine. Here you can see different holders that could be applied to a simple, very common BMT rotary turret. This slide shows holders for driving tools. Some holders could be aligned with different angles. That means you may have one holder with different angle setup, and this could be a problem when you would like to represent this in CAM system because you need to change your angle. Situation becomes critical when we move to Swiss-type machines. Here we can see how one machine model could be equipped with different attachments, and that means not only that we need 3D model of attachment to represent Swiss machine working zone in CAM system. This also means a different structure of G-code. The output should have special parameters given CNC information about current machine setup. Else, each type of attachment will need its own style of offset output. As a conclusion, we can say that attachment matters. The answer for this challenge is Toolkit, one and only. If you never heard about it, please find information, detailed information and overview in our video tutorials. I'm going to name several advantages of Toolkit now, and we'll explain a little bit more about it. First of all, it is supporting of any type of tool holder, attachment, or machine removable device for cutting tool. The second one is import of 3D model. You can import a 3D model for example, one piece of the assembly. You can import all the assembly or any part. You can even import an insert. Everything that you want could be represented as a 3D model. The next good feature and advantage of Toolkit is configure properties of each part of tool assembly. As you can see, a toolkit is built based on the tree, so it's a well-known tree structure. And you can click on each part of this structure, each part of the assembly, and assign it properties. If it has an angle, if it could be removable, if it has additional drive unit, whatever you like, you can arrange this information inside toolkit. The next advantage is adding any number of cutting points and offsets. You can add multiple joint holders, as you can see on a slide. This holder has 4 positions. It's not a problem. Add as many joints as you would like to have it. You can store tool and cutting data also inside toolkit. That means you can add information about different cutting conditions. You can also add information about the producer, about the cost of this tool. We have 3 levels for tool library. This could be a library of components, library of assemblies, and library of machine setups. And the next advantage is called running of toolkit apart from SolidCAM. That means that you can run this application without running SolidCAM, and you can take all data or add data to toolkit apart from SolidCAM. This is amazing. And the last one point, which I would like to pay your attention on, is easy machine setup with preview window, drag and drop of your tools or part of assemblies, and for sure it is holder swap commands. For example, as we can see on a slide, there is a setup for Swiss type machine, and this machine can have these holders on different places. You can easily, with just one click, swap these holders inside toolkit, and you will get a new construction for your machine working zone. That's amazing. Okay, let's go to the next challenge. The name of the next challenge is Special Approach to Program Structure. This mostly consider it for Swiss type machines, and I would say in a machine manual there will be a special chapter which describes how machine program should look like and what rules it will use. But please imagine situation when you have a ready program for a part, and for example it is already coded, and you have to transfer this technology to other machine with different program structure. You may have this problem both from manual and CAM output, and you have to know the decision how you can do that. Well, SolidCAM provides a variety of tools to support any program structure. We have a number of special functions in VMID file. That means post-processor will care about special output format. All you need to do is to choose another machine, another post-processor in your new project. Also, we have a very useful operations, which is called MCO, machine control cycles. You can program such operations as part ejection, moving of subspindle with or without part, positioning of stock with Z-axis for Swiss type machine, additional tool change, any M command or sequence of commands, whatever you need. We can add custom project variables to change output format with one click, and many other necessary tools to meet machine and customer demands. In terms of operation complexity, programming of advanced mill-turn machine could be also very high. You may have to program both milling and turning operations from 2.5D to 5-axis simultaneous, and also some advanced mode for lathe operations. We should also consider different CNC programming modes. That means the same geometrical element could be outputted with different G-code, and machine movements will also differ. The answer is yes, we can support them all. This nice video shows how different types of operations could be combined in one project. SolidCAM has a powerful clean, efficient, and easy-to-use operations for 2.5D milling, 3D roughing, finishing, 4-axis simultaneous, 5-axis indexing, and simultaneous milling. System supports all range of turning operations, including balance cut and other types of toolpaths, even manual toolpaths. One more challenge that you can have to be very careful to is when you're trying to organize operation sequence. I'm talking about multi-channel synchronization and axis combining modes that most Swiss-type machines are supporting. SolidCAM provides an excellent tool for synchronization of channels and organization of operations. As you can see, this is just a screenshot of our amazing tool, which is called Channel Synchronization Table. Here you can order all your operations. You can add weight marks to divide these operations, and as you can see under weight mark, you can also choose an axis pattern, which will rules axis exactly for this operation. Also, you can see information about axis for the first channel and for the second, which axis will be used now and which will not be included to the output. You can move operations in the list and you can see all the information. The next very nice feature that we have inside synchronization table is a clash control. It will give you a tip if something will go wrong. For example, if you can do this synchronization, if you need to add additional weight mark and you will have a text tip what is wrong. For example, if you're trying to use axis that is not allowed to use for this channel. And for sure, we can support as many channels as you need. For example, this is a screenshot of the synchronization table of 6-channel machine. Okay, the next challenge that we can avoid and we can support is axis combining mode. I would like to name just several types of axis modes that we can support. We can support more, but I just would like to tell you about several. The first one is called axis synchronous control. I decided to start with it because each Swiss-type machine should have it. This mode is used 100% when you're doing your cutoff. Also, you can clamp your stock into spindles, do the synchronization of the speed and phase, and continue your cutting. For example, you can do turning, you can do threading, and also you can do grooving and cutoff, and everything in one mode. What is special about this mode? The special thing is that Z2 or any other axis, we call it slave axis, is ordered and moved after the main master axis. For example, on this picture from machine documentation, you can see that Z1 axis is our main axis. It will rule Z2 axis. This is what we call axis synchronous control. And this picture shows how we can manage this process inside SolidCAM. This is internal processes inside MCO cycles. As you can see, we can choose which axis will be master, which will be slave. On the right side, you can see that that machine had 3 axes, and you can choose how it could be combined inside the software. But for the customers, we have different other type of interface. All this information is hidden under the cycles. All you need to do is just to choose cycle from the list, and that's all. It is done. Okay, next axis combining mode called mixed control. For sure, in different documentations, it has different names. For example, cross-axis control, axis recomposition, or composite control. On the left side, you can see a picture from the machine documentation, the normal or basic control axis, and axis which are included to mixed control. For example, you can take axis from other channel and manage this axis to program it in other channel. This is what we call mixed control. And this is how you can manage it inside SolidCAM. Again, you will need axis synchronization table. operation synchronization, and you can use different submachines to choose what axis will be main, what will follow, what you can do with this machine. On the picture you can see the machine with 3 main turrets, and it has 2 channels, and you can choose, for example, which axis will move. Here you can see Z1 axis comes from stock. Also you can have Z axis on a turret, and you can choose how it will be cutted. Do you need to cut it with a stock movement, or you're going to cut it with turret movement? You will choose, and you will have this information inside synchronization table. And the last combining mode is called balance or pinch cutting. This is very famous type of operation. On the left side you can see how it's going for the turning machine. You can have 2 cutters and your stock is rotated. That means that these cutters have the same drive unit, so they divide a drive unit. And on the right side you can see how this process is operated for milling. They have a separate drive units because it's mills, but they have the same stock and they should go simultaneously. This is what we call balance cut. We have a separate type of operation for balance turning. It is called balance rough operation, and you can convert normal turning operation to balance rough if your machine has this functionality. If your machine has 2 cutters and 2 axes to move these tools. So you can do this through our normal operation interface. And inside the synchronization table, you will see information. If your operation were converted, you can see this operation is doubled in a second channel, and also there are signs about what axis will be synchronized, and that drive unit will be divided for these 2 operations. For the milling process, for the milling pitch cut, we have a little bit different situation. You should create 2 operations, add them to the synchronization table, and put the same weight mark for both of these operations. And again, you will have information from the system which axis will be synchronized. In this example, you can see that Z-axis and C-axis, the angle, should be synchronized for both operations. The next challenge is predictable operation setup and verification. Swiss type machine setup is a very important stage of programming process. You need to carefully follow instructions and track outside holder lengths of tools and other dimensional data. One more problem is axis strokes that could give you this error message and even after you run your G-code on the machine. We have several tools to meet this challenge. In SolidCAM, you can have predictable operation setup and verification. First of all, it comes from setup process. Before you will start to add milling and turning operations, you should go to machine setup. You can open a machine preview window, and you can add fixture, for example, as a 3D model, or it could be a sketch for a jaws. You should arrange the position of jaws inside spindle, or if it's a fixture, you can arrange its position on a milling table. And also you can see this information on the machine preview. And after that, you can put the position of stock and target aligned according to this position of jaws. This is the first step. The second step is putting your tools, adding your tools and attachment to a toolkit. This data is also critical. You should do it as exactly as possible, because the length of the tool will matters for some machines, for example for Swiss type machines, because working zone is really limited. But you can see it and you can do it inside toolkit again with machine preview. After that, you can use machine control operations, and also each operation has a very nice button to call machine preview window and to check the position, current position of axis, to check all information you need. So you have a precise control on each step of programming. And as a final tool that you can use is machine simulation. This is also an amazing tool that will show you the complete information about all the project. If you have any stroke limits, if you have any gouges, all this information will be shown. You can also run it block by block, like a single block on the machine, and you could get all this information easily. Okay, we are coming to the end, and the last two challenges is easy change and output of G-code and saving data. One more important issue is the possibility to quickly and easily change operation order, to add or delete them. Data storage is also critical. What if you will have to return to the current project in 3 months, half a year, or 1 year? Will you remember tools and cutting conditions you had there, tool setup, and other information? Yes, we have a solution for this also. You can easily change an output and saving data. First of all, I would like to remind you that you can have all your CAD data inside your CAM project, because SolidCAM is integrated solution to SolidWorks and Inventor CAM. The second one is that storing of all tool data is available inside a toolkit application. The next point is easy changing, adding, removing, or swapping operation inside the CAM tree, because CAM tree is very flexible tool. You can just drag and drop them and recalculate. You can store and apply channel synchronization, and all these programming challenges could be solved with SolidCAM. Okay, thank you for being with me. I hope you enjoy it. Goodbye.
Thank you, Marina. I saw 3 questions came in already. The first one is, how can I quickly and easily add my own hard code to any place of the CAM tree?
Well, machine control cycles are the best solution for this issue. There are 4 operation types available in SolidCAM. Just 2 of them for cutting, for milling, and for turning. One is for probing, and the last one is for this issue. This is called machine control operations. If process that you would like to add is constantly repeated or hard code, we can save this as a cycle. That means you do not need to program it again. Just choose it from MCO cycle list, which stores in VMID file. So it stores in your post-processor. 2 clicks and you're done.
Nice. So the second question is, we get a stroke limit messages and machine stops very often because working zone is very limited. Can SolidCAM predict software limits and will not let us continue G-code generation?
Yes, this is an amazing function that we have. SolidCAM led us to create a complete virtual copy of your machine. Basically, it consists from 2 files, VMID and machine simulation. Stroke limits is a part of machine access description. We assign machine 0 position, home position, and axis limits. There with values and signs. This is what you need. To get a true information about axis status, you need to add a real data to setup window, place a fixture on a table or inside a lace spindle, and also locate position of stock as you're going to have it on a machine. True tool data is also important. You need to have tool assemblies as they are in reality. That's all. You can program your part in SolidCAM, and system will give you a warning message if axis comes to its limits, and machine simulation will show this information also. So this is how you can do it.
Thank you. The third question is, somebody's asking, my question is about tailstock. We have a set of different tailstock centers. They have different lengths. So when we try to move tailstock, we get different machine coordinates. If SolidCAM can support my set of centers with machine coordinate output?
Working with coordinate system used while programming is very important for advanced mill-turn machine. Some operations may need both machine and part coordinate output. SolidCAM cares this issue for sure. Based on valid machine virtual model, we can get true machine and part coordinates at any programming steps. Tailstock center, consider it inside a system as a fixture. You can add this as many fixtures as you need to the project. It is a removable component, but tailstock as itself, it's a constant for a machine. It's every time it is on a machine. And it will be a part of post-processor and virtual machine model. This is how SolidCAM will join data from current project and from machine itself.
Sounds good. Thank you, Marina.
You're welcome.
Hi everybody, my name is Vika Friedman, Vice President of Sales for Israel and Japan. The subject today is our new version of Shop Floor Simulator and Shop Floor Editor. Great products. Most medium and large size machine shops, staff, work in the CNC field in two main levels. The first level are the programmers, who are technologists and engineers, who get the original SolidWorks model and their role is to determine the machining strategy. They are usually professional with the CNC technology, the capability of the machines, and the machine technology. They have the CAM tool, SolidCAM, that you can see here. Just we are staying in the department, the programming department. And by SolidCAM, they program the machining process using a variety of machine operation for milling, turning, mill turn, and Swiss type. At each stage of the process, they can use the CAM part simulation as well as the machine simulation. And finally, they produce the G-code file for the relevant machine using the post-processor the SolidCAM provides for all the various CNC machines. Okay, the second level in the CNC machine shop is the level of the CNC operators, who are responsible for getting the G-code file, the list of the tools, a chart that's showing the parts clamping, including the location of the ohm and the position they need for the setup. Actually, the operators, they need to perform an initial dry run with utmost care, step by step, at the machine to verify that indeed the CNC program prepared by the programmer is error-free, with no collision, and that the CAM part will be executed well and in the right dimension. Look, in many machine shops, there is complete separation between these two levels of the programmer and the operator. And an existing problem is the lack of understanding of the part machining. This operator actually returns to the programmer with questions, while the programmer is already preoccupied with programming the next part. This happens day by day, and in addition, minor changes are sometimes required in the program. Look, such as changing the cutting condition, changing the offset of the tool, and so on, this can also lead to large problems in the workflow. For example, when the programmer and the operator are working in different shifts. To solve this problem, we have created two spatial SolidCAM versions for CNC operator, solving the dilemma that exists in almost every machine shop, and to streamline the machine shop work. So we have the shop flow editor version. It can run standalone or inside SolidWorks. It enables the shop flow operator to do a minor changes in the SolidCAM CAM part, like feed, speeds, and downstep, recalculate, simulate, and create new G-code file right by the machine. We launch now also the shop flow simulator, which enables the operator to see a full simulation of the CAM part, to see the tool list with full details, to understand the clamping, the on position, and to see the entire picture before they run the G-code and they run the machine. These two new products are low-cost solution with a big value to many of our customers. Thank you.
Thank you, Marina. We are really, really lucky to have you.
You know, Linda, Zvika has been with SolidCAM for ages. He's a brilliant sales guy, and today he's the Vice President Sales of Israel and Japan.
He is also an excellent sales guy, and he also knows the SolidCAM software inside out. With his combined sales and technical expertise, he manages to convince almost any lucky customer to get SolidCAM, iMachining, and our mill turn and Swiss solution.
Right. He has made SolidCAM the absolute #1 in our local market, cornering 80% of the total potential CNC machine shop market. That is no easy feat, and he's advancing in the direction also in Japan, working closely with Tactus, our major SolidCAM resellers in Japan.
So kudos to Zvika. Today, he will give a presentation about our new shop floor suite, which he is very excited about. Zvika, the stage is yours.
Hello, everybody. I am glad to be again in this amazing summit. And this time I will talk about a very useful tool of SolidCAM, the shop floor package, which addressed is the CNC machine operators, which stay in the front line close to the CNC machines and ready to prepare the setup and push the green button. Let's see what is the CNC department levels in most workshops. So the first level are the programmers, who are technologists and engineers, who get the original SolidWorks model, and their role is to program the part. They are usually well experienced with the CNC technology, the capability of the machines, and the machine technology, and they have SolidCAM in their hands, with which they program the part using a variety of operations for milling, turning, mill turn, and Swiss type. The second level in the CNC machine shop is the level of the CNC operators, who are responsible for getting the G-code file, the list of tools, the chart showing the parts clamping, including the location of the arms and the positions, and they need it for the setup. They need to perform an initial dry run, which utmost care, step by step at the machine, to verify that indeed the CNC program prepared by the programmer is error-free, with no collision, and that the CAM part will be executed fluidly and in the right dimension. The goal of the shop floor package is to give the operator to control the entire program before running the machine and to understand the machining process without the dependence on the programmer who is already busy in programming the next part. If you think what we have today in SolidCAM 2021 to the setup department, well, for that we have powerful and easy to use options. First, we have the shop floor editor, which allowing the operator to make changes in the entire operations, in the toolkits and in the setup, and simulate the entire program by a variety of simulation that offers by SolidCAM. We have also the shop floor light, which allowing the operator to make minor changes in the toolkit, like cutting condition, feed rate, spin, tool renumbering, and of course to simulate the entire program. And the third option is the shop floor simulator that allows the operator to see and simulate the entire program by a variety of SolidCAM simulations. We will talk about it in depth as we're going along. If we think why CNC operator need shop floor seats. So first of all, clear picture. With the shop floor, the operator has all necessary tools before cutting. Clear tools picture and mounting, full 3D simulation and fixture, and setup view prepared by the programmer. Change minor parameters. Sometimes, the CAM programmer is new to machining or to the CNC machine, or has less experience than the machine operator. The shop floor editor lets the shop floor operator flexibility to make minor changes to improve the process. Working in shift. Sometimes the machine operator is working on a different shift from the CAM programmer. Or maybe the CAM programmer is not available to make changes. So the operator wishes to make minor changes, for example, increase or decrease the step down for a pocket, or make some changes in the cutting condition. So now with the shop floor editor, the operator can make these changes very easily. Outsourcing programming. Some companies are using outsourced services for their machining. So instead of just receiving the G-code, the machine operator can receive the CAM part of SolidCAM, check it, do minor changes, and simulate the entire process before machining, thus understanding it better or making changes if needed. QA department in the factory, in the workshop. The shop floor is a great tool also to the QA department. They can see the entire process, understand what was the programmer's idea, mainly with the multi-position part, when they need to measure sometimes during the cutting process. Okay, so to summarize the 3 types of categories of the shop floor package. So we have the shop floor editor, which let the operator to modify the edit operation, to change the toolkit, to change the part setup, to get a full simulation, include machine simulation, and to regenerate the G-code file. We have the shop floor light editor, which let the operator to change minor changes in the toolkit, to see the full simulation and to regenerate the G-code. And we have the shop floor simulator, which let the user full simulation and regenerate the G-code. Okay, I must point out the fact that we began develop the shop floor editor first, and the other two categories are maintained due to customers' request and due to internal factory consideration of them. Okay, now let's switch to SolidCAM to see it in live. So let's now demonstrate the shop floor version inside SolidCAM. So if the operators needs to run the setup and cutting the part without the shop floor, for example, for this kind of machine, this is a Multus mill-turn machine with the back spindle, main spindle, and main turret and upper turret. So without the shop floor, he probably get from the programmers the G-code file first. He need to get the drawing of the model, maybe some picture of the model, the tool sheet with detail about every tool, holder, how they mount inside the turret or the spindle. You need to get some sketch or some picture of the setup which show him the material clamping in the main or in the back spindle. So what's happened in the most cases is that there is a partial picture for the operator, and it's required him to return and ask many questions, the programmers. Also, he cannot see simulation and needs to run the program like a blind, without confidence and without really understand the machine movements. With the shop floor version, it's totally another story. So let's see why. So first step is to go to the stock, to see the stock. Show 3D, and we can get the stock, and we see that stock is from a bar. It's for turning. We go into the target model, again, show 3D. We get a nice picture that shows us what is the target model. The operator can rotate, can see the picture of the target. Then you move to the, if you want, you move to setup and want to see how the programmer defined the setup. So we have here, you can see that we have main spindle and we have back spindle. And in the main spindle, we understand that we mount the material 79 millimeter from the face of the main spindle, and if we touch the back spindle, we can see -9. But we have another tool, we have a machine preview that we can see exactly what's happening. And actually we get the simulation of the machine. Make here zoom, and we can see very nicely that we have the material, how the material is clamped, and we can see inside the material also the target model. But in the other side, in the back spindle, it's empty now. Why? Because if we will go to the back spindle and we click on the stock in and activate the machine preview again, then we can see that the part is in the back spindle and it's mounted as it needs to be. Actually, the operation by the MCO is to take the material from the main spindle to transfer it to the back spindle and finish the part. We can see it later. Now let's move to the toolkit, which is extremely important for the operator. So let's see what we can gain from it. So we open the toolkit, and we can see, first of all, tool number 4, for example. You can see very nice the holder, the insert. And now we want to understand how to hold this tool, how to mount this tool. So we have also the machine preview, again with the machine. If we zoom here, so
we can see in a green light, this is the tool in station number 4. Let's return, let's minimize it. Put it here, for example. And let's see another tool. This is tool number 2, for example. This is a shape tool. The shape tool is in station number 2. You can see exactly the shape and to understand it. And let's see what is tool number 5. Tool number 5, we can see very nice holder. It's a turning tool. And let's see how it's mounted here in the machine. No, it's not in the turret, the lower turret, but it's mounted in the spindle, in the upper turret. Let's see another tool. Tool number 2. It's a milling tool. See the tool, the holder, and we can see here in the assembly of the tool and the holder, we can see that it is HSK A63. We can understand what kind of holder is it. You can see exactly the parameter of the tool. See the diameter of the tool. We don't need to guess, we don't need to look at a drawing or some sketch. We have here the CL, the cutting length of the tool. And if we want to see how it mounts again, how it mounts in the machine, we have the machine preview. And we can see very nice how it mounts. So, to summarize, the operators gets all the list of the tools. You can see the holder, you can see all the details of the tools. You can see how it mounted in the machine, and this is helping very much to prepare the setup. Okay, but this is not enough in order to see the entire picture. So for that, we have a very strong tool, simulation. First simulation is our new simulator. Let's move to it. SolidCAM simulator. That will show the operator exactly what he will get after machining. It's very nice simulation. You can see the bar, you can see the clamp. Now let's simulate it. Let's move it slowly. But actually we cannot see what's happening exactly in the machine. So for that, we will use after it the machine simulation. But this simulator is fantastic to see the picture, how the final target will look like, and if there is some problem with geometry and so on. See now the last operation is the cutting. But what you cannot see here is how the material is moved, transfer from the main spindle to the back spindle, how the material is pulled out from the main spindle and so on. So for this we have the machine simulation. The most important tool in the shop floor version, mainly in such advanced machine, is the machine simulation. With it, the operators can see the exact picture. You can see the movement of the tools. You can see the safety movements of the devices between operations. And you can simulate everything forward and back and can be sure before pushing the green button. So let's see this part with machine simulation. Okay, we see the simulator of Mazak Integrex. The material is in standby in the main spindle, and we can start. So let's run the first operation. We can see here is a turning operation with the lower turret. Then come another tool. We can see another tool is coming for a milling tool, work from the top. And now we can see some stopper that come and pull out the material. Let's stop here and we roll back the operation because we want to see exactly what happened here in this case. So let's zoom out a little bit. You can move, rotate, okay, and then now we can see that the back spindle with the stopper is move forward to the main spindle, clamp the material, and then pull it out a distance that the programmers wanted during the programming. And the reason in this case is to prevent material bending during the cutting. Let's continue. Now we can see that in the main spindle, we can see a tool that positioned with a turning, also it's turning tool, and also in the lower turret, also a turning tool in the right position. And if we continue, we can see that now we have a turning operation that called balance rough. Two tools that working together. So the operator can understand exactly what is happening when he will see it running in the machine. Continue, and now until we come to the last operation, the finish. And we finish with this operation, and now continue with milling tool. Let's run it. We can see that we have here an index movement. The material is rotate every time in the right angle. Continue the cutting. The operator can check and see that all the devices are in the right place, no collision. And now again, the back spindle pull out the material. The part itself now is clamped from both sides, from the main spindle and by the back spindle and by the main spindle, and now is very suitable position to cut. So we continue now by the shape tool to make the slots. And cut off. This is the last operation, I think. Let's go step by step. You can see a grooving tool here. Can be sure that everything, the environment is okay. Zoom again. And now the part, let's put it again, part is transferred to the back spindle. And this is just the last operation. So the operator now can be sure that everything is okay. No problem, no collision, and he can continue and run it live in the machine without fear. Another very important tool in the hands of the operator is the ability to change operation parameters after first dry run in the machine, when it could improve the cutting process. Let's see an example for it inside SolidCAM. So perhaps the operators want to change something in one of the turning operation here. Let's open the screen of the operation, and we can see this is a balance of operation, and I want to change the cutting condition, the feed weight. The feed weight is 0.3, and the operator wants to increase it a little bit to 0.35. And also you want to change another parameter. For example, the down step, the step down here is 0.6 millimeter, and the operator thinks he can make it bigger. So let's put 1 millimeter here. 7, calculate, simulate, and now we can see also another type of simulation, very nice and good for turning. It's a turning operation which can you see the 2D simulation, and very nice. You can see the both tools in this particular operation that works together to make the balance off. So actually we have 3 types of version to the shop floor. Shop floor editor, which the operators can simulate and also have the ability to modify, change parameters in the operations, but it cannot change the geometry. Another type of shop floor is a shop floor simulation, which let the operator just to simulate the entire part, in the operations of course. And there is the third version is shop floor light. In shop floor light, the operator can change just the cutting condition or the tool, the numbering of the tool. Okay, let's go back now to the PowerPoint to summarize and explain the benefits and advantages of the shop floor version to every factories. Okay, I hope you enjoy the video and in SolidCAM, the live in SolidCAM. And now we'll talk about Simco Editor. So Simco Editor is a very strong tool in the hands of the operator in SolidCAM 2021, and it's a simulator that runs on the G-code file and give an accurate picture to the operator and almost 100% confidence before cutting. Simco Editor had integrated to SolidCAM, and we delivered directly to Simco Editor the G-code file, the tool with all the data needed, fixtures, stock, and target. And of course the setup on position. And the results, which maintained from Simco, is a clear toolpath on the target model and also full solid simulation. I can tell you that today in the market, we deal with a very expensive and complex part. And the Simco Editor is a fantastic complementary tool to use inside SolidCAM. Okay, let's see to the end, what's the factory benefits to work with the shop floor package? There are many, but the major benefits are: first, preventing machine and tool damages. The ability of the operator to see full solid simulation inside SolidCAM give him the confidence which prevents unexpected crashes in case of programming mistake. Second, efficient work. The independence of the operator with the shop floor package without the need to interfere the programmer that is already busy programming the next part. It means efficiency to the factory. Okay, and full setup picture. The SolidCAM shop versions give the operator full picture about tools for the job, setup definition,
stock clamping, on position, and of course full simulation includes machine simulation. And last, very important, improve operation skills. With SolidCAM shop floor package, the ability of the operator to improve his knowledge and to move ahead is very high. Okay, I think we got the point across very well. We already sold many seats in Israel in the last 2 years, and I'm sure almost every factory will be very happy with it. I would like to thank everyone for joining us. Stay tuned for Linda and take care.
Thank you, Zvika. That was a very interesting presentation.
Thank you.
And a new feature of SolidCAM.
Of course, and very important.
So now I see there are a few questions from the attendees. Let's see. The first question is, can the shop floor editor suite be combined with SolidWorks?
Okay, Linda, yes, definitely. It can even be a great combination for a factory manager or production manager who wants to see model in SolidWorks and also to understand the programming process performed by the factory CAM programmer, including full simulation and machining time for the part. It could also be a fantastic pricing tool for managers.
Nice. Okay, second question. Does a change made by the operator with the shop floor suite update the original CAM programming?
Certainly, Linda. Actually, there is no limit for it in the shop floor version. This is already a question of organizing the internal files in the factory. If the factory keeps the data on the network, everything is updated at every stage. And of course, after changes that made by the operator who use the shop floor suite.
Okay. So the last question, why are there 3 types of versions for the shop floor? There are different prices?
Linda, first of all, there is 3 types of versions. Shop floor editor lite, and shop floor simulator. Cost the same price. And the reason for having 3 types came according to customer request, who want the shop floor to be appropriate for their workshop policy. For example, if there is a workshop who don't want to let the operator to make changes in the program, but just to simulate before running, so he gets the shop floor simulator.
Makes sense. Thank you, Zvika.
Okay.
我们现在这个产品呢，就是用到了这台设备这图纸。那么我们这个材质是不锈钢316L 的，我们用到了一个 SolidCAM 的编程的功能，让我们加工出来这样一个零件。在过去来说的话，这样的零件我们是无法加工出来的。现在有了 SolidCAM 编程软件，我们就可以很轻松的做出这样一条非常漂亮的一条一个一次性加工的，包括这里，这都是一次性完成的。
Our next presenter is David Somech, who is SolidCAM's Chief Information Officer. He has been working for 16 years in the company. He is responsible for Salesforce and many other information management tools. He is now also responsible for the solid metal marketplace with his team. This marketplace will be the perfect meeting point for our CNC, for our SolidCAM customers with CNC job buyers worldwide. So David, can you tell us about this amazing marketplace?
Sure, Linda. Happy to. What is Solid Metal? Solid Metal connects buyers with manufacturers all over the world. It's a cloud platform that connects CNC shops using SolidCAM, manufacturers, and potential buyers that need to machine parts. The platform is free for SolidCAM customers under subscription and with iMachining that can register as manufacturer. The platform is free for every potential buyer that need to machine parts. So, if by accident you are not on subscription or without iMachining, make sure to renew today. How does it work? Well, the manufacturer registers and adds information about his CNC shop, machines, additional machine shop capabilities. Buyers register and can see the directory of validated manufacturers and their contact details. Buyers can contact the manufacturer directly through the platform with online chat or also call the manufacturer. Buyers can upload their project details, due dates, part files, job description, and bookmark their favorite manufacturers. So as you can see, very streamlined process, very simple, very user-friendly. What data does the manufacturer provide about the CNC machine shop? List and details of CNC machine. This can be imported directly from the VMID directory of SolidCAM. Machining materials, aluminum, steel, etc. Industry types, automotive, aerospace, medical, etc. Additional job shop capabilities, assembly, casting, coating, etc. So, reach new customers and grow your business. Find buyers all over the world. With Solid Metal, you can publish your CNC shop worldwide. You're no longer limited to your own country. Get your parts programmed and machined by our manufacturers using SolidCAM and iMachining, the leading CAM software. So I will say it again. You need iMachining and subscription to be on that platform. So get it today to get new business. Chat with hundreds of potential buyers. Everyone likes to chat. It's user-friendly, it's fun, it's fast. So, publish your CNC machine shop. When you complete your profile, upload as many details as you can about your CNC machine shop. Pictures, really as much details as you can to have a great looking profile. Thanks for watching, everyone. I'm David Somech.
Not so fast. We have a question coming from one of our attendees.
Sure, Linda.
They're asking, why does the SolidCAM customer need to be on valid subscription and have iMachining to be able to offer his services?
Well, Linda, we want all our SolidCAM customers to be on a valid subscription to benefit from our latest and greatest version, SolidCAM 21 SP4. And obviously, to have iMachining and enjoy its amazing advantages. If we are going to recommend a SolidCAM customer to the CNC shop buyer worldwide, we want to make sure he's using our latest and best technologies and thus being able to provide a good quote to the CNC job buyers. A SolidCAM customer with no iMachining will always have a higher quote from SolidCAM customer with iMachining.
Okay, now there's another question. Can a manufacturer also publish his projects and outsource them?
Yes, definitely. Glad you asked that. When you register as a manufacturer, you see the directory of other job shops like yours, and you can contact them. Also, you can publish your own outsourced projects and get offers.
Thank you, David. That was very interesting.
Thank you, Linda.
I am Tejpreet Singh from Kartar Group, Kartar Brothers Private Limited, Ludhiana. I was looking for various CAM software, but what I found was SolidCAM was the best one in the field, and it has made me money many times its cost, and I am enjoying its usage. Thank you very much.
Eurostampi è un'azienda di lavorazioni meccaniche, è un'azienda che nasce nel 92 da due ex colleghi di lavoro e decidono a un certo punto di affrontare questa esperienza. Gli stampi in quel momento erano molto richiesti, nel tempo Eurostampi si è evoluta e un po' alla volta è andata nella meccanica di precisione. Il software in ufficio tecnico ci ha permesso di organizzare 4-5 frese contemporaneamente con un unico operatore che dall'ufficio gestisce i percorsi CAM. Un altro dato sempre molto importante che ci ha portato questo software è la diminuzione notevole degli errori. La possibilità di simulare in ufficio tecnico il pezzo che andremo a fare poi in macchina è un qualcosa che ci permette di accorgerci in tempo dell'eventuale errore. È molto difficile nel nostro settore trovare ragazzi che la scuola forma. Le scuole che formano sono sempre meno. In questo caso ci viene in aiuto ovviamente SolidCAM e SolidWorks, che facciamo continuamente corsi in azienda per tenere le persone aggiornate.
Sem lastnik podjetja Orodjarstvo MDM. V našem podjetju prilagodujeta natančnost in točnost. Zato potrebujemo program, kateri je prilagodljiv našim sistemom in določljiv funkcionalnosti. Po končni podrobni raziskavi ponudb konkurenčnih CAM programov sem hitro prišel do rezultata, da program SolidCAM najbolj ustreza našim kriterijem. SolidCAM je enostaven za uporabo pri vseh 3-osnih in 5-osnih obdelavah. Do sedaj me je najbolj navdušil 2 in 3D iMachining, ker njegova dovršljivost najbolj ustreza naši natančni izvedbi dela, da se lahko na trgu predstavimo kot vrhunsko orodjarno. Glede na prejete ponudbe je SolidCAM najugodnejši program, kateri že na samem začetku prevzel večinsko pozornost pri naboru. Če tudi vi iščete dovršljivost v svoji stroki, natančnost v delovnem procesu in to želite izvesti v najhitrejšem času, vam priporočam program SolidCAM.
David, that was very interesting. For SolidCAM, the customer is the king. And here you are developing a marketplace that will bring income to our customers and the best quotes and work for the buyers. This is truly fascinating. Okay, so now you are going to talk about another new product, the Solid Cloud. Can you tell us more?
Sure, Linda. Happy to. What is Solid Cloud? Solid Cloud is a backup service offered by SolidCAM that allows SolidCAM users to back up their data to the cloud.
Interesting.
Your data, right? Your SolidCAM data, your very precious data. You don't want to lose it, right? So we offer you the best backup solution to back up your SolidCAM files. What data is backed up? SolidCAM settings, post-processors, machine simulation, material and machine tool databases for iMachining, global tool tables, and SolidCAM CAM parts. Forget the headache of losing your data. As you can see, all your information, including your post-processors, all backed up to the cloud, to the great Google Drive technology. Where is the data saved? Solid Cloud syncs your data with your Google Drive account. You can stay in your familiar backup environment, also access your files with the mobile application. So many users use Google Drive today, and SolidCAM enables you to stay in the place where you feel comfortable, your Google Drive. Why is it so useful? If the SolidCAM user computer has problems, he could simply reinstall SolidCAM software and can access all his data on the cloud. If the SolidCAM user wants to work from another computer, he can access all his data on the cloud. Any changes done on the computer will be synchronized to the cloud. What is Google Drive? Google Drive is a free cloud-based storage server that enables users to store and access files online. The server syncs stored documents across all of the user's devices, including mobile devices, tablets, and PCs. So, and this is a very important question, is Google Drive safe? Sure it is. Nowadays, the security vulnerabilities that we see, such as ransomware attacks, very often happen on traditional servers that become compromised, whereas the cloud-based solutions are automatically kept up to date and protected from these risks. Google itself has almost 1,000 security engineers that are solely focused on keeping data safe and removing possible threats. This means it would be extremely difficult for even a large organization to rival this level of security internally. Therefore, Google Drive is one of the safest options for your data. So you can be calm. Thank you everyone for watching. I'm David Somek.
Just a second, there's a question coming in. Let's see, is it completely safe to put our CAM parts data on the cloud?
Great question, Linda, which is relevant for any cloud application. When you host your data on your own device, you are responsible for securing it, which is not an easy task. As you all know, Google is second to none in cloud technology, and they protect your data with the latest and greatest tools out there.
There's another question. Do I need to pay Google for the backup?
Well, when you create a Google account, you get 15 GB for free for email, photos, and files. This should be sufficient for a SolidCAM backup. However, if you exceed 15 GB, you need to be on a paying plan. For example, you pay only $5 monthly for 200 GB.
Sounds good. Thank you, David.
Thank you, Linda.
One of the reasons why we chose SolidCAM versus any other CAM system out there was its full integration with SolidWorks, which we use for design engineering. By having that, we were able to cut down on the amount of time that it took from the modeling process to the manufacturing process.
We're using SolidWorks for everything we do, right? And then you have SolidCAM right inside SolidWorks. Not only you have the ability to have the fixtures in your programming window of you're working with, you have the raw casting. The programming alone, we're running this one casting out here. It took me like an hour to program the whole job. And it's a full 5-axis job with, you know, 6 different angles and all kinds of different features. And there's always clearance issues, and it's SolidCAM tells you if you're going to run into a clamp. You can make it, you can program right around it. It's perfect.
Hallo, ich bin Dominik Weißer. Ich bin Zerspannungsmechaniker bei der Firma VMR GmbH und Co. KG in Weiler. Wir stellen Prototypen und Kleinserien aus Kunststoff und Metall her.
Mein Name ist Florian Fehrenbach, ich arbeite als Zerspannungsmechaniker hier im Hause und mittlerweile nutzen wir seit 1998 SolidCAM in unseren mehreren Bearbeitungszentren zu programmieren. Derzeit nutzen wir 9 Lizenzen.
SolidCAM hat wenige Softwareprobleme, aber wenn man Fragen und Probleme bekommt man schnell und guten Support.
Dadurch, dass SolidCAM in der Region sitzt, konnte ich bereits in der Berufsschule mit der Software arbeiten und wurde so in das Berufsleben vorbereitet.
Ich programmiere gern mit SolidCAM, da man einfach und schnell zum fertigen Teil kommt. Die iMachining-Jobs sparen Zeit beim Programmieren und erhöhen gleichzeitig noch die Standzeit von den Werkzeugen.
Die vielen Bearbeitungsstrategien sowie der übersichtliche Aufbau des Programms gefällt mir sehr gut.
Thank you, David. You are a rising star in SolidCAM.
Absolutely. So, Linda, our next presentation is very interesting and very important. It is about partner relations in CNC machine tool and cutting tool manufacturers and resellers. Michael, our COO Global, will talk about our partnerships in SolidCAM Germany, and Greg Payton, our partner manager for the US West Coast, will talk about partnerships in the US.
You know, Natalie, this is really a very important subject. Partnerships with machine tool and cutting tool manufacturers means that these manufacturers believe in SolidCAM.
That's right.
And see our software as an important complement to their CNC machines and cutting tools for their customers. It is a win-win relationship for both sides. So Michael and Greg, the floor is yours.
Hello everybody out there. My name is Michael Liditzky. I'm the CEO of SolidCAM. With me today is Greg Payton, who is the Director of Partner Projects West in the United States. Greg, welcome.
Hello, Michael. Happy to be here.
Cool. Today we are talking about partners and how important partnerships in the business environment are. So we should start, shall we?
Absolutely.
First, I would like to talk about the agenda that we're having today. So we start about how important it is to have partners out there. Second of all, we talk about the different types of partnerships. Then we are going to give all of you a few examples of already existing partnerships, how we are dealing with them, and creating this win-win situation for us and our partners. At the end, there will be a small how-to of getting partners. So first of all, we start, as I mentioned earlier, with how important it is to have partners. And Greg is going to talk about it more.
Thank you, Michael. As we all know, the CAM industry is composed of multiple pieces, and our customers are looking for solutions to get their jobs done. And so what it is our goal to provide the solutions to this by bringing together a multitude of industries. Now, some of these partnerships may be sales partnerships, where we're looking at cross-promotional events, something that you'd see like a live cutting event or maybe an in-house workshop. These could be webinars, or one of the most popular ones that we come across is trade shows, where we can really get together with our partners and showcase the strengths of each company. And what this does is it ultimately strengthens the SolidCAM brand, because now we're able to get in touch with our customers and show them exactly what they need to be productive and successful. And in addition to our sales-based partnerships, we also look for technical-based partnerships. Now, this could be where we are coming together with a machine tool builder and getting information about their particular types of machines. Now, new machines are becoming more and more complex by the day, and getting the correct information to drive these machines properly is becoming a bigger and bigger challenge. And by partnering with these machine tool builders, we're able to get the information that we need to build post-processors correctly, as well as get the 3D data for a realistic machine simulation. And what this ultimately ends up in is streamlining the process to get the information directly to our end user. This also benefits the partners that we partner with, because then they can have the tool path and the power of SolidCAM to use in their day-to-day operations to create test cuts and other promotional materials. Now, when we are doing this, this can also lead to post-processor certification, meaning that our customers are getting the best post-processors for use with their machines. In addition to machine tool builders, it's also great to partner up with cutting tool manufacturers, because the cutting tool manufacturers are looking for the best possible way to showcase their product. And we can do that through the power of iMachining. And we can do cutting tests that will show the end user just how powerful iMachining is utilizing these tools. This helps the customer get their jobs done faster and also allows for the cutting tool manufacturer to sell more tools. And ultimately, by building these partnerships, we end up with the getting and exchanging of leads. That way we can share this information to grow our SolidCAM user base worldwide.
Well, Greg, thank you for this beautiful explanation. Next, we're going to talk about the different types of partners that we have, starting with machine tool manufacturers, cutting tool manufacturers, software partners, and at the end, one of the most important partners you can have are existing customers. So let's start with the first one. We put here just an overview of a few of our partners that we have out there. Obviously, we have a lot more, but we need to keep it simple for this presentation. So let's start with Citizen. And to be honest, Citizen is one of my favorite partnerships that we have because we started about 5 or 6 years ago and we got the first machine of Citizen. We put it inside our technology center in Schramberg. Then eventually we got the second one. It was a Citizen D25 3-channel machine. Then we got a machine at our booth at the AMB exhibition. And since then, the relationship started to grow and grow. At one time, I was adding Adlin Trabesi to our technology center. And after that, we met at the EMO exhibition in Italy. And there is a beautiful video that we have taken there. And I would like to show it to all of you. Hi and welcome from the EMO 2021 in beautiful Italy. I'm here at the Citizen booth. And beside me is Mr. Adlin Trabesi, who is the European sales manager of Citizen Machinery Europe. Adlin, more and more customers approach us and they want to have a solution for Swiss-type machines. And they're also asking us what's the best possible solution for Swiss-type machines. So do you think a CAM system is an added value when you have a Swiss-type machine?
Definitely, because you know your customer, our customer, buy a machine with B-axis in the first stage not to make interpolation. They buy the machine to having a comfortable adjustment of angle and correction. Yeah, sure. But then let's say after a few months or few years, he will make complex parts and need the software, then he will call you and he will call me, we need to make a post-processor as soon as possible. And this is not comfortable for you, for me, and also for the customer. That's why I am happy that you are here we can prepare ourselves for Miano and Syncom, prepare post-processor for your customers. And this is the main target.
Yeah, definitely. I mean, actually, we almost got all post-processors ready for Miano and Simcom machines. So if it's just a regular Swiss-type machine or a multi-spindle machine, it doesn't matter. We got the software, you have the machines. So I would say, let's make it happen. All right, so as I mentioned, this is a really, really interesting partnership. And to be honest, whenever I talk to Citizen, they tell me, whenever they visit a medical customer out there, that SolidCAM is the de facto standard in the medical industry. So we are going to have special conditions when Citizen is going to sell a machine together with SolidCAM, and they get a certified post-processor at the end with a discount. So this is going to be really nice in the future. In addition to the partnership that we established in Europe, we got a Citizen L20 ATC at our reseller Tactics in Japan in an exhibition. Then we got a really good connection to the Citizen headquarters in Japan as well. So whenever we need 3D data of a machine, they will send it directly to us because, as you all know, getting 3D data of those machines can sometimes be really hard. Then in the bottom you can see that we had a live cutting webinar directly streamed live from our technology center in Schramberg, where we did a bone spoon together with Citizen and ISCA, and it was a really nice event, I can tell you. At the end on the right side, you can see the Citizen D25, which is placed inside our technology center. And I think in about 3 weeks, we're getting the next one. So the third machine we get from Citizen, a Citizen L20 ATC. We are looking forward to get the machine. Next, we would like to talk about Star. Greg, would you?
Yeah, thank you, Michael. In addition to the great work that we've been doing with Citizen, we're also building out a tremendous relationship with Star Machine as well. And it all starts with Gordon's team at SolidCAM UK and their technology center, where they're bringing in Star machines such as the SR38, the ST20, and they continue to cycle out machines and build out that relationship with STAR. Now, this has led to an increased presence for us in terms of cross-promotional events. We see that we are able to partner up with them in trade shows such as WestTech, in which we had a promotional stand inside the STAR booth. We had a STAR machine directly within the SolidCAM booth at the Mach Expo in 2022. And we had a live demonstration station within the STAR booth at the Medical Device and Manufacturing Show in Anaheim in 2022. Now, this has also led to some great partnership support where STAR is now giving us technical documentation, and 3D models are becoming a lot more prevalent for these machines, ensuring that our customers are getting the best end result from us as well as from STAR. All in all, we are continuing to build that relationship with STAR by providing them with licenses. We now have 40+ licenses all around the globe, and just continuing to build that relationship.
Wow, awesome. Thank you very much. Next, I would like to talk about Hamle. As you all have recognized about my accent, I'm from Germany. And in Germany, Hamle is one of our oldest and biggest partners that we have. With Hamle, we did a lot of events in the past. We even have our own Hamle machine inside our technology center. We are training their application engineers. We do some post-processor development. So actually, we developed a special strategy for NC code output that whenever a customer of Hamle uses SolidCAM, he knows that it works 100%. Then we are doing live machining tests. And above all, they have 28 licenses of SolidCAM just in Germany. On the right side, you can see some famous parts that are out on YouTube everywhere. It is a Formplatte and a Griffstück. And for example, the part at the bottom was machined at the Hamle exhibition, the open house they had last week. Next, I would like to talk about Grob. Probably all of you heard about them. We have a great partnership all around the globe. Actually, they also were our first iMachining Foreign-X customer. And what you can see here in the picture is pretty interesting. There is a SolidCAM version installed directly on the second monitor of this machine. So there's a dedicated computer in it, so you can edit your SolidCAM files directly live on the machine. This machine is still sold until today, and I'm not sure how many they sold, but it is a great technology out there, and it shows how good our connection with Grob actually is. And above all, we're doing exhibitions. We're actually participating in their open house next week in Germany at their headquarters. And as I mentioned, it is a really nice partnership, and we are going to put more, growth in it in the future. In addition to what we have achieved in Germany or in Europe, there is a great cooperation in the Asia-Pacific market. So whenever Grob there is going to sell a machine, they would offer SolidCAM as their preferred solution for Grob machines. When there is a turnkey project, they even sell a SolidCAM license directly with the machine as well. And in addition, they also do seminars, exhibition, events, and most important, they also do lead exchanges between Grob and SolidCAM. Second of all, I would like to talk about cutting tool manufacturers. And to be honest, those are the guys who are as closest to the customers as possible. They are every day out there in the machine shops, they're seeing problems, they're helping customers, so they really know what's going on out there. And we would like to start with an overview, obviously. As mentioned previously, we just put a few of our partners in it because we have to go through this presentation quickly. But at the end, we have a lot more out there, and we are going to start with one of the most important ones that we have started recently. It's Kennametal. Greg, would you?
Yes. Kennametal is proving to be one of our most promising partnerships. We are starting to do online training for Kennametal applications engineers worldwide, with over 50 applications engineers taking part in this training. Now, this allows them to get to know SolidCAM software and really see the power that it could bring to utilizing the toolpath with their tools. Now, because of this, Kennametal is giving us tooling for some live cutting webinars. This results in some great cross-promotional material. As you can see on the picture of the right, we have a machine set up for a live coming webinar for an upcoming KevCam night class, in which Kevin's going to be demonstrating the use of SolidCAM on one of his machines. Now, this allows us to really showcase what we can do with these Kennametal tools and really builds out that cross-promotional brand and gets it out to more customers. This also leads to cooperation in exhibitions. We can use these tools in trade shows and really showcase the power of both brands coming together seamlessly. Now, for those of you that are users of SolidCAM, you'll be happy to know that we are now linking up with Kennametal's cloud-based software, Novo, for the direct import of 3D tool model directly into the SolidCAM toolkit. Not only is this a good way of getting Kennametal's name out there in front of our customers, but it also benefits the customer by being able to quickly build out tool libraries using accurate model information. A win-win for everybody involved.
Oh, definitely. So next, I would like to talk about ISCA, also a pretty famous machine tool manufacturer. With ISCA, we did some live cutting events, as I mentioned earlier, in combination with Citizen. We are working on turnkey projects together. We are helping them in their facilities to control their machines, even they also have SolidCAM licenses. And at the end, they also gave us tools for our Citizen machine. At the end, you know, whenever you have a good partner, you're giving something back and they give you something. So it's this win-win situation we are going to talk about a lot more in this presentation.
Now, one of the more exciting partnerships that we've come across recently is that of NTK cutting tools. Now, this is a good example of how partnerships can arise in different circumstances. Now, the way this one came about in the United States is that an applications engineer from NTK approached our booth at an IMTS show and saw a live cutting utilizing iMachining. And he approached one of our applications engineers, actually a senior application engineer and VP of automation, Ken Merritt, and was talking to him about the iMachining toolpath and if it might be good for his ceramic cutting tool. And after a quick chat, they decided to do some test cutting. And in this video, I'd like to show you just how powerful iMachine can be when using these ceramic tools. Now keep in mind the sparks that you see coming off this tool are supposed to be there because it is a ceramic tool in Rene 65. But listen to that sound of that cut and how beautiful it is. Now normally the NTK applications engineer would only go about 25 thousandths deep when making each pass. But because iMachining is so powerful and can control the lead-in into the cut and the cutting force, we were able to go 10 times as deep, just absolutely astonishing the guys at NTK. And because they were so excited about what they were seeing, we were able to start building a relationship with them, and that included their full line of tools. And now we have access to their Swiss tooling package. And we're currently involved in a cross-promotional giveaway of a Swiss tooling package as a contest, getting their name out and the SolidCAM name out to a bunch of customers worldwide.
Good that you mentioned the sparks. I was really worried. So next, I would like to talk about Mapal. We have established a really good partnership with Mapal, and they're using SolidCAM in their R&D department completely. Talking about iMachining, I want to mention that we did a really interesting test cut at Mapal's where we used insert cutters to cut even materials like titanium. And we will hear a lot more in the future about the combination of Mapal tools and SolidCAM's amazing iMachining because it works great. We are also doing partner events, videos, and of course, as I mentioned, cutting tests. Next, there is Göring. Greg, would you?
Yes, absolutely. Göring is another example of one of our oldest partnerships really coming through and being a true ambassador of our brand. Now, Göring has partnered up with us in some live cutting events, and we have some videos that we can play just showcasing how beautiful a cut we can achieve using the SolidCAM software and the Göring tools. Now, once Göring was able to start testing our tools and seeing how powerful the software was and the iMachining algorithm, that they actually put us on their webpage and created special tooling just for use with iMachining. Now, if you look at the text below the slide here, it says near endless tool life with Göring milling cutters. I mean, how amazing is that? that the cutting tool manufacturer is so enamored with the SolidCAM product that they're willing to put that in writing on their website.
Definitely. I mean, I want to repeat it one more time. Near endless tool life with iMachining and grooving tools. This is really amazing. Next, we're going to talk about software partners. So we always say that we focus on what we can do best, and this is creating and supporting CAM software. But we need interfaces. We are linking up to all the major brands out there. For example, we just integrated SimCo inside our software to be able to edit the NC code after we output it. Also, for example, you have a direct interface to Vericat, Zoller, WinTool, and TDM systems, so we can, put data back and forth in a really easy way. At the end, a really amazing thing is to talk about existing customers, because happy customers are your best partners. Greg, want to talk about it?
Yes. We all think about partnerships between the machine tool builders and between the cutting tool manufacturers, but one of the most often overlooked is partnerships with your existing customers, because happy customers can be one of the best sources of referrals that you can get. People are more apt to trust people that are using SolidCAM, and we can see that we've got a 4.92 out of 5-star rating on our homepage. If you check it out, you can search through these reviews and see exactly why everybody loves SolidCAM. You can type into the search bar for posts and get all the information that you need for why people love our post-development team. You can talk about our support and see exactly what everybody has to say about how easy it is to contact us and get solutions from our support team. And these customers, if they're talking to other people in the industry, you're going to get more leads. Now in the US, we have a program called our Easy Sell Partner Program, in which if a customer gives us a lead and that lead turns into a sale, then that customer would be eligible for a piece of the commission on that sale, and benefiting everybody involved.
So 4.92 out of a 5-star rating.
Absolutely.
It's incredible. Okay. Now one more slide about how to build those partnerships. Want to continue?
Yes, absolutely. As Michael likes to say, a partnership is between humans and not companies. And that all starts with finding the right contact person for the partnership that you want to build. If it's going to be a sales-related partnership, you're going to want to find somebody that's going to be in charge of marketing. That way you can send out cross-promotional materials like email blasts or engage in webinars or trade shows. If you're looking to showcase the beneficial opportunities that the SolidCAM software will provide to somebody like a cutting tool manufacturer, you're going to want to look for an applications engineer or technical manager. And then you can show them the benefits that they'll receive from utilizing SolidCAM as their CAM system of choice. Now, once you decide what kind of partnership you're going to go with, it's very important to stay in contact with these people and make sure that you're engaging with them, staying on top of any issues that they might have, questions that they are asking. It may involve giving them training on how to best use the software and get the most out of it. That way they can get the most out of their tools and ultimately showcase to the customers how to get the most out of the software.
All right, thank you very much. At the end, I would like to give all of you a summary. If you have a partner, take care about them in the best possible way, because, as Greg mentioned, partnership is between humans, not just companies. So call them regularly, visit them, do events together, because this ensures that those partnerships will last, a long time. Having the right partners is going to ensure our growth in the future in a tremendous value. So try to find the best partners for you and utilize them the best. And of course, you need dedicated specialists who are just doing this partner managing, because you can't do it just by the side of your daily activities. Find the right guys, put them in charge of the partner management, and make it happen. Because I have to honestly say, today is one of the best days, or let's say the best time, to get partners. A lot of our competitors got swallowed by bigger companies. So the partners out there are looking for the best CAM solution. Obviously, it's us, it's SolidCAM. So just take the advantage now, because it's the best time to do so. So I want to end this presentation with my favorite words. Teamwork make the dream work, so let's make it happen. Thank you.
Thank you, everybody.
That was a very interesting presentation you two gave. And the questions, as usual, are coming in. So the first question is, does the focus on partnerships hinder SolidCAM from focusing on the needs of their customers?
Thank you, Linda. And I would say no, it doesn't. SolidCAM's core focus is on its customers. The SolidCAM Partner Network exists to serve as a knowledge base to enhance the SolidCAM user experience by providing unique solutions through a unified industry experience.
Okay. The second question is, what does SolidCAM look for when considering new CNC machine and cutting tool partnerships?
Well, we are looking for compatibility, reliability, and passion for the industry, and an open-mindedness to embrace new technologies and solutions.
Okay. What to do if I want to become a SolidCAM partner?
Actually, a really good question. So just contact us. A partnership must be a win-win situation for both sides. So let's understand together what we can do for each other.
Perfect. Thank you, guys.
Thank you, Linda.
Thank you, Michael. Thank you, Greg. That was really an important lecture. Partnerships are super important.
That's right. Okay, Linda, and now we continue with Michael Lidetsky, our COO Global. Works in our Rosenheim office and technology center in Germany. You know, Linda, he has been working in SolidCAM GmbH for the last 11 years, with the last 4 months also as SolidCAM COO Global. So we decided to be the providers of additive manufacturing for our SolidCAM customers. Emil and Michael launched SolidCAM Additive GmbH. Michael will let us know about this new and exciting field.
Natalie, you know, the manufacturing world is advancing in huge strides, and SolidCAM always tries to stay on top of things. Our SolidCAM customers will eventually introduce 3D printing to complement their CNC machining. So we will offer them an excellent 3D printing solution provided by their longtime customer CAM supplier, SolidCAM.
Exactly. You know, Emil checked all available 3D printing companies for metal and carbon composites, and he chose Desktop Metal as our partner for the additive manufacturing venture. Michael, the stage is yours.
Hi everybody out there. My name is Michael Lidetsky and I'm the CEO of SolidCAM. Today, I would like to talk about additive manufacturing because it's part of the future in the machine chips. So let's get started. And I would like to start this whole presentation with a question to all of you. So do you think that additive manufacturing is going to replace CNC machining in the future? The answer I will give you at the end of this presentation. There are 5 big industries where 3D printing has become indispensable, starting, of course, with aerospace, then with medical, transportation, energy, and at the end, consumer products. So probably all of us had something 3D printed in his hands already. For example, in the transportation segment, airplanes, parts for airplanes are already 3D printed. The same in the consumer products market, and also medical devices are already printed, which is, I think, really interesting. So let's talk about the different materials that can be printed today, starting with plastics. Plastics, you know, ABS, PLA, PETG, probably all the materials you guys use at home with a small 3D printer, like a do-it-yourself kit or something like this. But they are major, more advanced materials like carbon fiber and also fiberglass. Going to the second point, I would like to talk about metal. And yes, metal is printed today, and it's a really easy process. We can print titanium, stainless steel, aluminum, tungsten, whatever, name it. And there will be a lot more materials are going to be added soon in this whole process. Then, of course, ceramics can be printed. Then we can print wood. And yes, it's true. Wood is printable those days. Of course, there is paper, wax, resins, gypsum, and also cells. I mean, even they printed organs. Most important, it's also possible to print chocolate. So also fruit gums and general food can be printed. But today, obviously, we are going to focus on materials that are used in the industry we are in. It's plastics and metal. On the left side, you can see plastics, an example of printed plastic parts, especially carbon fiber parts, What you can see here in the middle is, for example, a crank for a bike, for a bicycle. So you really get the feeling that those materials are really strong, sturdy, and you cannot break them easily. The X-shaped thing you see over there is the base plate for a drone, for a quadrocopter. Talking about metal, it gets even more interesting. What we see, the first part here in the left corner, is a heat exchanger. So it's distributing heat through inner channels. And to be honest, to machine a part like this is not easy. You need the part to split the part in 3 or 4 parts and machine the inner channels. And the same applies to the copper part you can see at the right bottom corner. It is a heat exchanger, for it is actually built on a rod. And there are inner channels, so water is circling through it, and also no way to machine it in a conventional way like we all know it. Of course, you can see an impeller as well. So you can actually save a lot of roughing time because the parts has been printed previously. But, all the machinists out there are going to ask me, no, but Michael, wait a minute. Isn't 3D printing slow? Or the next question would be, isn't it more expensive than conventional machining? How about the strength, density, the surface quality, and above all, the accuracy of the part? So those questions I would like to answer during the next slides. And the first question was, isn't metal printing slow? We see here a laser sinter process, and I'm going to start the video now. So there is a fine bed of metal powder, and there is a high-capacity laser who is melting this powder exactly at the position where the contour of the part is. And now we see that there is another layer of metal powder is going to be put on the first layer, which has already been sintered. And this happens again and again and again, thousands of times until the part is finally done. So there is the second layer. So then we can see the laser again. And as I mentioned, it's going to repeat over and over again. So isn't metal printing slow? Yes, it is slow, but not anymore. There are technologies out there that are going to speed up this process tremendously. And this is where I would like to introduce SolidCAM additive manufacturing. And I'm actually really proud to introduce it to all of you. So what we're going to do now is to combine the strengths that we have in the CAM industry with a really famous reseller and manufacturer of 3D printers, which is called Desktop Metal. And I want to add a few more things about Desktop Metal. The CEO of Desktop Metal is Rick Fulop, and on the left side of the picture, you can see the start of this relationship happening last year at the Formnext, which is, of course, our CEO, Dr. Emil Tomek, and Rick Fulop. The headquarters is in Burlington, Massachusetts, and as I mentioned earlier, they are inventing and manufacturing those 3D printers. And they claim that they exist to make 3D printing accessible for engineers, designers, and manufacturers. And, it is a good thing that our customers are exactly the targeted group of those 3D printers. So let's talk about this special process that I mentioned earlier. It's called binder jetting, and this is exactly the technology that makes the slow metal printing that we have seen previously faster. And it's not just faster, it is a lot faster, it is enormous. So we start with also fine metal powder. We are going to print it, then there is a debinding where we get rid of all the excess material, and then there is sintering. And what we have seen earlier is there was sintering directly on the 3D printer, and now there is the big change. We're taking out the parts out of the 3D printer, put them in batches in the sintering oven, so the next part can be printed simultaneously at the printer. So it is called a batch process, and this allows you that the 3D printer is working all the time, producing new parts, and simultaneously the sintering furnace is going to sinter the parts where they need to be sintered. What we have now in our technology center in Schramberg in Germany is a so-called Desktop Metal Studio system, and it's the first metal printing system that is, I would say, office-friendly. So you can place it inside your office. On the left side, you can see the actual printer. It's a standard printer like you actually know it from home, but those printers are able to print metal. On the right side, you can see the furnace. It's also pretty small. You can fit it through a door, and this shows that this whole technology has reached a point where it's really reusable and easy to usable out there. Example parts we see here are some parts for engines, impellers, heat exchangers, some cloths for clamping, for example, and also jewelry can be printed in this printer. There is a nice video I would like to show because it really indicates how easy this process actually is. Enjoy. So I want to repeat, it is the easiest possible process you can have, and especially, for example, for educational institutes. For spare parts, this printer is meant to produce metal parts, not in big batches, just one part at a time, and you're going to sinter it, and you have the full metal part ready at your office. Next, there is the more advanced system, which is the desktop metal shop system. And talking about the shop system, we're talking about a printer that can actually replace a whole CNC machine, because those printers are meant to print big batches, thousands of parts, 100,000 of parts a year. And on the right side, you can see how awesome the surface quality actually is. And there is another interesting video which showcased the process of binder jetting and the desktop metal shop system in the best possible way.
You are now in the shop lab. The shop lab is designed to be a mini factory to continuously exercise the shop system, printing hundreds of parts a day for ourselves and for our customers. So the shop system is the first metal 3D printer designed specifically for machine shops, allowing shops to enter into additive metal manufacturing like never before. The shop system is a single-pass, high-resolution metal binder jetting system at a price point that has never been achieved before. The shop system is an extremely easy system for machine shops to learn to use. Powder is loaded into the printer, and the printer autonomously lays down 50 to 100 micron layers of metal powder and prints batches of parts. The customer can load as many different parts as they would like into that batch, and it does not change the time. The printer then ejects that batch of parts, which can move on to the next station, and the printer can begin another batch of parts. The next step in the shop system is the depowder station. Now, the shop system is a batch process, which means a batch of parts can be printed, and then that batch can be moved on to the depowder station, so another batch can then be printed at the same time. The depowder station is a fully integrated depowdering station where parts can be excavated from the powder, and that powder can be fully recovered in the integrated recovery system. Those parts, once excavated, can be placed directly into the desktop metal furnace for full sintering. Sintering technology has evolved over the years to be huge furnaces that cost hundreds of thousands of dollars and take up entire rooms like this. But what we've been able to do here at Desktop Metal is shrink down that same technology into a small furnace that is vacuum capable, partial pressure capable, and can roll through a door. And the shop system is designed to scale manufacturing from small scale to medium scale to enhance a machine shop, whether it's an external machine shop or an internal machine shop, with 3D printing capability.
All right, so this was a really, really good explanation of the binder jetting process. So it is easy to use. It is specifically meant for machine shops. It got a great form factor. You can put it in any small space you have in your machine shop, so absolutely great product. If we talk about mass production of part, there is even one more thing that we can talk about. It is the production system, and it is when you have to print millions of parts a year. This is where the production system comes in. The most affordable one, though, is the desktop metal fiber solution. So as I mentioned earlier, carbon fiber is a really, really dense material. You can print parts that are really, really stiff. And not just prototyping, but also some small batches you can print with these printers. So it's a really great product as well. So being a machinist, I would ask a specific question to myself. What about surface quality? What about tight tolerances? So let's use this part as an example part. And for example, we have your precise hole that obviously cannot be printed. We have a really tight tolerance in the pocket depths. Maybe we have a special surface quality, so you have to do a finish cut on it, or a special sealing groove that needs to be machined. So what happens then? Well, it's easy for us. We are going to add one crucial thing to this workflow we have seen earlier. And of course, it is machining. And as you all know, we are the experts in machining, and we are putting all the knowledge we have into this workflow, and this is what we call SolidCAM additive manufacturing. Because talking about all the customers we have worldwide, I mean, we're talking about 23,300 seats. We have 62,000 educational seats out there. So there is a lot of potential out there, because all the customers today, they have to get in touch with additive manufacturing, because in the future, if a machine shop does not know how to print parts, they can't be competitive anymore. So we have to help our customers that are obviously directly placed inside these important markets that I have shown at the start of this presentation. So we know the customers and they already know us. They know we are not just selling a product, we are also offering the best possible support. And we are going to help them, our customers, to transform to the future in additive manufacturing. So we always call ourselves the solid platform for manufacturing. And I will put another thing in it now, which is called SolidCAM Additive. And I think it's the perfect combination for our solid platform for manufacturing. Talking about numbers, the 3D printing global forecast is really interesting. Until the year 2026, we estimate a market size of $35 billion US. And you know, as I mentioned earlier, our customers need to invest in 3D printers, or let's say in additive manufacturing in the future, so we have to help them making this transition. Talking about different markets, the compound annual growth rate in different countries is really interesting. For example, I'm from Germany, we have a 22% of annual growth rate, and you know, comparing it to Asia, of course, there's a little bit more potential there. And also in the US, we have about 20% of growth rate yearly, which is really interesting. So I want to ask you this one question one more time. Do you really think that additive manufacturing is going to replace CNC machining? Obviously, no. It completes it. Summary, of course. So we are going to act as a reseller of desktop metal products starting actually now. We are going to not just sell them, we are going to offer solutions to our customers, because we always say we're not just selling products, we also give the best possible support with the best possible team out there. We want to close the gap between additive manufacturing and CNC machining. And of course, we're doing all the necessary stuff that is, you know, coming with it. We're doing installations, we do maintenance, we do everything that needs that our customers can use those desktop metal printers in a productive environment. So I really would say that SolidCAM Additive is the best solution for additive manufacturing, especially for customers in our CNC machine shops. We are going to start in Germany, obviously then we are going to transfer to the US, then in India, and at the end in Israel. And of course, there will be a lot of more countries in the future. So at the end, I want to end with one of my favorite sentences. It's success is best when it's shared. So let's share the success we see in additive manufacturing with our existing customers, and let's transform the machining world into the future together. Thank you very much.
Hi SolidCAM family, this is Gürtel Kali speaking. I'm a regional manager at Desktop Metal in EMEA. Some of you may know me from my time as a SolidCAM employee. Today, I have the pleasure to talk about a new partnership between SolidCAM and Desktop Metal. First of all, I would like to thank Emil and Michael for the invitation to shoot this video for the SolidCAM World Summit. I entered the additive manufacturing world 4 years ago, with the belief that the future would be a combination of CAD, CAM, and AM. Today, I'm proud to announce that this combination is launched through a partnership between SolidCAM and Desktop Metal. Desktop Metal develops and distributes products that take additive manufacturing to a new level, AM 2.0, from single part to high volume production. Until now, these solutions have mostly been offered by companies in the 3D printing market, where the knowledge about metal, manufacturing, and traditional production methods is very limited. SolidCAM has this knowledge, and therefore the greatest potential in this market. Not every printed part immediately is an end-use part, and therefore the combination of CAM and AM is essential. Easy of use is the most important part of SolidCAM, as well as at Desktop Metal. A great successful future awaits us. We at Desktop Metal are looking forward to a wonderful cooperation. I wish the SolidCAM family a very successful summit. A great successful future awaits us. Regards from Heidelberg.
Wow, Linda, we heard so many fascinating presentations today. Our next presenter is Amod Onkar, SolidCAM India Country Manager and our SolidCAM 3-axis and simultaneous 5-axis Product Manager.
You know, Amod has been with us for over 15 years. All the time he has been pushing SolidCAM to become #1 in CAM in India, and for SolidCAM to have the best 3-axis and simultaneous 5-axis solutions. I can tell you, this is another person that works around the clock.
Definitely. In this presentation, Amod will show how by leveraging SolidWorks RMB add-ins, ModelWorks, SplitWorks, and ElectroWorks with SolidCAM machining, we can provide an excellent solution for die and mold and electrode design and machining.
That is so good to hear, that we can now provide a complete CAD/CAM solution for mold makers. Amod, the stage is yours.
Hi, welcome to the SolidCAM World Summit 2022. My name is Amod Onkar, and I'm the product manager for 3-axis and 5-axis milling in SolidCAM. Today we are going to see a slightly different presentation, a slightly different approach to our product. We have a solution for complete mold making, and so we are going to look at the mold making products that we have inside our portfolio. So let's get started. If you look at the process of mold making in the mold making industry, it generally starts off with a design data. It could be a third-party file, it could be a native file, or it could be a drawing and you're going to build a model out of it. All this is handled in one software, which we can right now call it as a CAD software. Once the part is designed and the shrinkages are applied, we move to the next step of separation of core and cavity. And this is a very critical area, a critical process. And once the core and cavity separation is done, the parting surface is built and the inserts created. From here starts several processes together. One team, if the organization is large enough, starts doing the mold design. Another team takes the core cavity inserts and starts programming for the CAM. And another team also starts taking up these inserts and they start creating electrodes. They basically find out areas where electrodes will be needed and they make the electrodes. Now this is generally called as a concurrent design or a parallel design or parallel mold making process. So what do we have from SolidCAM for each of these processes that I just showed you? For CAD, we have the world's most popular CAD software, SolidWorks, inside which all of these other products also work. For core and cavity separation, we have a product from RMB called SplitWorks. For mold design, we have got product from RMB again, it's called MoldWorks. For electrode design and documentation, we have a product from RMB, it's called ElectrodeWorks. And finally, for the CAM, we have SolidCAM, which can handle right from a simple 2.5D product right up to simultaneous 5-axis, mill turn, Swiss type, and beyond. But today we are going to focus more on milling because that's about the area that mold makers need. So we have a complete solution for mold making with full associativity, which means that any changes to the CAD part in the native CAD system can trigger a change to the entire process. The process will automatically update itself right from the core cavity updation to the mold design, the drawings, the electrodes, and finally the CAM. Everything gets updated because they are all associative with the tight integration all of these products have inside SolidWorks. So let's look at a very short video wherein we present to you how the part is actually modeled. So we start with the base features and then we go on adding features onto this product. We add fillets, we add shells, we add bosses, we then add holes, again fillets. We also add ribs to strengthen the product, and once this is done, the product is frozen and this becomes our base for our mold design. So once this product is frozen, it need not be 100%. There could be further changes to the product, but once the design or the part is somewhat ready, we can start with the next process of core cavity separation. This is handled in the R&B SplitWorks. SplitWorks is a revolutionary product using advanced technology to automate the process of core and cavity separation and creation for plastic molding, for blow molding, for high pressure die casting dies, investment casting, wax molding, etc. It also includes a very advanced technology to update the inserts and any modifications or additions in the part that include changes to the IGES or Parasolid file that would have been given to SolidWorks as a start for the core cavity separation. Let's look at a very quick video on how we handle this core cavity separation inside SolidWorks using R&B SplitWorks. So we have the part that we just designed. We introduce the SplitWorks. SplitWorks creates immediately the split of the part and separates the core and cavity. So what we do basically is we take the separation and then we start editing and moving things that we do not think belong to core to cavity and from core cavity to core and vice versa. We also attach surfaces that are not part of the core or not having any draft back to the core, and we create the first basic core cavity separation. After which, we take the surfaces that belong neither to the core nor to the cavity. These are the ones that are going to go to the side cores. We attach these surfaces to side core 1, side core 2, define the direction in which they're going to move, and there we go, we complete our complete separation. This generally for parts like this, the separation happens in less than few minutes. Once the separation is done, we then close the internal parting areas with internal parting surfaces, and then we move ahead to create the external parting surfaces. The external parting surface in this part is created using two methods. One is using SolidWorks method, and then we have to stitch it if we are using the SolidWorks method. But we also have a very interesting lofting function inside SplitWorks where we just select the start and end, and SplitWorks creates the surfaces automatically using the direction and the edge that we have defined. No need to do any stitching because it's a part of the process. The parting surfaces are created automatically everywhere, and once that is done, we move to the next stage of creating inserts. By selecting the parting surface and the inserts are created, the core insert, the cavity insert, and the part itself. So there we have the core and cavity. Of course, the side cores and the sub-inserts still remain, so this will be created in the next step. So let's look at the next step of creating sliders and sub-inserts. So once we have the core and cavity separation done, the main core and cavity separation done, we can go into creating the sub-inserts and sliders. The first is going to be the side cores. So we take the side core, we close one end of the side core and create the pin that is needed to call that the entire area side core. Once the pin is generated, SplitWorks automatically updates the core, removes that area from the core, and allows the pin to be inserted in that or pin to move in that. The same process is also applied to the other side, which is the other side core, because there are two side cores in this, and the sliders are created, the portions are updated again in the core insert. Once this is done, we go into our next step of creating sub-inserts. Sub-inserts are those areas which need not be a part of the, or need not be an integral part of the core insert. These inserts are separated and they are created externally, and then they are assembled when the mold is being assembled. By doing this, the cost of manufacturing comes down dramatically. So there we have selected the sketches. We apply what kind of head we want, whether it's a cylindrical or a rectangular head, and the inserts are automatically extracted from the core insert. So we have the core pins coming out from the core insert. Once this is done, we have completed our core, cavity, sliders, and sub-inserts. We can move to the next stage of our process, and the next stage of the process is the electrode design. We have everything. Now the electrode design team gets into action and starts extracting electrodes in areas that are very difficult to machine or areas that are impossible to machine in milling. For example, if there's a sharp corner or if there are very thin ribs where putting a milling cutter is virtually impossible, in those areas electrodes are created and the process of electric discharge machining is then done using the electrodes. Now, one of the most critical things in electrode is application of spark gap, and this is automatically handled by Electrode Works. It's very, very powerful, as you're going to see in this short video. So Electrode Works automates all the aspects of electrode design, management, documentation, and manufacturing of EDM electrodes. It's fully integrated into SolidWorks environment, and it guides you. It's an intuitive GUI. It guides you through the entire process and the production of the electrode. Let's look at a very short video of the Electrode Works. So we have our core insert, and we are now going to create an assembly file in which we are going to store the electrodes. We are interested in creating the electrode for the rib shown on the core insert. So we pick the holder and we pick one of the surface, and Electrode Works automatically picks up all the remaining areas of the electrode that needs to be extracted and then creates immediately the electrode. We can adjust the dimensions of the electrode like length, width, and height, and the electrode is extracted. Once the electrode is extracted, we can do the sub-design work, like for example, extending the sides of the electrode, which are currently exactly the same as the rib. So the sides are extended tangentially on both sides, and this is done almost automatically, very quickly. And another very important thing is application of spark gap. I would like to mention here that spark gap currently is given in the softwares by the CAM user. The user gives a negative offset during milling and then creates the CAM program. Generation of drawings in Electrode Works is completely automated. Just right-click on the electrode and click on Generate Drawings, and these drawings, like EDM drawings as well as manufacturing drawings, are generated automatically by Electrode Works. So it's a complete process of design and documentation of the electrode by Electrode Works. So once you have the electrode, we can move to the next step of the process, and that is the mold design. MoldWorks, it's an R&B product, is a premier solid-based mold design application that delivers innovative, intuitive, intelligent design tools for injection molding industry. And it has got great support of almost every mold catalog that is there today in the world, like Hasco, DME, Futaba, PCS, Progressive, etc. And comparing with all the competition today that we have in this area, MoldWorks supports most number of catalogs that are available today in the world. So you can do a complete mold design, including the cooling design, checking the collision during making the cooling design, runners, gates, slider design, ejector pins. Everything can be done in 3D, and once the design is ready, you can generate the drawings at a click of a button. All the drawings can automatically be generated. Once we have done with our mold design, our next process is taking these inserts and the plates into CAM. And for that, SolidCAM offers three different engines for generating the machining program. For roughing, we have the legacy or generic high-speed roughing, and then we also have the new generation turbo roughing. We also have iMachining 3D that can be used for small to medium parts for doing very high performance roughing that can save a lot of time on the machine itself. So let's look at the finishing area. Again, for finishing, we have got the legacy or the generic high-speed finishing, where we have more than 18 to 20 different strategies for finishing the part. We also have the turbo finishing or turbo HSM, which has got also its 5 to 6 different varieties of finishing strategies. iMachining, Anthony has already talked about it, and I'm going to repeat it again. iMachining 3D is an amazing technology. It uses the proven algorithms of iMachining 2D and then uses a step up to create the scallops. And this can save anywhere between 70 to 80% of your time on the machine. Coupled with iMachining and HSM and HSR and the finishing strategies, you can machine any kind of small to medium mold, any complexity inside SolidCAM. We also have the SolidCAM HSR and HSM. This is a generic high-speed roughing and finishing engine. It has a very powerful and finishing toolpaths for molds, dies, aerospace components. It has got unique machining and linking strategies, generating high-speed toolpaths. And cutting moves are, and the retracts are smoothened and retracts are kept down to minimum so that it's always cutting and not doing any air cuts. It translates into very efficient and smooth toolpaths, which gives an extremely good surface quality in the end. The turbo roughing, which is basically the new generation roughing, is an amazing technology because it has got several of the new architectures in place. For example, it has got multi-core support. It's a full 64-bit calculation. The speed of calculation is very, very high. And as you increase the number of cores, the speed of calculation goes up because it distributes all the calculation across all these cores and uses them efficiently. It also has a very fast recalculation. In the event you would like to change some parameter and recalculate it, it's much faster than calculating it the first time. The second time, the calculation becomes even more faster. Now, we made a lot of change in 2022 in SolidCAM, and one of the areas we made a change was in the area of calculating with Turbo HSR and Turbo HSM. So if you look at the roughing and rest roughing times that we have between 2021 and 2022, for this part that is seen on your screen, it's approximately 400 by 200 by about 130. You can say it's between medium to large part. In 2021, the roughing took about 20 seconds. In 2022, it's about 10 seconds. The rest roughing is about 66 seconds in 2021, and in 2022, it's about 16 seconds. In the rest roughing, the second rest roughing, generally this is where the time increases. It's about 40 seconds in 2021 and about 15 seconds in 2022. So we are about 3 to 4 times faster in 2022 when you compare it with 2021 SolidCAM. So that's a big, big improvement that we have in our Turbo HSR engine. Turbo HSR and HSM also have got the multiple surface offsets where you can provide different offsets to different group of surfaces. And this is very useful when you are machining large sheet metal dies where you would like to keep a different offset on the parting surface and a different offset on the actual profile geometry. You can create infinite groups. There is no limitation on the number of groups that you can create. You can create as many groups as you want. We also support, apart from regular machining, we do the hatch roughing and contour roughing and also the rest roughing. The rest roughing here is very, very powerful because it works on two principles. It works on the principle of previous tool and it also works on the principle of the previous updated stock. And you can use either of them or you can use a combination of them to generate the toolpath. And the toolpaths are very precise, have got very less lifts, and they only go and machine areas where material is left out beyond a certain value that has been defined by the user. And we can provide arc fitting to smoothen out the rapids that are getting generated so that the machining happens very smoothly. In 2022, in Turbo HSR and Turbo HSM, we also created a very new function of arc fit. And this greatly reduces the number of blocks that gets generated in the final G-code output. For example, the same part for roughing, it generated about 785,000 lines of code in 2021. With ArcFit in 2022, it generated only 464,000 lines of code. For rest roughing, it generated 332,000 lines in 2021. In 2022, it just generated 121,000. And finishing, approximately 250, it's 2507440 lines. and in 2022 with ArcFit it was down to 144,150. So it's almost between 50 to 60% of reduction in G-code size. And ArcFit is very, very useful, especially when you go on older machines which can't handle a lot of linear moves. There the arcs become very, very important. So this translates sometimes into a much faster machining, better surface quality on older machines. Of course, on the newer machines it can be even better, but even on old machines it translates into a very good surface quality. Then we have SolidCAM Turbo 3D HSM, which is a new generation high-speed machining. It's a new generation machining which uses all the cores, 64-bit calculation. It's extremely fast in calculating toolpaths. It can take few seconds to calculate the constant Z or linear toolpath even on really large paths. It has got minimum definition of parameters. There are not many things. Most of the things are automated and they are kept as a relation between the tool and the geometry. We have constant Z, linear machining, constant step over, rest machining. All the toolpaths are available, including the combination of constant Z linear, constant Z, constant step over, etc. And full gouge checking, including holder gouge checking, is already inbuilt into the toolpath. Apart from the mesh-based technologies that we have for roughing and finishing, we also have surface-based finishing technologies which come up very handy when you would like to do localized machining of areas which need a very high finish. This is where high-speed surfaces or SolidCAM HSS comes into play. It's a very good complementary module for machining using localized surfaces. It has got advanced gouge check for holders, arbors, and tools. It supports standard tools as well as shape tools. It handles undercuts very well. You can machine undercuts using HSS, and it's super complementary. It's really complementary. It works as a complement to all the HSM and 2.5D toolpath engines that we have inside SolidWorks. So I have been talking about stuff that we have inside SolidCAM. We did some trials with all these technologies on several machines, and I present to you a few case studies. For example, this part here was done on a mold steel, on a pre-hardened mold steel on a Makino PS105. That's the photograph of the part as it is coming out of the machine. There was absolutely no touch-up on this. It's as coming out from the machine. It took about 240 minutes from rough to finish. The same part was then attempted on an Indian-make machine, Jyoti VMC 850, and the machining time here is 300 minutes on a pre-hardened, same pre-hardened steel. Another small part was cut on the same machine on Jyoti VMC 850, and here the machining time is approximately 200 minutes. This part is as seen on the machine. You can see the coolant, the vise, everything, and the finish is as coming out from the machine. The part that I just showed you earlier, which was like a forging die, the 400 millimeter by 200 by 135, was also cut on an Indian machine, and this was done on an AMS MCV 450 from Ace Micromatic. The machining time here is approximately 400 minutes, and this was done on a pre-hardened mold steel. So if I summarize, we have got the excellent solution today, right from design of the part, design for core and cavity, mold design, electrode design, and finally CAM right up to 5-axis. You can do any kind of mold insert. You can design everything and do the entire process in a single software running concurrently. Thank you very much for listening and watching this presentation.
Thank you, Amo. That was a very interesting presentation as usual. And there are 3 more questions from the attendees.
Sure.
So the first question is, do mold makers use a single software for the entire process?
It's not common for mold makers to use a single software for the entire process. Large corporations, large mold making companies do. Generally, mold makers use different softwares, which are also called as best-in-class for each approach. But this approach has great limitations. Data transfer and change management takes away all the benefits which the mold makers would have accrued using the best-in-class approach.
Okay. The second question is, What challenges do mold and die makers face in the entire process of mold making?
There are many challenges, but I would like to put two of the challenges which mold makers face today. One is a concurrent mold design. This ensures that the mold is manufactured much faster by doing things and processes parallelly. And the second is change management. Mold making is always fraught with part challenges or changes. Mold makers address this currently by waiting for the final part before they begin making the mold. This adds to increase in delivery time. Making a mold with a concurrent process greatly reduces the delivery time.
Thank you. And the last question is, how does SolidCAM fix the challenges you mentioned?
SolidCAM today offers solution for the entire mold making process in a single window. Data is also showed in one format. For part design, we have SolidWorks, the world's best and most popular CAD system. The mold design is handled by SplitWorks and MoldWorks from R&B, that too a native SolidWorks data without any conversion. Electrode extraction and design happens with ElectrodeWorks. And finally, machining of the electrodes, mold plates, cores, cavities, sliders is done by SolidCAM. All the process is done in single window without changing the environment or data format. Since the format is always SolidWorks data, any changes to the CAD data is seamlessly transferred to all the aspects of the design and manufacturing, which results in changes being applied and all the data including toolpaths, drawings automatically updated to the latest change. This makes concurrent design and manufacturing possible, which results in faster delivery of the mold.
Thank you, Mahmoud. I think you explained it very well.
Thank you.
Thank you.
Falling too fast to prepare for this. Tripping in the world could be dangerous. Everybody circling as vultures. Negative, nepotist. Everybody waiting for the fall of man. Everybody praying for the end of times. Everybody hoping they could be the one. I was born to run, I was born for this. Whip, run me like a racehorse. Pull me like a ripcord. Break me down and build me up. I wanna be the slip. Word upon your lip. Rather that you rip. Break me down and build me up. Whatever it takes. Feeling miserable, always hanging on to the visual. I wanna be invisible, looking at my years like I'm out of dumb. Everybody needs to be a part of them. Never be enough on the prodigal son. I was born to run, I was born for this. Whip, run me like a racehorse. Pull me like a ripcord. Break me down and build me up. I wanna be the slip. Word upon your lip. Rather that you rip. Break me down and build me up. Whatever it takes. 'Cause I love the adrenaline in my veins. I do whatever it takes. 'Cause I love how it feels when I break the chains. Whatever it takes. Yeah, take me to the top. I'm ready for whatever it takes. 'Cause I love the adrenaline in my veins. I do what it takes, but critical, egotistical. Don't wanna be the parenthetical, hypothetical, working on to something that I'm proud of.
Welcome to the MTD Technical Corner. Today we're going to be discussing iMachining, the revolution in CAM with Ben. Welcome to the MTD Technical Corner, Ben.
Hey, Gio.
iMachining, the revolution in CAM. What is iMachining?
So iMachining is our high-speed roughing strategy. So it's fast metal removal, getting rid of the majority of the stock as fast as we can.
So it's a roughing strategy. Now, I would assume and please talk us through it, that a lot of the time savings come through roughing, and this is the importance and the main USP of iMachining.
Yeah, a lot of people can concentrate on the finishing strategies and things, but the roughing is the majority of or the bulk of the material that's going to need to be removed, so being able to get that away fast is where you're going to get all your time savings in the job.
So talk us through it in more detail and from a technical perspective.
So iMachining is sort of a two-stage process. The first stage of it is a morphing toolpath. So you've got obviously a stock shape on the outside, going down to our shape as you can see on here. Yeah, so we morph from the outside shape to the inner, maintaining a constant chip thickness. So not a constant step over, constant chip thickness. So we're constantly varying the speed or the feed rate, should I say, determined by the contact angles as it's cutting.
And is this done automatically?
Automatically, yeah, you tell it, so 3D iMachining, as you can see here, we are telling it to cut the entire target wherever there is stock. It is doing all the deep cuts first, you can see full depth of cut using the full flute length, and then it will come up where there's stock left and create a skull on the component.
So this is morph machining?
Morphing, yes, it's a morphing toolpath. The second stage of iMachining then is the technology wizard. So the wizard then takes in data from the machine tool, so we know the power at the spindle. It takes in all the data from the tool, takes the data from the material, and then it will produce its own depths of cut, speeds, feeds, and all the step overs and contact angles.
This CAM strategy, is it unique to SolidCAM?
It is, yes. So it was developed by SolidCAM themselves, released back in 2010. So it's been with us for a while. Still, our sort of big focus, our big USP inside SolidCAM is the high-speed iMachining.
So effectively, Ben, this takes care of everything pretty much automatically once you give the machine tool the component details. But what happens if you've not held the component securely, or your tooling is sticking out quite a long way and you might experience some vibration issues?
So the software can account for that. We've got a machining level, so it's the material removal rate. So although iMachining will calculate all these speeds, feeds, depths of cut for you, you've then got a slider bar from 1 to 8 where you can slide down, up and down that scale, which will bring everything. So you keep in using still the technology of iMachining, but just slowing everything down a little bit, still getting all the benefits of sort of tool life, less pressure on the tool, on the spindle, and things like that. Still getting that high material removal rate, just at a sort of reduced rate instead. So if you held it on a casting or held in quite flimsily, for instance, or like you say, long tool sticking out, the program has got the option to dial that down a little bit.
Okay, so let's start discussing some of the time-saving benefits using iMachining, starting with cycle time reductions. On average, what would you expect a typical cycle time reduction to be using iMachining?
So on average, we're boasting up to 70% cycle time savings. The harder the material, believe it or not, the better it is for iMachining. So you can get up to sort of 90% cycle savings cutting into titaniums and harder steels. But 70% is roughly the sort of average marker that you'll be gaining.
Well, that's massive.
Yeah,
It's game-changing, effectively.
Big cycle time.
Now, you mentioned cutting tools. We've mentioned cutting tools if they're sticking out a long way to get accessibility or whatever the case may be. How is the cutting tool life longevity increased using iMachining?
Well, it's
and
increased.
What are the benefits of that financially?
Yeah, so the tool life's increased from the point of view that the cut is a lot nicer, a lot kinder on the tool. But we're also using the full flute length as well. So you've paid for all that carbide. Instead of using just a section of it and then creating a notch in the tool where now you can't use the tool again, you've got all of that flute length that you can use. So why not use it all? You can see here full depth of cut, full flute length cutting.
So is that part of the strategy then, to use the full length of the cutter?
It will, yeah. It will go as deep as it can with the flute length. Obviously this has got a bit more flute length to go, but the depth of the part obviously is not the same length as the flute length. But the idea behind iMachining is get as deep as we can with that tool.
So the engineering or the engineer plays a big part in this by choosing the correct tools for the application. So this is effectively a tool to enhance the productivity up for free-access machining.
Yeah, exactly. It's not there to replace the engineer, it's there to give them assistance and a tool to use to increase their productivity and to increase the obviously the efficiency of the tool path, but also tool life on there, so decrease the cost of purchasing new tools. It's better for the machine tools, less pressure on the spindle bearings and things like that as well.
So it also gives your machine tool better longevity?
Yeah, definitely, yeah.
Now, Ben, this sounds absolutely fantastic, but for people that may be watching this technical corner and think that it's too good to be true, can you prove to them that it isn't?
We can, yeah, and we often do so. If anybody wants to send us a part or they want us to come in to their facility, we'll happily program a part using iMachining. We'll cut it, we'll run it on a machine. You know, we'll take the challenge and we'll prove to you that we can save you cycle time, but obviously we'll save tool life as well.
Ben, an absolute pleasure. So there you have it, over 70% cycle time savings with the revolutionary iMachining from SolidCAM.
My hopes are, at least for Northern Nevada, is that not too many people learn about iMachining, because it is my biggest competitive edge over local competitors. If you don't have iMachining, you cannot compete against me, because I will cut the part in a fraction of the time and not destroy tooling. And I have many examples, but the biggest impact that I saw was in cutting difficult materials, stainlesses and Inconels, and many of the difficult to machine materials that are just known for chewing up very expensive cutters. iMachining extended our tool life upwards of 10 times.
Hi, Ahmad.
Hi.
You are our famous simultaneous 5-axis product manager and a highly regarded worldwide expert for simultaneous 5-axis machining. You always tell us that we have one of the best simultaneous 5-axis solutions today. So can you give us more details?
Sure. Hi. Welcome to the summit. My name is Amod Onkar. I'm the product manager for 3-axis and 5-axis milling. And in this presentation, I would like to present to you the packaging of SolidCAM 5-axis and how it is sold and how it is packaged for consumption. The agenda for today's presentation is I'm going to introduce the modules of SolidCAM 5-axis, how it is packaged, and finally the summary. Let's go ahead and see what we are offering currently in SolidCAM. So we have the generic 5-axis, 4 and 5-axis milling. We also have the multi-axis machining, we have the multi-blade machining, and we have the port machining, which is the application-based solution. We have rotary machining, we have edge breaking, we have edge trimming, and finally automatic 3+2 roughing. So these are the 8 broad classification of packages that we have, and then there are sub-classifications also of the packages that are there inside SolidCAM 2022 and 2021. So what does the generic 4 and 5-axis milling have to offer? So it's a complete generic solution, which means it's completely controlled by the user. Every aspect of machining can be controlled by the user. You can machine any part the way you like. You have full user control with the tool axis. There are user-defined gown check strategies, smooth lead in and lead out. You can apply different types of leads in, lead out macros to the tool path. We support all standard tools, including the circle end mills, which are basically the barrel tools. And we have got several strategies and sub-strategies inside the generic 5-axis machining, like parallel cuts, parallel to curve, perpendicular to curve, morph between 2 boundaries, morph between 2 surface, etc. And user even like engraving and stuff like that inside the generic 4 and 5-axis machining. We get exceptional surface quality in this because we machine the NURBS surfaces as they are without creating any intermediate mesh or any other thing. We directly machine the surface. So we get exceptional surface quality. We can reproduce the surface as they are on the part. Part of the generic 4 and 5 axis machining is also a rotary 4-axis finishing. This is designed to machine parts on a 4-axis milling machine. It can be used to machine cylindrical parts like bottle molds, cores, electrodes, jewelry items, woodworking panels, etc. Tool parts are directly calculated on the part and not wrapped. It's very important because we do the slicing and we do the cutting directly on the part, and we don't take a planar tool path and then wrap it around the cylindrical space. Strategies that are available are along and across. You can also shift the tool axis by defining a value, and you can use the tip of the tool or the edge or the side of the tool to machine the part in rotary. Next is the swarf machining. We have a very robust engine for doing swarfing. Swarfing is basically using the flank of the tool to machine the surface. The surface can be a straight surface, it could be a curved surface. So swarfing can handle both straight as well as curved surfaces. Minimum inputs, all you need to define is the machining surfaces and the floor, the tool, and some other entry and exit parameters, and that's it that are needed to machine the swarf geometry. Clean results, because here we do not directly machine them on surface, but we create a mesh and we generate the tool paths on the mesh so that the results are very clean and extremely reliable. Tilt control is automatically applied. User doesn't have to break his head on the tilt control, because many a times when you are doing swarfing operations, one of the most critical thing here is the tilting, and this tilting is controlled automatically by SolidCAM. Almost every user who is into machining needs swarfing, because swarf can handle all the axes. You can have swarfing in 3 axis, you can have swarfing in 4 axis, and you can also do swarfing in 5 axis. So any user who is into machining will, in one or other part, will need the swarf operation. And some of the applications are impellers, frame components, and production parts, including blisks also can be swarfed around their blades. Part of generic 4 and 5 axis, we also have a 3 to 5 axis conversion. This is a very useful tool to convert HSM, 3D HSM, and Turbo HSM tool paths to simultaneous 5 axis. These are generally needed when you want to machine really deep areas where you actually generate the tool path without the holder, allow the tool paths to be generated, and then apply the holder and convert it to 5 axis. So what the software basically does is it uses the holder, the tool, and checks for collision, and whenever there is a collision that is about to be detected, it tilts the tool to avoid the collision. Therefore, it converts a 3-axis tool path, simple 3-axis tool path, to a very complex 5-axis tool path at just a click of a button. The process is completely automated with minimum user intervention. The user really doesn't have to put his brains into it on what it needs to be done. Everything is done automatically by SolidCAM. The next one is in the generic kitty is the multi-axis drilling, which basically is an operation that creates multi-axis drilling, taking the advantage of SolidCAM hole recognition process. So it uses the hole recognition process of SolidCAM and then applies, checks the vectors to create the multi-axis drilling toolpath. All advanced linking, tilting, and collision avoidance strategies that are there in simultaneous 5-axis and generic 5-axis are available to the user in multi-axis drilling. Drill depths are automatically determined by the software, and the user can edit and change even the drill depths as and when he needs to do. The next one in the package is contour 5-axis machining. This basically is a robust engine for machining only curves. You don't need to, the user doesn't need to define any kind of surfaces. Nothing of that is needed. He can just pick the edges, and no surface input is needed. And all he needs to do is pick the edges and input some lines for creating the tool orientation, and the tool path is created. Now the application here could be for chamfering, for deburring, for trimming, different kinds of parts where this technology is very useful. And we support different cutters, whether they are ball nose, flatten mill, bull nose, chamfer tools, taper tools, any kind of tools that are supported inside the contour 5-axis machining. We recently introduced, like a couple of years back, a technology called geodesic machining. Geodesic here means SolidCAM provides a new next generation evolution in field of the pattern generation. So pattern generation is taken care by this engine. And what happens in geodesic is it uses a global field. That means if I define a step over distance as, let's say, 1 millimeter, irrespective of how the surface is and from which direction the machining is happening, that 1 millimeter is maintained looking normal to the surface at any given point of time. So it maintains a consistent distance between two cuts everywhere all along multiple surfaces. So that's the whole idea about geodesic machining. It works on mesh data as well as surface groups. So you can give the entire model, or you could give a portion of the model as a group of surfaces, and it will still machine it. We also introduced last year Auto 3+2 roughing, which is a very, very powerful module that uses the turbo HSR and creates its own directions. The machining can here be done by automatic, semi-automatic, and manual method. In automatic, the software finds the directions automatically by itself, including the start direction. Whereas in semi-automatic, initial direction will have to be provided by the user. Once that is provided, the remaining directions are taken care automatically by SolidCAM. And in the manual input, the user specifies all the directions from which it needs to machine, and SolidCAM creates the toolpath automatically. One of the most critical applications for Auto 3+2 is right in front of you on the screen. It's a Pelton wheel. In a Pelton wheel, it's really very difficult to identify which is going to be your direction, how much material it needs to remove, and where it needs to remove, because there is absolutely no way a user can pinpoint at an area unless he looks at the simulation very carefully. This is completely taken out, and this particular part, for example, what you're seeing is about 500 millimeter in diameter, and this particular Auto 3+2 roughing took about less than 45 seconds to create in SolidCAM 2022. Remember that in SolidCAM 2022, turbo HSR is about 3 to 4 times faster, so that effect is also seen here in Auto 3+2 roughing. And it detects the directions automatically, it detects the stock automatically, and it detects also the boundaries in which it needs to machine automatically. So most of the thing is done automatically by the Auto 3+2 roughing. Within the generic 4 and 5 axis milling, we also have support for the circle end mills, which are the new generation tools which more and more tool manufacturers are introducing as their new product line. Manufacturers today promise or claim at least 90% reduction in their machining time when using circle end mills. That's primarily because you have a large radius on the side and you end up using big step overs to generate the same scallop that you would generate using a very small step over with the ball nose tool. So that's how the time of machining comes down dramatically. SolidCAM introduced this circle end mills way back in 2019, and we have already almost progressed in every version, and we'll talk about it in our later slides. We support the barrel shape, the lens form, the oval shape, as well as the taper form tools in circle end mills. Next, we have, apart from generic 5-axis, 4 and 5 axis, we have multi-axis machining, which includes multi-axis roughing. So this operation creates a multi-axis roughing toolpath that can be used for either roughing or even finishing of pocket-shaped geometries in full 5-axis. So you can see the examples right on the screen and where you would possibly apply this solution. In the multi-axis finishing toolpath, the user has to specify the floor and the wall, and the toolpaths are created automatically by the software. We also have a possibility to define or decide or give an adaptive roughing feature in full 5-axis. The wall and floor finishing toolpaths, they use the new generation barrel tools, and also they can use ball nose, bull nose, or flattened mill for generating the toolpath. Now, there's something new that we introduced in 2022 is total automation of wall and floor finishing using barrel tools. For example, the part that you see on the screen, the wall and floor finishing has been done automatically just by selecting the surface and not defining anything else. Just select the surface, pick the tool, pick the step over or down step you need, and that's it. Everything else is handled by SolidCAM automatically. It machines all the walls and floors by the step over that you have defined, calculating what is going to be the most optimum tilt angle to allow the barrel shape or the lens shape to be in contact with the floor or wall accordingly. The collision checking, as usual, happens automatically in the background, and you get safe, efficient, and collision-free toolpaths in multi-axis machining. Next, we have a very powerful module for machining impellers and blisks, and we call it multi-blade machining module. This particular module is a very powerful engine. It's used for machining blisks, impellers, and components that are very similar to impellers, including rotors. If you look at the, let's say, the marine industry, there are rotors. The rotors can also be machined using multi-blade machining module. The classic application, of course, is impellers with splitters. Minimum inputs, just define the tool, pick the geometry, define the depth of cut, side step, and you have the tool path. So you don't need to define anything more than that. And more often than like, this particular module is very, very popular with users who have just begun programming in 5-axis. Tool axis control is completely automatic. Root fillets are handled with ease, because the problems in 5-axis is, of course, whenever there are fillets at the bottom. That's where all the complexity arises, but this is handled with ease inside SolidCAM's multi-blade machining. We have separate strategies for doing roughing, we have separate strategies for doing wall finishing, separate strategy for doing the root finishing, as well as the hub finishing. We have port machining, the next one. It's a powerful engine for machining engine ports and tube kind of components. Minimum inputs, because it's an application-specific toolpath calculation engine. Automatic tool axis control, no need for the user to define any geometry or supporting geometries. The tool axis is handled directly by SolidCAM automatically. And we have separate strategies for roughing, rest roughing, spiral finishing, and plunge finishing strategies. These all are available in port machining. The output can be, unlike multi-blade, the output here can be in 4 and 5 axis. So you can choose in which axis you need the output, and you'll get the output in that format. Next, we move to rotary machining. Here we have rotary machining that generates 4-axis rotary roughing and finishing toolpaths on any solid model. It need not be a screw. It can be any kind of part that rotates around an axis, and rotary machining will handle this particular part. It'll do roughing as well as finishing of that part in 4-axis. We support 3 different types of tools in this: bullnose, ball nose, and end mill. And it works like 3-axis roughing. In fact, we are using the Turbo HSR functionality in this. However, the slicing in Turbo HSR in 3-axis is done in planar space, whereas in rotary roughing, it is done in cylindrical space and not one directional. The user just selects the part and the stock and can rough the entire part in just single operation. Linking, collision checking is automatically done in SolidCAM rotary. What we introduced in 2022 in rotary is you could now do, instead of just plain 4-axis, you could do 4+1, which means that if you have a floor and the floor is tapered, you can align the tool axis to the floor, or you can make the tool axis normal to the floor, and it can machine the entire part in 4+1 axis. Next is the edge breaking, which is a very, very powerful functionality for deburring the entire part after the machining has been performed. There are many edges or non-tangent outer surface topologies you'll find burr caused by the tool when it's doing the machining, and this burr needs to be removed, because if you don't remove the burr, the part doesn't pass the inspection or QA. SolidCAM edge breaking toolpath engine automatically detects these edges and creates a deburring toolpath. And this deburring toolpath can be done in simple 3-axis, it could be done in 3+1, it could be done in 4-axis, it could be done with 5-axis minimum tilting, as well as full 5-axis. Currently, if you don't have edge breaking, this process can actually take the same amount of time that you took to program the part completely. So it's a very, very manual and a laborious process. And with edge breaking, the whole programming time can come down to few seconds. If not minutes, it will be few seconds of programming time with edge breaking. What do we have new in 2022? We are supporting, earlier in 2021, we were only supporting ball nose tools. Now we support a host of tools. We support end mills, we support ball nose, we support taper mills, we support taper ball nose, lollipop, and chamfer mills. All of these tools are now supported inside edge breaking in 2022. We have edge trimming, and this particular toolpath engine is used for machining the outer periphery of a part, whether it is a composite aerospace part or it's a vacuum form part for automotive. All these parts, after their forming operation is done, they need to be trimmed to get to their exact shape, and edge trimming does exactly that. It's a very powerful engine, and it's a highly automated engine for creating the edge trimming toolpath. The trimming edge is automatically defined, or the user has a possibility to pick the trimming edges himself manually. And the position of the tool is relative to the geometry and can be defined by various options. So you get the output from a simple 3-axis output to the most complex 5-axis output with different tool axis orientation in edge trimming. So if I summarize our entire bouquet of offerings in simultaneous 5-axis, we have got a complete solution to machine any part in 4 and 5-axis. It's really tested. It's been around for the last 15 to 20 years. It's a highly proven 4 and 5-axis engine. It's easy to learn with a very intuitive GUI. It drives the user to pick the geometries, put in the parameters, and calculate the toolpath, including gout check, collision check, and other things. Users, experienced users, will love it because they have got complete control over all aspects of toolpath. The generic, they have got complete control. And a complete control over collision avoidance. They can change the tool axis. Once there is a collision, they can automatically change the tool axis to avoid the collisions in the part. And then we have the application-specific simultaneous 5-axis strategies for machining impellers, ports, rotary components, aerostructures, die molds. All of these are really automated functions in simultaneous 5-axis that require minimum user input. So they are very, very popular with people who have relatively very less experience programming 5-axis parts. So we cater to both of them. We cater to the most experienced user, and we also cater to the not so most experienced user in the CAM programming world. Edge deburring and trimming add value to the complete offering. So they complete the entire bouquet of offering that we have for simultaneous 5-axis. Now, in order to simplify this whole concept of 5-axis, we created a new packaging system in SolidCAM. And this is the simultaneous 5-axis packaging, wherein we have got 3 packages. We have got SolidCAM simultaneous 5-axis standard, SolidCAM 5-axis professional, and SolidCAM 5-axis premium. I'll explain to you what each of these bundles have. So with standard, we have got the generic 4 and 5-axis, which is a full-blown 5-axis solution that can machine any kind of part. We have got 3 to 5-axis conversion, which converts 3-axis toolpaths of HSM and turbo HSM to 5-axis, multi-axis drilling, 5-axis swarf, 5-axis contour, rotary finishing for 4-axis, geodesic machining, and the Auto 3+2. All of these are added as a part of the 5-axis standard bundle. So if you buy 5-axis standard bundle in SolidCAM, you get all of these. The summary of 5-axis standard, it's an excellent solution for machining any part. I mean, with the generic, you can do any part. There is no limitation on the kind of parts or complexity of part that can be handled by the generic 4 and 5-axis machining. It's a very good solution for advanced users. It has got complete control over the entire process. And this is what is the 5-axis standard. Next, we go to simultaneous 5-axis professional package. It has got everything what standard has to offer, plus it has got multi-axis machining, roughing as well as finishing using the barrel tools, the automated functions. They're there in multi-axis machining. It has got rotary machining. It has got edge breaking and edge trimming. All of these functions plus the 5-axis standard constitutes 5-axis professional. If I have to summarize what is 5-axis professional, it's a complete power of SolidCAM standard simultaneous 5-axis package with complete control and with a certain degree of automation, because we have got edge breaking and edge trimming, which are automation, rotary machining, also an automated one, multi-axis machining, certain degree of user control as well as automation. So we have got complete control with the generic, and we have got certain degree of automation with the other toolpath strategies that I just talked about. Good for 80% of the customers. It really addresses a large segment of the market. Next, we move to SolidCAM 5-axis Premium, and SolidCAM 5-axis Premium essentially is 5-axis professional, which of course also includes standard, with multi-blade machining and port machining. So it includes both of these very high-end strategies that are there for machining impellers, blisks, and ports and tube parts, along with all that you have just seen in the 5-axis professional package. It's an ultimate solution for simultaneous 5-axis machining. It has got a perfect mix of complete control and great automation. So you have got generic with complete control, and then we have automated strategies like multi-blade port, rotary, multi-axis machining, edge breaking. These are all almost automated solutions for doing 5-axis machining. It's good for all the 100% customers, and it addresses the entire 5-axis segment. We have not left out even a single area of 5-axis that we do not address. We address the entire solution of 5-axis. Apart from selling the 3 standard packages, we also have the hybrid approach in which the user can pick whatever he wants. Let's assume the user wants only edge breaking. So he doesn't have to buy standard, he doesn't have to buy premium or professional, he just buys edge breaking and that's it. He adds it to his 3-axis bundle and he's done with it. So that's why we also have the hybrid approach in which we have got all the standard packages and also all the automation packages that we have inside SolidCAM. So of course, the hybrid approach may not be useful for everybody, but I believe the packages that we have created, the standard, professional, and premium, are really going to be exciting for all our resellers and customers. And they can pick and choose what they want, or they could go back to the hybrid approach for selecting the 5-axis solution. Right. Thank you very much for watching, and it was really nice interacting with you. Thank you.
Thank you, Almut. 3 questions have come in from the users, from the attendees, I mean. The first question is SolidCAM more flexible or more automated in its approach to simultaneous 5-axis milling?
That's a very good question, Linda. SolidCAM is in a unique position to offer a right mix of flexibility and automation. Experienced users will love the control SolidCAM provides on every aspect of simultaneous 5-axis milling, while the relatively new user will love the automation and power of the application-based Sim5X toolpaths. SolidCAM offers everything both for the most experienced CNC programmer as well as not so experienced CNC programmer.
Thank you, Almut. And now the second question. Since you said SolidCAM also caters to less experienced programmers in simultaneous 5-axis, how does SolidCAM ensure that the toolpaths are safe?
I'll explain that. The collision check in SolidCAM's application-based strategies is totally automated. The user might forget about it, but SolidCAM will not. The collision checking is done automatically by SolidCAM and thus providing collision-free and safe toolpaths. Plus, the integrated machine simulation ensures further visual checking of the toolpaths with a realistic simulation of the entire part, the fixtures, and the machine components. Starting with SolidCAM 2021, we are also having an integration with Simco Edit Professional. Simco provides an extra layer of safety by checking the generated G-codes visually against the part, thus ensuring foolproof, collision-free, and safe toolpaths.
You know, Almut, I'm also learning a lot here. Okay, and now the third question. What are the new things in simultaneous 5-axis that the users can look forward to in SolidCAM 2022?
Sure. There are many features that we have introduced in SolidCAM 2022. Nowadays, barrel cutters are getting more and more popular due to their ability to take bigger step over and thus reduce the cycle time by almost 90%, as claimed by few cutting tool manufacturers. In SolidCAM 2022, we have introduced automated wall and floor finishing using barrel tools, where the user simply selects the wall and floor surfaces and SolidCAM will create optimum tool paths with automatic tilting to ensure that the barrel form always is in contact with the floor or the wall. Also, we have enhanced the cutter support for our edge breaking strategies, which now allow almost any type of tool to be used for edge breaking in Sim 5X. Apart from this, we have improved our calculation for the rotary machining. Rotary machining is now 3 to 4 times faster than SolidCAM 2021.
Wow. Okay, that's it. Thank you.
Since moving to iMachining, we've seen a huge improvement in tool life, along with a reduction in cycle time. Now for us, it's not about cycle time because we want quality, and iMachining toolpaths give us that. We also find that the adaptive profiles mean that we don't have as many accidents on the machine, which is also hugely important. Now 3D iMachining is an absolute revelation. Those toolpaths with a one-click button, absolutely easy. When I'm using it, I always use iMachining as much as I can. It's just simple and it works.
Welcome to the MTD Technical Corner. Today we're going to be looking at 5th axis solutions from SolidCAM, and I'm joined by Ben. Ben, welcome to the MTD Technical Corner.
Thank you.
Ben, great subject, and I'm looking forward to get into this and dive into this technically. But what has driven the evolution of CAM for 5th axis machining solutions?
So if we start from the beginning with 5-axis, you've got 3+2, 4+1, right up into simultaneous 5-axis. So the key driving point really is the complexity of parts being designed in CAD systems, so like your SolidWorks and Inventor. The more complex the part becomes, the more need there is for a 5-axis machine. So even in 3+2, you're cutting down setups, so from 3-axis machine onto a 5-axis machine, you can do it in 2 ops rather than maybe 5, 6 operations. Right then up into simultaneous 5-axis, where the complexity of the part demands the more complicated tool paths, as you can see here with the barrel cutting.
I mean, with an application like this, Ben, it's safe to say it would be pretty much impossible to program this by hand.
Yeah, especially in the timescales as well that we can program it. So you may be able to create the toolpath manually, but yeah, far easier using CAM software, driving directly off the model from the CAD system.
So simplification of programming parts such as this, how is this achieved from SolidCAM?
So SolidCAM has a nice, easy to use interface. Right up to the complexity of 5-axis. So if you're already a SolidCAM user, for instance, you already know how to do the 2.5D profiling, things like that. Up into 5-axis simultaneous, it's the same window, same graphical interface, exactly the same usage inside SolidCAM. So it's then just a matter of deciding what surfaces you're going to use, what tooling to use, and you can generate the toolpaths pretty easily.
With the SolidCAM package, as you're saying, you're kind of growing into a package such as this from 3-axis machining. Is this quite common?
Yeah, so you've got customers where they've already got SolidCAM, they've already got 3-axis machines or simplified machines. They may then venture into getting a more complicated machine, and we can just grow with that customer, adding on the necessary modules that they need.
Now, we're looking at this application again, and this looks like barrel cutting to me.
Yeah.
What advantages do you get from programming a part like this with a barrel cutting tool?
Well, the initial advantage and the most common advantage really is the step down and the time saving over using a ball mill tool. You can see here on this cutter, using a 2mm step down on the semi-finish and then a 1mm step down on the finishing cut gives us a nice surface finish. As opposed to on the ball nose, you're probably looking at 0.1 step over on there. So already you're at 90% cycle time savings just from the step downs.
90%?
Yeah, and then the other advantage then of a barrel cutter is keeping the tool nice and short, so we can It's not just for curved faces. You can see on this component here, we actually barrel cut the lower face on here because the access using a straight tool is not, you know, you just can't get in there. So use the barrel cutter to create that flat face as well as creating this sort of nice.
So this is really important feature there, because then you're not getting the vibration that you would have done if you're using a longer tool.
Correct.
Is that correct?
Yeah, so if we was using this on here, we'd be at 90 degrees, the table would be in the way as the head's coming down, you'd have a nice long tool stuck out trying to machine across here, whereas we have the barrel tool, which means we can tip up like this and have the contact point on there and still produce a nice surface finish.
So we're touching on barrel tools, but there's lots of different tools such as lens tools that you can use. Can you explain in a little bit more detail of the kind of applications you use with these tools and what that tool means?
Yeah, so a lens tool is part of the barrel family, but the actual convex of the tool is on the bottom of the tool. So whereas you would have a ball nose, say for instance you'd have a 12 diameter shank, 12 diameter ball nose, yeah, you may have a step over of 0.1 to create a finish on there. With the same size tool, so 12mm, you can have a lens tool on the bottom, so maybe 25 diameter, 25 radius, sorry, on the bottom, which is effectively a 50 diameter ball nose. So you can then use that for 3-axis work. So you could generate this shape here in 3-axis. So barrel cutters are not all about 5-axis. You can use them in 3-axis machines as well.
Like you mentioned, 3+2, 4+1, or 4 simultaneous, and some of these demos that we can see on the screen here kind of highlight that you can actually machine any complex component using your CAM packages.
Yeah, that's correct, yeah.
Now, one thing that is really important with the complexity of the components, but not only the components, the complexity and the evolution of the technology and the machine tools, how easy is it to interface your product with a machine tool?
So that's where the post-processors would come in. So we write and develop all the post-processors in the UK locally. So they're all done by us at our technology centre in Barnsley. We would go out on site, test the post-processors, make sure everything's working correctly so that when the code comes out of SolidCAM, it's in the machine and it's ready to run. There should be no manual edits between CAM and the machine.
So you're reducing any potential downtime.
Correct.
Simplifying the programming.
Yes.
And making it easy, I suppose, for people working within the organisation.
Yeah, that's correct. You sort of you're creating that standard as well. So you've not got two people programming in a different style. We create the same code for different machines on the same machine, different jobs, and everybody can read that code, use that code.
So employees, programmers within an organisation, you're standardising the programming within that organisation, and what kind of benefits would you get from that?
So the benefits from that is obviously everybody can move around machines, everybody can look at that code on different machines, see the same, see it in the same style, the same layout. You've also got different jobs obviously being done with the same tool paths, the same strategies as well.
So Ben, there doesn't seem to be any limits with your solutions and CAM solutions that you offer, but the product is one thing, but what about the technical support that you can offer?
So that extends on from the post-processors being locally supported. Technical support again is all local, it's all run from the technology centre. We've got the engineers there ready to assist with any programming, any issues that they may have with using the software, straight into an engineer and get the response they need straight away, carry on running the machines.
So you practice what you preach?
Correct, yeah. We've got the technology centre where we've got machines in the technology centre to prove the capabilities and what we can do. We have open days and open houses there. Anybody's welcome to come and have a look at the technology centre at any time. We'll show them the functionality, we'll show them exactly what we can do.
So for any existing Fifth Axis users or any new Fifth Axis users that have watched this Technical Corner, how should they get in touch and how can you help them?
So they could just get in touch with us, contact us by phone, email, however they prefer. We can come and do an on-site demonstration, we can come to your facility, we can prove our capabilities on your machine, on your parts.
have worked a lot with the development team on this associative coordinate system. This is an important feature that will be released in SolidCAM 2022. This feature will take SolidCAM to the next higher level of associativity to the SolidWorks model. Can you tell us more about it?
Sure thing, Linda. So, as Linda has asked about the new associative coordinate system, you know what my next presentation is about, the new associative coordinate system. But before I do that, let's first discuss why we needed to enhance our old one. Was it really inadequate? Was it missing functionality? Did we just want to give it a pretty face? Well, I can answer the first one easily. No, it was not really inadequate. It has served its purpose for many years, and we were always able to produce the coordinate system exactly where you wanted it. But as SolidCAM became more advanced and more powerful, we needed to keep up with the changes in order to accommodate our customers' needs when working with the coordinate system. This included full associativity, more flexible editing capabilities, easier to use, and more visibility. Let's take a look at the issues we needed to address. Upon creating your coordinate system, once you accepted it, that was it. It stayed in that place without any physical regard to the actual part. If the part was changed and the location origin or the angle of the coordinate direction was changed, the original coordinate system would stay in its original position. This forced you to edit the original coordinate system. And then, when it came to your coordinate system level page, there was not any option for associativity as well. And then there was also visibility. You did not have any indication of what faces or points you used to create your coordinate system or where your levels were located. Now, speaking of editing, that itself was another issue. Since you accepted the coordinate system beforehand, any slight change you wanted to do would require you to redefine the coordinate system from scratch. The list can go on and on. In the new coordinate system, we have addressed all of these issues. Issues such as associative fields, visibility, automatic origin location, and more, including some surprise enhancements we've added in our levels page of the coordinate system. We always say seeing is believing. So let's take a look and see exactly what we have done. Well, let's take a look at this part. If we take a look at this part, I'd like to create a coordinate system. Okay, no problem at all. But before I do that, let me do one more thing. Let's take a top view of this part also as well. And you may not notice, but the part is at a very, very slight angle also up. It's actually a perfect rectangle, but it's slightly at an angle. Please notice that because I want to show you something as I'm creating the coordinate system. Okay, and let's go create our coordinate system. Okay, click on coordinate system, and what you'll notice is as follows. One, every single field that we have over here is an actual associative window. When we will choose something, you'll see it light up over here as well. And also notice that we have something here called Pick Auto Location Top. What does auto location mean? If I were to click, say, on this face over here, in this area, it'll go to the closest face at the very top. Of course, I have to be in that field. Click on the face, and you'll note it'll go to the top of that corner. That doesn't mean I can't move it, but just to show that you can put it exactly, just click on that area and it'll go to that closest point. Now, before I continue, you'll note that it also jumped automatically to my pick Y direction, and it says they're automatic. You know, we have our automatic direction. But I always tell people it's a good idea to give it a direction. Why? Let's take a look for a moment at the top view, and you'll see that the box that was created around it is slightly at an angle. Because remember I told you in the beginning, the part itself was at an angle. So people may not notice this, but therefore it's always good to give an actual X direction. So when I give the X direction, I can actually just click on the face itself. I don't have to pick a point. I can pick the whole face. And the X direction will move towards there. If I put the top view in again, you'll see everything straightened up. Now, what else do we see over here? First of all, you see what I picked over here. It's visible. That's what I talked about, visibility. You can see it's an associative field. You can see that my X direction face is also associative, and you see that as well. Now, you'll see that it automatically went in my modify origin area, that my origin is at the automatic point. If I want, for example, I want to move my XY origin to the center of this. I'll just click on this cylinder over here, and you'll see it will automatically jump to the center of that cylinder. Now, we've added another nice little feature, is something called, if I go down at the bottom, you'll see my Z level is also automatic. I can actually pick a Z level, not modify it to go up or down to a value that I don't know. So if I go in here and click, say I wanted to put it over on this surface over here, just click on that surface, and you see it'll automatically go down to that surface. When we actually put it on the top of the part, we can have it over there. But you know, for this demonstration, I want to keep it down at the bottom. Not that I may necessarily want to work that way, but I'm going to keep it down at the bottom. So click in there, and it's back at the bottom. Okay, I'll accept this. Now we're going to go off, and it takes us to our levels page. Now, you'll also note that in our levels page, every single one of these fields are associative, and it has a delta value as well. So, for example, if I want my tool start level, if I want to make sure it's associative, I'll pick this as my tool top start level, and I'll just give it a delta value, say 100 millimeters, okay? My clearance level, I want it also from there, I want it to go up to a total of, you know what, leave it at 50 millimeters. I'm going to have that at clearance level at 25 millimeters from there. My upper level, again, on top over there, I'm not going to use for delta that. That's my actual upper level. And my part lower level, I'm just going to pick this point over here. And you can see part lower level is associative as well, and I'll give that a delta of -6, let's say for the excess material, okay? I can do my tool Z level as well. I'm just going to leave it for now. Now, when I accept this, let's take a look at my coordinate system manager at the top side. You'll see that all of the associative fields show up over here. What does that mean? If I click on any of them, you'll see exactly what my upper level is, what I use as my upper level, and if there's a delta value that I added to it, you'll see it over here as well. Clearance level, same thing. Upper level, no delta level to that. You see the upper level over there. And my lower level, you can see the point over there that I picked with the delta value there as well. I'll just accept that. And I have my coordinate system created. Now, let's make a little change to the part, okay? I'm going to open up this part. Let's do two different changes. I'm going to do one at a time. I'll open up the part, and I'm going to say that, you know what, this over here is right now 20 millimeters. The height of it is actually 20 millimeters. I'm going to make it 10 millimeters, okay? Let's just save that. And when we go back, you'll see that my coordinate system manager is showing that it needs to be synchronized as well as my target. So I'll just right-click and synchronize. And if I go into my coordinate system manager and do edit, you'll see that my values changed over here. And everything's associative, exactly the way it was before, okay? Now, by the way, since I'm here already, let's do another edit. Let's do edit coordinate system. Remember I talked about edit coordinate system, how you don't have to create it? If I want to make any changes, I can go over here and make any changes I want. For example, all I want to do is change my Z level. I don't have to create anything from new. I'll just create my Z level up on top of the part. Accept that. Everything updates here as well. And that's done. Now, I'm going to do one more change, okay? Let's just go out of here. The change that I'd like to do after I open the part is as follows. You see this cylinder over here? I want to change the location of that cylinder. Right now, it's 25 millimeters from this face. I want to make it 28 millimeters, okay? You can see that that jumped over. Let's exit and save this, obviously. And now I'm going to put the part in my top view. You can see right now, it has to be synchronized, but note, my coordinate system is still at its old location. But when I click on synchronize, you can see my coordinate system will automatically update itself to the proper position. So as you can see, editing was made a lot easier. Obviously, if I do toolpaths, they will be also updated as well. So let's go back and let's summarize what I've done over here. We now have full associativity. Visibility is complete, both on the part and in the selection fields. Editing the coordinate system location is exactly that. Edit and not create from scratch. These were just some of the highlights in SolidCAM 2022 new coordinate system.
Thank you, Sidney.
You're very welcome.
3 questions have come in also for this presentation.
Okay, go ahead.
Okay.
Let's see if I can answer them.
Right. So the first question is, how can you ensure that your clearance level will all be above the part and clamps if there is a change in the upper level of the part?
Okay. Well, that's actually very easy. If you remember, I showed you that all the level fields are associative, and they have a delta field as well. All you need to do is click on the top of your clamp, for example, and just give the clearance value you want above that in your delta field. This way, if there's any changes, the levels will automatically synchronize and the information will be updated.
Perfect. Okay. The second question is, I understand that the associative face you pick in the levels are visible. How are the delta fields visible?
Okay, that's, again, a good question. When you are in the coordinate system manager, you'll note that under every position you created, the associative levels will be a branch of that position. When you click on the level with your mouse, it will show you the associative face or point, and it will also show you on the screen the actual delta levels with its value. This is actually very helpful.
Okay. And the last question is, one issue that was always pain was editing. I saw that you touched a bit on that subject. Can you explain exactly what you do so that you do not need to create the coordinate system from scratch?
Okay, this was actually always a very painful issue. So I have no problem explaining that, because actually it's a very, very strong point. Well, in the past, as we never were able to track the way we created the coordinate system, so you were not able to save all that information. What we have done now is that you create it with a certain order. That is something that we can save in our database. So when you go back to edit the position, all we do is recall exactly what you did, and all those fields are open for you for a quick and easy editing. I know it makes my life a lot easier.
You know, Sidney, that's why they used to call you the SolidCAM professor. You know how to explain things.
All right, thank you very much.
Thank you.
All right, and again, thank you for joining us in my presentation. Take care and enjoy the rest of the presentations.
Linda, I must tell you, this is an absolutely fascinating summit. I am enjoying it very much. But now comes my favorite part, acknowledging our best resellers for their efforts and dedication for year 2021. But before we give out these awards, I would like to take this opportunity to say a few words about my work with resellers in the past few years. Working with resellers is both challenging and rewarding in so many ways, and it is always exciting for me to give out these awards, as we are a part of their success and they are a part of ours. You know, we work hard behind the scenes to make sure that SolidCAM delivers the best solution to fit our customers' needs. And then it is our partners' job to sell and then deliver the best support to their customers. It is a joint venture with a joint goal to make your SolidCAM business successful and profitable, and obviously to make SolidCAM customers happy and also profitable. So, Linda, should we start?
Yes, definitely. I also want to take this opportunity to say a few words before we start. When Emilia and I first founded SolidCAM, one of the most important things we did throughout the years is to establish these partnerships. SolidCAM was just starting, and these resellers took the first steps with SolidCAM, and they built their success step by step with SolidCAM. And today, together we are strong, and we are on a mission to implement SolidCAM at every CNC machine shop worldwide.
Absolutely. So the first award I want to give is to one of the best teams worldwide. They work hard, they work strong, they never stop expanding their great operation, and they reach exceptional sales of 12 million euros in year 2021.
Wow.
So this award goes to SolidCAM GmbH. I want to congratulate the entire SolidCAM GmbH team and management for their efforts and hard work.
Congratulations to our SolidCAM GmbH team. Germany is our major market worldwide, with 75 staff and 7 offices. SolidCAM is a leading CAM brand in Germany today, with Michael Leditsky and Dirk Klinge. Excellent leadership. They have a very strong sales, technical, and post-support operation that is unstoppable.
Absolutely.
I wish the entire SolidCAM GmbH team to keep the push and achieve all success in 2022.
Yes. And now, our second award goes to the reseller. Do you hear this, Linda? With the best subscription rate worldwide of 80%. SolidCAM US! Woo! I want to congratulate our US team for achieving this great subscription rate of 80%. I have no doubt that the excellent support that is given to our customers in the US is an important contributor to this achievement, and I wish the US team great success in year 2022.
Congratulations to the US team. The bottle popped by itself, which means subscription is very important.
Exactly.
And this year, we're going to work closely with all our teams to significantly increase our worldwide subs rate. We have so much exciting new functionalities coming up for our customers under subscription that I hope this year we will reach a worldwide record in subscription.
You bet! We are so excited about our new solid metal platform that will provide our customers with a great venue to connect to CNC job buyers worldwide on condition they're on subscription and on iMachining. Okay, so we continue. Linda, I have a riddle for you. Are you ready?
Sure, bring it on.
Okay, so here are a few hints. We love it. We are proud of it because it revolutionized the manufacturing world. Our customers love it because it saves them machining cycle time and prolongs dramatically their tool life. And on top of that, it has a brilliant technology wizard that is equal to someone with decades of experience in metal machining, standing right by you. Are you starting to have a clue?
This is an easy one. SolidCAM iMachining. You know, every time I hear another success story coming from one of our happy customers who are using iMachining, it makes me so happy to know that we are making the iMachining process so much more efficient and productive. And the wizard is a game changer, where it automatically calculates for you the optimum feeds and speeds for any stock material. cutting tool and CNC machine. I wish I had such a wizard in every area in my life.
Exactly. So I think you know what's our next award. And the award for the highest iMachining 2D, 3D rate goes again to SolidCAM US. Congratulations to our amazing US team.
Best congratulations and keep up the great work.
And now we continue to our next award, which goes to a team that leveraged our Swiss type solution advantage and sold the highest number of seats in 2021. Congratulations to SolidCAM Ltd for selling the most Swiss type new seats.
Congratulations to our SolidCAM Limited team. And I also want to take this opportunity to thank Zvika Friedemann, our SolidCAM Ltd sales manager, Michael Vinetsky, the architect behind our amazing mill turn and Swiss solution, and Dimitri Pitkin, our Swiss type application expert, for their great efforts in supporting our Swiss type customers. We have today the best solution in advanced multi-channel mill turn and Swiss imported domain. And this is the time that are all of our partners to take advantage of this great opportunity.
Absolutely. You know, SolidCAM Ltd is the solid proof on how hiring a Swiss type specialist can be a determining factor of your success.
Right.
So thank you, Dimitri, for your great contribution for expanding our Swiss type customer base. Okay, and now we continue to the second best reseller of Swiss type sales for 2021, and the award goes to SolidCAM UK. Great achievement for our SolidCAM UK team led by Gordon Drysdale and Mark Stocks.
Wow, truly a great achievement for SolidCAM UK. Although I must say I'm not surprised. Gordon is always first to see a great opportunity and immediately act. Hiring 2 dedicated Swiss type post specialists absolutely paid off. And now our sales team with the 3rd best type sales for 21 is SolidCAM US.
They did it again. Wow, our US team should clear up some room to put all their awards this year. SolidCAM US, led by Sean Yamudis and his great team, are making great efforts to make a strong footprint in the US CAM market. And you know, their sales grew by 40% in 2021. Okay, and now we have reached the 5 top resellers for year 2021. They worked hard. They made endless SolidCAM demos, worked long hours to support their customers, and they finished off as the best 5 worldwide resellers in total sales.
I cannot wait to hear who they are. It's always amazing to me when I think how we grow our channel sales, and we have 7 branches, 9 affiliates, and 65 resellers worldwide. We are right now on the right path to conquer the worldwide CAM market.
Yes, absolutely. And unlike in the past where Emil had to go on a plane to travel the world and recruit new resellers, with our strong brand name and product today, we have companies from all over the world reaching out to us to sell SolidCAM. That's a great feeling. So, without further ado, let's start. The reseller who reached the 5th place for sales in 2021 is SolidCAM CZ. Congratulations to the excellent SolidCAM CZ team led by Ivan Zimmer.
Wow. We want to thank SolidCAM CZ for their efforts and dedication, and congratulations for your achievements in sales. Okay, so now we're up to the 4th place. And the reseller that reached the 4th place in sales for year 2021 is SolidCAM DOO Slovenia. Congratulations to Jerne and all his amazing SolidCAM team for this excellent achievement, considering that Slovenia has a population of only 2 million.
Amazing. Okay, so the tension builds up. We continue to our 3rd place. And the reseller who reached the 3rd place of SolidCAM sales in 2021 is DPS Germany.
Wow.
DPS has been working with us for 19 years since 2003. And we look forward to many more years of such a successful cooperation. DPS has many offices and a strong sales and support team. Congratulations to the DPS team for their excellent achievement.
Okay, So now we have a second place, and the reseller who reached the second place for best sales in 2021 goes to Tactics Japan. Tactics has been working with SolidCAM for 22 years in the important Japanese market. They have 10 branches, a major technological center, and a strong sales and support team.
Wow. Congratulations to Tactics, and keep the push for year 2022. You have started very powerfully. And how exciting, Linda. We have reached the #1 best reseller for year 2021. Let me tell you, you can take the champagne because they worked hard. They are determined to give the best SolidCAM support. They consistently increase their SolidCAM sales, and they have a great leader who is always ready for the next challenge. And the winners are Tekias Turkey.
Congratulations to Ilker Uludag and to the Tekia SolidCAM team, the winners for Best Reseller for year 2021. Tekias has been working with us for nearly 20 years, and with their network of sub-resellers, they have captured the CAM market in Turkey for their SolidWorks for SolidCAM solution. Turkey provides today a major CNC industrial market with a big potential for the SolidCAM product.
Good achievement. So, this was our last award for 2021. I have to say, it was exciting to acknowledge the efforts and successes of our partners. Together we make the best team. Thank you all for being part of our SolidCAM dream. And
now is the time to drink champagne.
Absolutely.
Thank you. Oh,
we wish all of you best of luck in year 2022. And always remember, yes, we can. Cheers.
Cheers.
Merhaba, adım Ersin Uzunoğlu. Robust Otomasyon firmasında SolidCAM operatörü olarak çalışmaktayım. 2013 yılında SolidCAM çalışmaya başladık. Tezgahımız eski olduğu için işlerimiz biraz yavaş ilerliyordu. Buna ilave olarak iMachining gibi yerimize kattık. İşlerimiz bayağı bir hızlandı. Fakat tezgahımız eski olduğu için de çoklu bağlamalarımızdan dolayı hassasiyetleri yakalayamadık. Yeni olarak ilave 5 eksenli bir CNC aldık ve SolidCAM 5 eksen modülüyle buna devam ettik. Simülasyon kısmını da bünyemize kattık. İşlerimiz daha güvenli, daha hızlı ve minimum bağlamayla çözüyoruz. Teşekkürler SolidCAM.
Welcome to the MTD Technical Corner. Today we're technically reviewing CAM with Gordon. Welcome to the MTD studio, Gordon.
Hi Gio, nice to see you again.
It's great to have you here, Gordon. Now, Gordon, CAM is such an important part of the engineering process nowadays, more important than ever. I'm going to put you on the spot a little bit to start off with. Okay. Why would people want to buy SolidCAM?
It's a very good question, Gio. SolidCAM is fully integrated, and that means it's fully embedded within the top 2 CAD systems around, which typically are SolidWorks and Autodesk Inventor, albeit more often with SolidWorks. The benefit of that over, let's say, a standalone system is that with CAM that is integrated inside a mainstream system, typically they will be designing using that same mainstream system. The company then only learns one CAD interface. Also, if you pass a file from one CAD system to another CAD system, you break that link. With SolidCAM, you maintain the link. And the other benefit there is if you have change, the change is reflected automatically in the CAM part.
So these are really important aspects. And addressing the first kind of question in my intro, why is the importance of CAM greater than it's ever been?
I think nowadays machines are becoming more complicated. People are designing more complex parts because the design software has become more advanced. Therefore, they're creating more parts. not just for the sake of creating them more complicated. Quite often there are good design reasons and they can now do that. So therefore having CAM is almost vital, because some parts are so complicated that you perhaps have got no chance of writing those manually.
Now, SolidCAM is an absolutely massive organisation globally, but we're focusing on the UK in this technical corner. So what does SolidCAM offer to the UK market?
Well, in the UK market, how shall I say it? Most CAM systems tend to be pigeonholed in a particular specialist area. SolidCAM started its roots with just milling and turning. As we've become more advanced, we're now working with simultaneous 5-axis. We've got our patented iMachining for fast metal removal, and more recently, over the last 2 or 3 years, we've moved into sliding head technology. So it's not just about offering the software itself, we've also brought in specialists. So we're employing people who are specialising in 5-axis machining. We employ people that specialise in sliding head kind of activities. Therefore, they fully understand the marketplace, vital when you're talking to customers and trying to advise them the best route forward.
I mean, that's a really big point. So you've got specialists in each arena,
yeah.
And they'll go on site to kind of back up your clients and to train your potential clientele.
Yes.
And tell us about the tech centre as well, which is also open to your clients.
Well, we opened the tech centre 4 years ago now. The reason for doing that is we wanted to have partner events. To us, having partners is absolutely crucial to our business model. So we have machine tool partners, we have cutting tool partners, work holding, verification. So we can then, if you like, operate a one-stop shop with customers. Quite often we're asked to do projects work for customers. Sometimes a customer needs to deliver a project which encompasses buying a machine, buying the work holding, buying the right cutting tools and buying the right software. Working together, we're proving to the customer before they push the buttons that we can deliver what they want.
This is quite unique, isn't it, Gordon?
Yeah, I think it probably is, yeah. I don't know of any other CAM system or CAM company that has technology centre with machine tools sat inside there. And the other thing is that we make some fairly bold claims about our iMachining product. So we can bring people along and say, this is how good it is. Not just tell them how good it is, we can show it and prove that we can do what we say.
So I mean, in the other technical corners that we've done, so keep an eye out for them, you know, we're kind of illustrating that you proving what you say, and that's massive really. It installs confidence, doesn't it?
Yes.
Now, in regards to your technology, you mentioned iMachining. Is this patented technology?
Yes, it is, yes, yeah. It's
and again,
certainly unique to us.
You mentioned bold claims. What are these bold claims?
Well, the claims are that we're going to machine parts 70% and perhaps even more quicker than doing it on the traditional methods of cutting.
Well, that's absolutely massive, isn't
it?
And can anyone afford not to take advantage of that?
You'd think not, wouldn't you? You'd think not.
So I mean, by all means, you know, get yourselves down to your tech centre to prove.
But by all means, the gauntlet is down. If anyone wants to come and have us prove to them that we can deliver, we're happy to do that.
And in regards to standardising a shop floor with SolidCAM products, what advantages will they get from this?
The big advantage, as I said earlier, we can cover the whole of their machine shop, whether it be milling, mill turn, multi-axis mill turn, right through to sliding heads.
And in an era where skill levels maybe not where they should be, or as the industry is evolving with more complex components, as you've mentioned, you know, this necessity is essential, isn't it?
Well, look, I mean, in the past, people have employed skilled people, and these people tend to hold the power of the business with themselves. And you may have 2 or 3 of these people in one business. They all achieve the same goal, but do it differently. With CAM, you can use these skills and use the software as a tool to achieve a consistent approach. That means people following these people as they retire and move on. You've got the consistency of working in a standardised manner.
So the benefits that you've been talking about today are phenomenal, Gordon. It's been an absolute pleasure. SolidCAM will prove what they say, and they welcome you to their tech centre
absolutely,
at any time. Gordon, been an absolute pleasure.
Thank you, Gio.
Hello everybody. So it has been a long event. And if you are still awake and with us, now we want to summarize briefly what you have heard from our main SolidCAM experts. We say again that SolidCAM 2021 is the best CAM on the planet, seamlessly integrated and associative to SolidWorks and Inventor. Now I will ask each of our panelists about our major advantages in iMachining, in multi-channel mill turn and Swiss, and in our powerful simultaneous 5-axis solution. By the way, I want to introduce our panelists. Michael Leditsky is our SolidCAM COO Global, Anthony Calderon is our SolidCAM CTO Global, and Amod Onkar is our Country Manager, SolidCAM India. So, Anthony, remind us again and again why our iMachining is so much superior to the so-called iMachining imitators.
Thank you, Emil. So iMachining, there is no other technology that compares, whether this is volume mill, dynamic mill, adaptive roughing, profit milling, or true mill. As you can see from our slide here, iMachining is unmatched by all of these technologies. You can see there's only one competitor who holds a patent like we do, which is SurfCAM. And all of these technologies are trying to have a technological approach such as constant force, and many of them are constant step over or constant engagement angle. Only in iMachining do we get variable cutting angles, variable feed adjustments with almost every line of G-code having feed adjustments, morphed spirals to maximize the machining and the tool inside the material, and thin wall handling. We also have our technology wizard, which nobody even attempts to do. We have the shortest learning curve possible. We have the best cycle time. We have a complete process where we not only do roughing, we do rest roughing and machining and finishing all in the same process. And our first pass success is unmatched.
And this has been proven in all our benchmarks?
Absolutely, across the board, every time.
Like against which competitors?
All of our competitors listed. Every single one of our customers is always asking us, what is your difference with volume mill? And like many times in the US, we are always replacing an existing CAM tool. So all of our customers who have come to us, they all have one of the technologies listed here, and all of these customers have been shown, and they've seen the difference of how iMachining is just unmatched compared to these tools.
And I assume there are some customer success stories. Where can we find them?
Absolutely. If you go on our website and you go to SolidCAM Customer Successes, you can see successes broken down by different materials, different processes. We have hundreds of success stories. And I think the nicest thing about those success stories is when you look at the pictures, you'll see most of these pictures are done by our customers with cell phones and just simple pictures. A lot of times they do it off the cuff. They just take a picture of a part and then they send our technology guys some information, because they usually help them with the test cutting, and say, look what we've achieved. We've achieved 8 times longer tool life. We've achieved 70% cycle time, and you can go right on our website and see all of these stories.
Okay, Anthony, I hope you helped to convince some of the skeptics about the strength of iMachining.
Thank you.
We try to do it again and again for your own benefit, because we know that every SolidCAM customer who didn't get iMachining is practically losing money every day. And it's hurt us because we have this great technology, and you as a SolidCAM customer are not benefiting from it. And obviously, if you are a prospect, please rush and get SolidCAM and get iMachining. And then you'll understand how valuable it will be to your machine shop. Okay, so now Michael, tell us the story of SolidCAM at Citizen Europe.
Okay, yeah, of course. So I have to start a little bit earlier talking about Citizen. About 6 or 7 years ago, we've been in contact with Citizen, and we got the first machine in our technology center. It was a Citizen L20 ATC. After that, we got the Citizen machine at our booth. We showcased how good our solution for Swiss type machines is. Then we got a Citizen D25, and now we are getting a Citizen L20 ATC. What we heard from Citizen is whenever they are going out, for example, to a medical customer, they see SolidCAM is already in the shop. So it is easy for them to sell a Citizen machine with a certified SolidCAM cost processor, because in the future, there will be some special packages with a Citizen machine and a SolidCAM license with it. That helped us, getting more into the Swiss type segment. And of course, Citizen is benefiting from it because they can sell the machine way easier.
So it's Citizen customer who gets also SolidCAM. What's its advantage?
Well, definitely. The advantage what they have that, of course, it's certified. So it's a proved out solution. And what we offer is the best support, because it's not just about the product itself, it's about supporting it in the best possible way. We have the best software for it, the best team, and the best support.
Excellent. So now tell me more about your story with Stahl in Germany.
Actually, it's quite similar. So Stahl is also a manufacturer of Swiss type machines. And whenever they go out to a customer, they need a software that is really easy to use, that we can support in the best possible way. We established a great partnership with Stahl in Germany, also in the UK, and also in the US. So we are doing this on a global basis. Eventually, we are getting a Stahl machine soon in one of our technology centers as well.
So actually, what do you recommend, a Stahl machine or Citizen machine?
That is a really hard question. Both are really good machines, and I would say that we can control both machines in the best possible way.
Actually, it's not only Citizen and Stahl that we support. We have a big database of Swiss-type post-processors. As you see here in this slide, we also support Tsugami, DMG Mori, Nomura, Nextern, Tornos, Index, Traub, Hanwha, and many other brands. And I could tell you we have another big advantage. Even if we have a ready-made post that works very well on your machine, and you have special requests from us, we can easily customize it for you. We are the best in doing that for our customers, and customers love it because they want to see the G-code just like they like to see it. So if you have a Swiss machine, get SolidCAM and you'll be happy. Okay, Amod, let me ask you a question. You are the simultaneous 5-axis expert. What are the advantages of SolidCAM powerful simultaneous 5-axis solution?
There are quite a few, Emil. One of them is our main one, which is our CAD integration with SolidWorks. Second, because of our integration with SolidWorks, our GUI also looks and has a feel of SolidWorks, so we are super easy to use, even in the most complex situations like 5-axis. You can machine any part you like with the entire suite of applications in 5-axis that we have in SolidCAM, and you create a very collision-free toolpath. We have a realistic machine simulation, and we have a right mix of full user control for experienced users and total automation for people who just have started working with 5-axis machines. And we also support the entire suite of barrel tools with total automation inside SolidCAM.
So how do we compare to other softwares in our simultaneous 5-axis solution?
There are quite a few of them, but I would like to list about 3-4 of them. First of all, CAD integration inside SolidWorks, and I'll explain to you why. A lot of people think they do not need a CAD solution when programming in 5-axis, but that's not right. A powerful CAD system is an absolute must when you're programming a part. And I'm not here talking about impellers or port that can be easily done using the automatic functions. I'm talking of really complex parts like Pelton wheels, where you have to create a lot of supporting geometry inside the CAD and use them to machine it. So the CAD integration here becomes really very critical. The second one is we have a full range of strategies available, from Auto 3+2 roughing to generic 5-axis machining. In fact, our generic 5-axis machining can program any part in the world. And we also have automated strategies like impeller machining, port machining, multi-axis machining, which includes support of all the barrel tools, edge breaking, edge trimming. With SolidCAM's simultaneous 5-axis, we are not limited to the kind of part that we can do. We can machine any kind of part that is thrown at SolidCAM. The third one is we have the easiest of the interfaces. SolidCAM has the easiest of the programming interfaces against all our competition. Generally, people feel that 5-axis must be really very difficult to use, but that's not the case with SolidCAM. We have really very easy interface, no clutter, straightforward interface, and all the parameters are so nicely arranged in a logical manner that makes learning SolidCAM a breeze. And finally, 5-axis is all about support and post-processors. If you can't get your support and post-processors right, no matter how good your product is, it's going to be of no use. We have all these three things right in their place in SolidCAM, and this is our biggest advantage today in the CAM industry.
You are the India country manager, SolidCAM India. So tell us about happy customers in India using 5-axis, some examples.
So we have, in India, like we have 3 major regions: the northern part, the western part, and the southern part, where most of the industry is concentrated. Maximum number of our 5-axis customers are into aerospace. And I'm really proud that most of my aerospace customers do real complex parts like doors of our aircraft, some are doing the landing gears, some are doing even the seating systems. So many of my customers use 5-axis solutions to machine these parts. Some of them also do impellers. Some of them do blisks. So all of these customers use our 5-axis to machine different kind of components, right from simple frames to the most complex parts like impellers and blisks, all on SolidCAM 5-axis.
So could you say they are happy with 5-axis like they're happy with iMachining?
Absolutely. They're not only happy, but they're also making money.
Excellent. So Michael, in Germany, tell us more about your 5-axis customers.
Well, it is a little bit different than in India, but you know, we have different big companies who are doing it, but we also have the small and medium-sized machine shops who are doing 5-axis simultaneous. So they are not really experts in it. They use it maybe once a week. So we need an easy solution for them that they get the 5-axis parts done. And this is what Ahmed just mentioned. We have the easiest solution, no collisions. Our support is doing great, helping them machining those parts in an easy and reliable way.
Excellent. What about the US, Anthony?
I would say the US is actually more similar to probably Germany than in India. We do have a few customers that do aerospace style work, but generally most of them are doing 5-axis simultaneous on parts that require 1 or 2 5-axis simultaneous toolpaths. And as Michael said, the same thing there. They are spending most of their time in SolidCAM programming 2.5D and 3D toolpath, and when they need to program a few 5-axis toolpaths, they need something that's simple and easy because they're not in it all the time. And our interface and our 5-axis toolpath really is easy to use. And in the US, we do have people that are doing port machining and impellers and stuff, and the automated tools really make it fast and easy for them to program and takes away a lot of the responsibility that you have to do with other systems.
By the way, you talked before about iMachining, and I know that the rate of iMachining in the US is the highest in the world. Why is that, you think?
You know, it's hard to say, but I know from our sales in the US, as I said, everything is a replacement market. So generally, every company that is coming to us, they have CAM. And I would say the ironic thing in the US is many of them have multiple CAM systems. So the main benefit of why they generally do look at SolidCAM is because they use SolidWorks and they want tighter CAD integration. And then the second thing is probably the machining performance. And iMachining is something that just nothing else in the market competes with. So we push iMachining, we demo it to every customer, and every customer who uses it, they use it. They're using it on every part, whether they're an aerospace company or a 3D mold, it doesn't matter. They use iMachining on practically every part. And this is why our subscription rates are very high with iMachining.
They are smart. They use iMachining and they save...
Absolutely, and it's less stressful and it's just easier for them.
Increased tool life. Ahmed, how about iMachining in India? How is it going?
We are very popular. In fact, I would say that our sales skyrocketed after iMachining was introduced in India. And most of my customers, again, are focused and concentrated in the aerospace segment, although we have iMachining also in the medical as well as in the general production area. But our customers are very happy using iMachining, especially the ones that really want to make money. And when they are tight against their competition, where they would like to reduce the machining time, and get more orders from the customer, that's where they end up using iMachining. And they machine every kind of material, whether it's a soft material like aluminum or a tough and a hard material like Inconel or titanium.
Actually, I once read an interesting story from your customers in India, where you went to demonstrate iMachining to a customer who realized he needed one more machine because his existing machine didn't do enough of the job.
Yeah.
And then when he saw iMachining, he canceled the order for the extra machine.
Yeah. We are not very popular with the machine tool people as well as the cutting tool people, because in most of the cases, the amount of job the customer has is more than enough, or the machines are more than enough for the amount of jobs that they have. Sometimes a couple of machines are free because iMachining does almost all that in lesser amount of machines. Also, the tool life dramatically goes up. Therefore, they don't have to order tools every now and then. So we have this saying that we are not very popular with the machine tool and the cutting tool industry.
Actually, also, since iMachining has constant spindle force, it's good for the life of the CNC machine.
Absolutely.
It lasts longer.
Absolutely, it does.
So the customer wins from all these advantages.
Yeah, it's a win-win for the customer itself.
Michael, I saw once that a tool manufacturer in Germany created special tools only for iMachining. He even called them iMachining tools.
True.
What was that?
It was Göring, to be honest. So back in the days, we did a lot of test cuttings with the machine tool manufacturers, and we figured out that using iMachining helps them convincing their customers about their tools. It was good for us because we could definitely get the customers of using iMachining. So it was this, how Ahmed called it, the win-win situation for them and for us. And since then, we have a really good connection to our cutting tool manufacturers. But you're right. Sometimes, the machine or the toolware is, not that high as in a typical operation. So yeah, as we said, win-win for all.
I would say when a customer sees iMachining working on a machine in a tremendous way, he does not know where this advantage is coming from the software, from the tool, or from the machine.
Yeah.
So we all benefit.
Definitely.
The software, the tool, and the machine.
Completely agreed.
People will be happy with their machine and their tools currently, and iMachining could be the main driver for this.
Correct. All right.
Okay, so to summarize, I would say this whole event, I repeat again, SolidCAM is the complete solution for your CNC machine shop. We have all the modules you need. We have iMachining 2D and 3D. Obviously, iMachining 2D if you are doing mainly only prismatic, but obviously iMachining 3D is great also for roughing of prismatic and also definitely for complex shapes. We have our HSM, HSR, and HSS for 3-axis. We have our Turbo HSM, much faster 3-axis cutting. We have our great simultaneous 5-axis solution. We talked about it. We have our best advanced mill turn and Swiss type solutions. We have our shop floor editor, Solid Pro for controlling probe on the CNC machine, and obviously our new SolidCAM simulator. So, if you get SolidCAM, the latest version, SolidCAM 2021 SP4, you will benefit from all these advantages. iMachining, advanced mill turn and Swiss, all the other modules of SolidCAM, seamlessly integrated in your favorite CAD, either SolidWorks or Inventor. Okay, so now to the final slide of this amazing summit. We say SolidCAM is the future of CAM. Why do we say that? Because simply the best way to predict the future is to create it. So we listen to you, our customers, we listen to what you need, we develop it, we give it to you, and that's how we create the future for you, our customers, because for us, the customer is the king, and as long as you are happy, we are happy. Thank you, and goodbye.